So let's go back and look at the post-service analogy that we have talked about before. And that will lead us to find out if we need more headers for IP addresses and IP packets or not. More than the source and destination IP address, I mean. So if we have John Smith, who lives in this unit number in this building in Boston, Massachusetts in the US, and this is the building address, wants to send regular mail to Sarah. She lives in unit 308 in this building, and that's a street address and so on. So John puts his address and he forgets to put his unit number. And that's a multi-story building, high rise. Sarah is the recipient, but also he doesn't know or he forgot to add her unit number. Let's assume that he forgot. So the letter gets sent, gets shipped through US Postal Service all the way to Egypt. Egypt Post will deliver it to the building, but then at the building, maybe we have 100, 200 units. We don't really know easily where to send it, which apartment, which unit. And that is why this will be a problem. And the mail will not be delivered without the unit number or the apartment address. Of course, there could be a lot of asking around, security guard, watchman, and all that until they know where Sarah is. But if not, then this is going to be shipped back to the recipient as undeliverable. Okay, but if we add the unit numbers, then there should be no problem whatsoever. And everything will be cool. The forward mail will go there and the response will be delivered as well. So similarly, we need additional headers in an IP packet to be able to precisely identify on the receiving end. There could be multiple VMs and multiple applications on the server, on the receiving server. Now, when the packet gets to the server, which application or which VM should receive it? So we need additional headers. Also, which application on the source sent the request? Was it Chrome? Was it Safari? Was it Firefox? Was it mail, email? Or was it Zoom? So on your laptop, you might be running a lot of applications. When the response comes back, which one should receive the response? They are all on the same laptop. The laptop has the same IP. But then we need to distinguish between the different units in the building. Your laptop is the building and it has many applications open. So which one should the software send it to? This tells us that we don't have enough information in the IP packet if we only confine it to the source and destination IP. Because of the fact multiple apps can be running, or multiple VMs on the server side and multiple apps on your phone or client side. So what is that header that we need? We call it the ports, the IP ports. So let's try to understand the source and destination ports a little bit more. So source and destination ports are required headers in a packet, and this is in addition to the source and destination IP address. If we look here and we try to do the analogy of an envelope, if this laptop is in Germany and it has an IP address, and this is not a private IP address, this is the public IP address, opens a browser, and now it's trying to send a request or a message or a login or whatever that is, let's say to a bank in the US or a corporate in the US. And this is the server IP address, and it is a public IP address as well. So here, the information we need at a minimum is who is the source, who is the sender as an IP address, and which application port is on this laptop that should receive the response, and where it is going, and what is the destination port, which application. In case I have multiple applications running on different virtual machines, for example, in this server, then which application port I should send it to. So when it is received, it will go to the one that is functioning or expecting communication on port 80. What is a port? We'll talk about that. So think about it as a unit, and it has a door. So each unit in a building has a door. So this is going to the door or the unit that has port 80 or has unit number 80, apartment 80. So think of ports like units in a condominium building, and this is going to be the unit number. That's what the port is. But actually it is an application port, a port that the application is listening on to find out if anyone needs to talk to it. Think about it as a local extension in a phone system inside the building. So extension number 80 should receive this message. So it gets here. Now the server knows which one should receive the communication for port 80, and it will send it to it. If this is listening on port, let's say 443, and this is listening on port 22, these are all legitimate ports, but we are going to talk about them later on. So in that case, this server, the software in this server should be able to tell which one is the port 80 application and send the traffic to it. Now, if it is to respond, what will happen? It will be from, and in this case, it will be the IP address on the server, which is this IP address, the port on the server, that's the sender now, because now we are talking about the response, port 80 on the server, and it will be going to 100.2.55.33, which is this IP address, and to which port? To the original port that sent it, which was 55,000. So now if I have multiple client softwares running here, the one or the unit number 55,000 is the one that will get it. So the others are not going to get the response by mistake. And this is exactly how, when you open your browser and you have 10 tabs open and each one is going to a different website, you will never find that the first tab, for example, is going to CNN.com. When the response comes, the page of CNN.com, you will never see it on the second or third or fourth tab. You will always get it in the right tab. Even if you are working on a different tab, you will find the data of CNN.com in the same place, in the same tab that you have opened. This is because of the ports. A quick recap. Source IP and destination IP are not enough headers to be sent with the packet. We need source port and destination port as well. All right, so let's talk now about the first model, or the main model when it comes to networking, the Open System Interconnect or interconnection, or the OSI reference model. What is that? Oh my goodness. This is not my drawing. This is the source for the drawing. But this is a 7 layers model. All right, it looks like a building to me, or at least the skeleton of a building. But what is that for? So the OSI model is just a framework, a collection of standards that breaks down how data travels across a network from the user using an application, let's say Chrome, for example, until it reaches, so if this is on this side, until it gets to the server on the other side. So from the user, from the application, the client application, through the network, through the LAN and WAN, until it gets to the other side and it is received and comprehended by the receiver. That's what the OSI layer defines. So the different layers will define things like what are the standards for cabling. So that would be the first layer. The physical layer will identify that. And what type of cables we can use, and what type of signals, and what is the standards for the optical signals, and what's the standard for the electrical signals, and what's the length of the cable, and how many wires should we use, and what type of wires should we use, what type of connectors we should use. All of that is defined as standards, such that if we bring one connector from China and one cable from Brazil, and then we get the copper wires from the US, and we get the crimping tools from Japan, or the tools that we use to make the cable, all of them are going to work without any issues. And when we connect that to hardware switches or routers that are coming from Taiwan, for example, and they're coming from Vietnam, then all of that is going to work without any issues. Why? Because everyone is following the standard. And that is why it ends up working like charm without any issues. All right. For the switches, then the second layer, the data link layer, will specify any required information and standards about the switches, like the protocols for the LAN, the protocols for wide area network, the protocols for data center, as far as switching is concerned and NIC cards are concerned. All of that is defined here. So if you bring in a laptop or a server that has a NIC card, a network interface card that you bought from China, the server is from Korea, and then you bring in the cable from Taiwan and you connect all of these and you connect it to the switch from the US, all of that is going to work without any problems. This is going to be data link layer, as it is called. So it defines the standards for switching and related. Then we have layer 3, and please note that there are 7 layers, and that's why when we say layer 1, layer 2, layer 3, layer 4, layer 7, you know what we are talking about. So when we say that a device functions at layer 7, then you should understand that it understands all the application headers and stuff like that. The most important ones that always are relevant are layer 3, layer 4, and layer 7. You need to know these like the back of your hand. What do they do? What's their function? Layer 3 is about the network, so it defines the standards for the routers, the interfaces, the routing protocols, the ping ICMP, IPsec, we'll talk about it later on for scrambling the data, IP, OSPF. A lot of things will function at this layer that have to do with routing. Then we get into the fourth one, the transport. So this is the bus that will take the data from one side and will establish a connection with the other side, and then we'll send the data down to get there. So that's the transport, the connection between the two sides that needs to be done. And this will define a lot of things that we are going to discuss: TCP, UDP, SSL, TLS. We are going to talk about all of these. Then we have session, which is controlling the communication. You are opening your browser and you're talking to the website or the e-commerce, Amazon.com, for example. So that session between your application and the other side, who's managing that, that will be the session layer. In the two sides, by the way. And then we have the presentation. So this one defines the session information and how the session should be between the two sides, how to open the sessions, how to close the sessions, what are the messages exchanged for that. This is all at the session layer. And then we have the presentation that decides how the data should look like and if there is any scrambling for security, which is called encryption. We're going to cover that later on. If it is required, then this layer will take care of that. And then we have the application layer that defines if you are working with DNS, HTTP for browsers, or HTTPS and all that stuff. All right. Each one of these layers define the standards and how the protocols or the frames or the format of the data should be at every single layer. How to establish a session, how to establish a connection between the two sides, how the network should look like, and how every one of these headers related to these services or functions will be identified in the packet, and it has to be standard across everything. And that is how the end points, they will be able to communicate without any problem. Okay, so the framework in 7 understandable steps, each one doing a specific job. That's for a successful communication from one end device, let's say my laptop, with a server in a data center. The packet, as it starts, it will start at the user. So the user will open the browser. Let's say, for example, it doesn't have to be a browser. It could be a client, Uber, for example, Uber application, or Google Maps, and going to the Google server. So the user will start whatever he is doing here or she is doing here, and that will be the payload, the data itself. So the stack of TCP or the stack of services that have to do with networks inside your laptop or her laptop or his laptop, the application layer is going to start getting that data and then deciding on what headers are going to be added and how to facilitate its access to the network. The presentation layer will look, do we need any scrambling? Do we need to add any headers that relates to that? And then the session layer will decide how the session would be and will manage the session. So these three are going to prepare the data the right way so it will be sent to the other side. If it needs scrambling, if it doesn't need scrambling, how it should look like, if there are any headers to be added, and so on. Then it gets down to the function that does the transport layer. Everything we are talking about right now is inside the laptop. So we're not going to go through layers in shelves and all that. It's all inside the laptop. So please use your imagination that there are components in the software and hardware in the laptop that are going to do these functions. Which component? Who cares? You are not the software developer right now. You are just starting. Maybe later on in the future, you will understand this very well and you will start developing to these different functions. But for now, these functions exist in every one of our devices. Even your phone, iPhone or Android, it does have all of that. This is the IP stack or the TCP IP stack inside your laptop or phone or iPad that will be doing this. Okay, now the transport layer needs to add headers. Why? Because it is the transport from here to there, to the other side. Is it directly? No, but it has to add headers so the other side will understand. Do we need to open a connection or not? Do we need to follow the sequence of each packet? So if one is missed, then I need to tell you. Do we need to have flow control? So if you're sending too much, I need to slow you down. Do we need to have extra communication basically to ensure that there is nothing missed, nothing is received in error or out of sequence, and if anything is missed, then we can talk and you can resend it again? If we need to do that, or just I will send you whatever I will send, receive it, and if we miss anything, who cares? And both of these are valid options when it gets to a transport layer. So the transport, it's going to add its own headers, the bits and pieces, and we'll deliver it. Okay, now it's time to ship it through the network. So what do we need to do? We need to give it to the layer that understands routing and understands IP addresses and understands BGP, for example, if that's required, and other stuff. So, network address translation also happens at this layer. Do we need to add headers? Of course. That header exists, and here's our original data, and now an IP header is added. Source, destination, IP addresses are added, and if anything else is needed. At the transport, this is the source port and destination port will be there as well. Goes through the switch. For the switch to deliver to the different ones in the same local area network, then probably headers are going to be added also. These are called data link or link layer or link to headers. Once this is done, it is ready now to go out on the NIC card to the network, to the local area network, and then possibly to another router or something. So it will filter down to now, if you are holding your iPhone connected through Wi-Fi, then this has to be converted into frequencies in the wireless LAN. If this was a wired copper port into a switch, then it will be converted into electrical signals to be sent through the copper wire. If it was optical cable, fiber optic cable, then it will be converted into light signals to be sent. Who is going to do that? That is the physical layer. So this path from the source, from the application until it gets to the physical layer is called encapsulation. Why is that? Because we have the data, and imagine how many times we have added things around it as if it is a capsule at the end. We are encapsulating the data. We are including the data, but adding a lot of headers around it. Now it gets as a series of binary zeros and ones, either presented as electrical signals or light signals or however. It gets to the other side. The physical layer here, it needs to do the reverse process, de-encapsulation. So the physical layer here is going to translate that into what is acceptable for the data link layer. So the data link layer will be able to read any information required for the data link and comprehend it and find out if it is for me or for someone else. Then it's going to remove layer 2 headers and it's going to pass it on to the network layer. The network layer would look at the source and destination IP, where this is going. If it is to me, I will process it. Else, if I'm a router, then I'm going to send it. If it is a router, it will end at this layer and it will not have a lot of information above. Now, if this was the server as we are showing here, then it will pass it on to the transport layer to understand, okay, was that supposed to be a connection-oriented communication or connectionless? Do we need to look at the sequencing and all that or not? Do we need to do retransmission or not if something is missing? And it understands the protocol or the port it's going to. Is it going to HTTP 80, for example, or port 80? If it is going to port 80, then it will remove each one after it does the processing. It will remove the header and will leave the headers for the layers above. If this was a router, then the router will pass it on. So we'll process the network layer, we'll look at any filtering required, and then it will pass it on to the next router or to the server at the end. But this is not our case. We're using a simple case that they are both close to each other. There are no hops or no devices in between. So now it goes up, session layer reads the information, presentation layer, and then it goes to the application layer. Now the application here will understand it, and then the application will become, for the response, it will become the sender, and here will be the receiver. So as if we are going to reverse the functions, encapsulation for the response, and then de-encapsulation at the laptop level for the response. So that's exactly how it happens. If we didn't have all the standards and we did modularize the different functionalities, the TCP/IP stack inside any device would have been a nightmare. But now, since we have broken these into functions and standards and all that, it's easy for a company, for example, to specialize in only doing the scrambling function of data, or only a deployment of a new protocol at the transport layer, for example, or a new function at the transport layer. So they can focus or zoom into a specific functionality and develop for that functionality only. So the source software will take the data from the application, flows down through the different layers to the physical layer. This is called encapsulation. And then at the receiving end, we do the opposite, which is called de-encapsulation. From the physical up is de-encapsulation. From the application down is encapsulation. Here's an example. Let's say a user is going to open a browser and needs to get to a web page on the server. So what happens? So the browser will send the HTTP request. That is a layer 7 activity, which is done by the application layer. And HTTP, and we are going to talk about this, this is a standard protocol that is defined at layer 7, will create the request. Like, for example, get for me a get request to read the HTML file of the website. So the web page of the website, simply. But this is still layer 7, and this is all happening now at whatever the browser functionality that will take care of that inside the sender or the client. Now the HTTP data is handed to TCP at layer 4, which is the transport layer, which adds a TCP header that includes. So this is the data after the browser has prepared it with session and presentation. Now it gets to transport. Transport will add the TCP header. What is TCP? We'll talk about that. It will talk about what is the source port, a random port. We'll talk about these ports later on. Destination port is going to be port 80 for HTTP. So now the transport is saying who is the source port, source application, client application, and what is the destination port on the server on the other side. This is where the port number appears. And then it goes down to layer 3 IP to add the source IP and destination IP, layer 2, and then out to the network. So hopefully this makes it clear in addition to the previous slide. What are the benefits of doing that? Standardization and interoperability. And that allows all software and hardware vendors to make products that are interoperable. It's a layered troubleshooting. When you have a problem that has to do with a network, go and look at the network. When you have a problem that has to do with ports, not allowed, traffic is blocked, then we go and look at the transport or configurations that have to do with the transport. So we can focus on specific layers while fixing problems, as opposed to if it was all one big function, then which part should we look into? It's an easier implementation of networking because it's easier to break down, understand, and work with networking components, different components. Modularity is very important as well. So it allows smaller companies or some companies to specialize in optimizing some of the functionalities or modules within the 7 layers. Let's now zoom into some of the important layers, and we'll focus on layer 7, 4, and 3, because these ones are very critical and you will deal with them a lot in your career, regardless what that is, and especially if you are into cloud engineering, network security, or network engineering. The OSI model layers, we have the application which will prepare the data as we mentioned. We have the presentation that will format and scramble or encrypt the data if required. We have the session that will start and stop the sessions to the receivers. We have the transport that will ensure the message will get to the receiver fully and in sequence if required. We have the network that will find the best path, the IP routing through the network. We have the data link layer that will add the delivery details at the switch level or the LAN level, if you will. Physical layer that will identify standards for the cables, and if it is Wi-Fi or signals that will carry the data. So this is an abbreviated definition of the function of each one of the layers. Let's zoom into layer 7, the application layer. So the application layer is the closest to the end user, of course, because we said it will be built into the browser, for example. So this is where the client sits, and that's the browser in front of him or her, and they start working on it. So this is where the users will interact with the applications, and this will provide, the application layer is not the application itself, it's a functionality within the browser that will take the data that you want. You want to go to CNN.com. So it will take that and it will translate it into how should the data look like when I want to go to CNN.com. So it will provide network services to the applications like browsers or email clients and file transfer. And it's not the application itself, but provides the services to allow the application to use the network or to work over the network. And it will handle the requests and the response operations between the sender and receiver or the user and the other side by handling the lower layers. So between the user applications and the lower layers that are available at the user side, so it can get to the other side correctly. So think of the layer 7 as the layer that will let the applications like Chrome or Outlook use the network through the laptop or the iPhone or the Android phone through the network until it gets to the right place. That's layer 7. Any device that has the intelligence of understanding what's happening in layer 7 is usually an expensive device, and it's an advanced device. Next one, we're going to discuss transport layer, layer number 4. This layer creates the end-to-end transport between the two communicating hosts, between the sender and receiver. The ports are added and interpreted or read here. So when one says I'm from port 55,000 as a source, the port will be added at the transport layer. And also where it is going, it's going to CNN.com on port 80. Then the destination port is going to be also identified here and then added in the TCP header. Then we have the third layer that we need to zoom into, which is the network layer. And as we understand, it's the IP layer basically. This is the main protocol that operates here. And it will move the data between the two hosts that are not physically connected. So it will do the routing decisions, what to do. Is it in the same network or in a different network? Do I need to send it to the router, or it will be reachable through the switch? All of that intelligence happens at this layer. And it uses the logical IP addressing. So the source and destination IP addresses are going to be added here. And we have the source port and destination port from the transport layer. Examples of what functions here also is IPsec, network address translation, and dynamic routing protocols. Hopefully that was easy to understand. The OSI layer is very, very important. And if you don't get your head around it for whatever reason, know what layer 3, layer 4, and layer 7 are for, because these ones are going to come and as bumps in your way if you don't understand them very frequently. So the OSI model that we have discussed, how is that related to the TCP/IP model? There is a model called TCP/IP. What is the relation of the OSI model also to the network devices? So for networking devices, where do they function at the OSI layer? So routers will operate at the network layer, and switches will operate at the data link layer, which is layer 2. Okay? And we'll see later on when we talk about firewalls, they could be functioning here or they could be functioning here as well. We'll talk about that later on. The TCP/IP model is also built for the same purpose. But the TCP/IP model combines these 3 layers into one layer called the application layer. And then we have the transport, we have the network, and the physical and data link layer are called the network access layer. So here we have 4 layers, here we have 7 layers. Now let's start with TCP/IP protocols. Let's understand what is a protocol and why is that important, and some common protocols that we are going to come across frequently in your career, whether it is network or anything else. So first of all, what is a protocol? A protocol is a standard set of rules. So there are a number of documented rules agreed upon. For what? In networking, for formatting and processing data that computing devices need to know how to send messages. So this set of rules or protocols agreed upon in a protocol that is known and standardized across the globe will allow the computing devices understand how they should send messages. So how to create them, which headers, what is the length of each header, which one to put before the others, which one to put after the payload, which one to use before the payload. This is the set of protocols such that developers who are creating applications that will use these protocols or need to communicate with others. For example, if someone is developing a new browser, so let's say Chrome, Safari, and Firefox, there is one that is coming up and it's much better than them. However, that browser needs to communicate with existing websites. The existing websites are using a protocol called X. That browser needs to understand the details of the X protocol and then develop according to that, such that the browser will format or create the proper format of messages. And when it receives messages as well, it will be able to understand them. And if anything goes wrong or something sent was not as per the protocol, then there should be some errors exhibited, and that should be all agreed upon. So for example, with websites, whether you know it or not, we all use HTTP and HTTPS, the hypertext transfer protocol. So that is a standard. Even if you bring an application from Taiwan, from China, developed in Vietnam, and then you use it with websites in the US, in Germany, or in India, it will work, because they are following a standard formatting of the protocol. When would the problems arise? When the format is not per the standard. Network protocols are used as a common language to enable network hosts to communicate. So the only reason we create protocols is interoperability and for the successful connection and communication between computing devices and the softwares on them, or the servers and the softwares on them. Just to give you an example, for the application layer, there are certain protocols that are widely recognized, like HTTP, HTTPS, DNS, SMTP for email, FTP for file transfer, NFS for file system, SSH for connectivity. At the presentation layer, we have the ones that deal with scrambling the data or encryption, TLS and SSL. TLS is the newer version of SSL or the successor of SSL. Then if we look at the transport layer, we'll find that we have TCP, UDP, and some functionality of the encryption or scrambling also happens here. Some documentation will tell you that encryption happens here. Some documentation will tell you that it happens here. Anyways, the recognition of the ports must happen at the transport layer. At the network layer, we have IP, Internet Protocol, ICMP, the Internet Control Message Protocol, Network Address Translation, Address Resolution Protocol, IP Security. These happen at the network layer. So these are examples. TLS and SSL, that's why we have the star here, that it has functionalities across layer 4 and layer 6, the transport and the presentation. So we mentioned TCP and UDP at the transport layer. So what is that? TCP is Transmission Control Protocol, and that is the TCP in the TCP IP keyword. Transmission Control Protocol is a protocol used at the transport layer, layer 4. The number of protocol is protocol number 6. Used at layer 4 means it has to do with establishing the connection, if required, between the two parties, between the two communicating parties. So a connection is established. In TCP, the two parties must establish a connection between the client and the server before data is exchanged. And if this fails, data will not be exchanged. So if we think that the client is a laptop and the server is a virtual machine or a physical server with an application, then they have to send a SYN. This is part of the TCP handshake. The client will send a SYN message, synchronized message. The server, because it understands TCP and it knows the protocol, it will understand that this format is for a synchronization message. Someone is trying to establish a connection with me. So after that, they will exchange data with me. So it will send a SYN ACK acknowledging the SYN. So this is again a message that is well known in the protocol TCP, indicating that, okay, fine, I have seen your SYN and I am ready now to start the connection. Then the client is going to send an acknowledgement saying, thumbs up, let's go ahead and start to communicate. In this connectivity, on this connection, now they will maintain the sequencing. So the sequencing of message, ensuring that messages are delivered in sequence. If one is received out of sequence, then the server will send and say, you didn't send me this message. Please retransmit that message because I didn't get it. They will make sure that the messages are received without errors and with acknowledgements of the receipt and retransmission if there are any missed or unreliable or erroneous packets. Basically, this kind of communication ensures that 100% of the data is delivered, nothing is missed, and nothing is erroneous. That is what TCP is all about. Of course, this is reliable, but it can be slow because you are retransmitting and you are sending a lot of acknowledgements and SYN and SYN ACK, establishing connections first. So if the connection is for whatever reason not established, no communication will happen and so on. TCP, you would use it when you are dealing with critical applications and critical data that you don't want anything to miss. Examples, websites, email. You don't want to send an email and then half of it will be missed in between. And file downloads. You want to make sure that your downloads are complete without missing anything, without any corrupted data. Previous one is reliable but slow. What if we are dealing with voice calls over the network? We're dealing with video streaming. What if we are dealing with games that has a lot of graphics and is sensitive to latency? Then in that case, you can use UDP, User Datagram Protocol. So these are the two major types of connectivity at the transport layer, either TCP or UDP. So again, it's used at layer 4, but this is protocol number 17. The previous one was number 6. TCP was number 6. It does not establish a connection. It doesn't use sequencing, error control, flow control, or acknowledgements. So just send and best effort. If I receive it, good. If I don't receive it, who cares? And one might say, okay, but you might lose data here as well. But think about it. Think about voice calls. So I am talking to you over the phone, and that is voice over IP. We are using an application over the internet, Skype or Zoom or something. And let's say we are doing audio only. Now, if I was speaking and you were following, and then some voice got or was broken, or some words were scrambled, you didn't understand me, or maybe some noise got in between, what would you say? The two parties, the receiving end, which is you would say, your voice is breaking up. Can you please repeat? I didn't get the last sentence, right? So the applications or the users are going to correct or request the retransmission, not the application itself. Same thing for video. If we're doing video conferencing and then the video gets distorted somehow, you would tell me, can we close the connection and start again? And then when we start, everything looks fine. So the two ends can fix problems if they happen. They can realize problems and fix them. For games, it will show in the games as well. So user datagram protocol is important when we don't really care about missing some data, because the two parties communicating can fix or detect that, but we need the speed. So this is just sending a request, the server will respond. There is no SYN or SYN-ACK or acknowledgement. There is no establishing a connection beforehand. So it's faster but not reliable compared to TCP, and use cases include online games, voice calls, video calls, and live video streaming. All right, so to recap quickly, a protocol is a standard set of formats of message details and error messages that are used for the successful communication between different parties, regardless or irrespective of who is the developer of the application or the software, for as long as they follow the definitions and the rules in the protocol. All right? Now let's go ahead and look at some common TCP/IP protocols that you will come across. So I'll give you some examples of what you might face and you will face in your engineering roles. So the first one is Internet Control Message Protocol, or ICMP. Simply, the ICMP is a protocol that will be used by one party or one device to send a message, we call it ping, and wait for a response to find out if the server has received it and is alive or not. So when I do ping 8.8.8.8 on my laptop, whether it is in command prompt in Windows or on Mac or on Linux, for an IP address, and the IP address can receive this message, if the server is alive, it will respond and tell me that yes, I'm alive. This is called an echo request, and the response is called an echo reply. And here's a snapshot. We have seen it before. If I do ping 8.8.8.8, this is done from my MacBook. Then I'm pinging this IP address. So 8.8.8.8 is the domain name system or service for Google. So one server in Google that is alive and accepts pings and responds to them. And this indicates a successful receipt of responses, and this is the time it took from when I sent it until I received it, in milliseconds. And if I stop it, here it tells me statistics. 5 packets were sent, 5 packets were received, 0% packet loss. It functions at layer 3, very useful in troubleshooting. However, some people misuse this to find out if they are scanning a network to hack it. They will scan the IP addresses by sending random ping messages to find out if servers are alive, and then they will start to orchestrate attacks on these IP addresses. That's why some networks, they will block ping and they don't allow it. So in that case, if you don't receive response, it's not 100% the server is not alive. It could be that the security in the network is blocking ping from reaching the server, and that's why it's not responding. So here, if I had anything at Google to stop ping and say no to ping, don't allow ping, the server will never receive the message. That's why it will never respond. So receiving a response 100% means the server is alive. Not receiving a response, if you know for sure that the server should receive it if it is alive, there is no security to stop that, then that indicates the server is not alive. But if you don't know, you are trying to ping, you are a hacker and you're trying to orchestrate an attack on a specific IP address, you would like to know if it is alive or not. In that case, if that server stops or is not allowed to receive a ping, that is not an indication that the server is down or not alive. You should try some other way to find out. Of course, I'm not trying to enable you to hack servers on the internet. I'm just telling you, when you are doing legitimate work on the internet or in your network, how to use the ping, and you need to be aware whether the other side accepts pings or not. Now let's look at another one, common TCP/IP protocols. We'll look at the secure shell or SSH. This is a secure way for you to log in to remote devices when you log into that remote device, you are going to log in as if you were physically on the device, and then you can start to type commands, troubleshooting, or set up applications, or whatever you want to do. So how does it look like? How does it work? We have a server or a device that accepts SSH connections. So it is a secure shell server. It can accept clients to connect to it securely. That's the whole reason. And then you need an SSH client on your side. So that the client must have an SSH client. The server must have an SSH server. Any Windows 10 and above has SSH client and has SSH server available. And if they are not activated, you can activate them. It's called Open SSH. All right. So what happens in the handshake? SSH is a connection-oriented protocol. So it runs on TCP. So there has to be a connection and SYN-ACK acknowledgement happening between the two sides. So the client will initiate the connection to the server. The server will send a key that the client can use to scramble the data and start to send the data. So they will negotiate the connection parameters, and then the client can use that key in order to communicate with the server. That key is used to scramble the data. We are going to discuss scrambling the data in the next module. All right, so whoever, if there is any man in the middle that tries to copy that data, they should not understand it because they don't have that key. They don't have the key phrase that scrambles the data. So the data will be garbled, will be scrambled. They will not be able to know what it means. And that's the whole point. So SSH, it's a secure way to remotely access and control another computer over a network. It could be over the internet, and it could be over a local area network or a private network, local area and wide area, and so on. Data transfer between the two ends is secure, encrypted, scrambled, so nobody can see the data transferred over the connection, and SSH operates at the application layer, layer 7, and uses what I meant by uses TCP. It uses port 22 at the transport layer. Why is it at the application layer? Because the presentation, as we mentioned before, is responsible for the encryption, and that's why they say it's at layer 7. However, the actual port used is TCP 22. It runs over port TCP 22 at layer 4. All right. And SSH is especially useful for managing and administering servers. Example use cases: you would like to log into a remote Linux system to manage it and run commands. That's a solid example. Let's go ahead and do a demo and show how this works. So let's go ahead now and do a demo. What we will establish is we will have an AWS Linux EC2 instance, and we will try to SSH into it from a Mac or Linux client. What am I going to try and do? How does SSH work in AWS? So we'll have a virtual machine, Linux virtual machine in AWS, an EC2 instance. And by default, it has an SSH servers, and it works the following way. When you try to connect to the, when you try to create the instance, there is an option to create a key pair, an SSH key pair. A key pair means we have a public key that will stay in the instance in the AWS side, and we have a private key that you will download it, and you don't have a choice. As soon as you create the pair, it will be downloaded to your laptop. We will see it in the demo. So the SSH key pair that we are going to create is how the negotiation happens for security between the two parties, and the key will be used to scramble the data on this side, and the public key will be used to decipher or descramble or restore the original message on the EC2 instance side. What if you try to connect via SSH and you don't have the right private key? The connection will be refused. So that's exactly how it works, and that's how we'll do it now. Please remember that the public key remains in AWS and a private key that will get downloaded to your computer. And the key pair is used for authenticating the SSH connection to the EC2 instance. SSH server is like a security guard at the entrance of an important place. The client is trying to connect to the instance, get into the instance, right? So the security guard, the SSH server will say, can you present your ID, please? And the ID in this case, the analogy, is the private key that will be presented with the connection request. The server will look at the ID and then look at the list of people who are allowed. If the matching public key, remember we said we create a key pair, so they are a matching public-private key. If it finds a matching public key, it will allow you inside and say, welcome to the instance. You can now log into the instance. And afterwards, the same will be used for the encryption, as we mentioned. So let's go ahead and do that in the AWS console. All right, so here is my console. What we'll do now is we are going to create a virtual machine in AWS in our custom VPC. And we are going to create a key pair and download it. The instance must be accessible from the internet, so we will launch it in public subnet 1 that we have created before, and we'll download that key pair. Then the instructions will be available in the console on how we can connect to it using SSH. All right, so let's call this testing 2. You can call it whatever you want. The name here doesn't matter actually. I'm going to go with AWS Linux as well, so Amazon Linux. And I'm going to use the free tier T2 Micro because I don't want to pay any money. Key pair for login. We can use a key pair to securely connect to your instance. Then absolutely, I would like to create one. I don't have any created, and I'm still in United States, Ohio. Please pay attention to where you are exactly. And I'm going to create a new key pair. I'm going to give it a name, testing 2. You can call it SSH test, SSH lab, SSH demo, whatever you like. Or let's do it a meaningful name, SSH demo. I like that one more. And I will leave everything else to the default. It's .pem. It has to be .pem. And I will leave it to RSA. And then click on create key pair. Notice what will happen now. See, a download has happened, SSH demo.pem. So I have that right now on my computer. And if I click on where it ended, right, as you can see that this is the file, ssh.pem, and it's asking me for key access. So you can find information about it, and here it shows that this is a certificate standard. Please make a note. This is extremely important. Now I know that it has been in my downloads folder. In your laptop, you need to find out when you clicked on the file, it will show you where exactly in your laptop it is. This is very important to know. Is it in the downloads folder? Is it in a user folder? Is it in a temp folder? You need to find out where that file is because you are going to use it. We are going to go into that folder and then try to connect. Or at least we need to know the path, how to get to it. So let me now continue this, and then we'll come back to the key. So I'm going to click on edit because I want to make sure that it's going to be in the custom VPC. And I would like to make sure that it will enable a public IP address. And for the security group, I'm going to use the one that we created that is wide open for now. Testing 1 VPC because I don't want it to filter or block any traffic. And that should be it for now. So let me just quickly look at this again. So we have an Amazon Linux. We have a T2 Micro free tier. The key pair login, we have already downloaded that. Remember that this is a key pair. So the one I have on my machine is the private key. The one that will be in AWS on the instance or related to the instance is the public one. In any other documentation, they will tell you the other way around, that the public key will be with the client and the private key will be with the server. Understand the concept and don't stick into the documentation differences, but AWS for sure keeps the public and gives you the private. All right, and it is in the right VPC and it is on the wrong subnet actually. It's good that we have reviewed it and I need it in the public subnet. If I put it in subnet 2 or 3 or 4, these are private, so it will not work. and we have a public IP address. So now I'm good to go. Let me go ahead and launch the instance. Please always do a revision before you create, because I overlooked the subnet. Although I went into the network, but while chatting with you, I did not notice that I had it on the wrong subnet. So this is very important to do. So the instance is created, and here's the ID. I click on the ID. And now I have the instance. Of course, this could be because the distance that I have between UAE and United States. Okay, so I need to connect to the instance. We have done before the connect using EC2 Connect, which is just go down and click connect. This is not what we want to try now. I want to try the SSH client. I want to use it not from the portal. I want to connect from my laptop into the instance through SSH and through the internet. So here you will find the details. So let's find what is required to connect. Open an SSH client. I have it in Mac. It is on the terminal or in the terminal program. I can access that and it's enabled by default. Locate your private key. Find out the key that was downloaded. Where is it exactly? The key is going to be used to launch this instance is ssshdemo.pem. So even if you forgot the name, here you have the name of the key for this instance. The key usually has public permission, so anyone can use it. This is not acceptable. When you want to do SSH, it has to be private and not publicly viewable. So you need to use this command on the file. Where do you apply this command? You have to head inside the folder where the file is. That's one way to do it, or the easier way to do it. And then you type this command. Then you can connect to it using this command. SSH-I. I want to SSH into the instance using this key, and consider that I am the user EC2-user. So EC2-user, that's me. I would like to connect to you, the server, using this key, and the connection will be SSH. So now this is going to format a packet, an IP packet from my browser that will be having a destination of 18.191.168.182. The source IP address is going to be my laptop IP address, which is a private IP because I'm using it in a Wi-Fi network. When it gets to the router at my location, the router will do NAT, will translate that. What will be the port, the source port on my side? It will be a random port created from a range of available ports. What will be the port for the destination? It's going to be TCP port 22. This is added at the transport layer. Then the network layer will add the IP addresses, the source and destination, and now the packet is ready, and it's going to carry the key information along with it. This is how it will work. So let me go in terminal, and first of all, let's try and see how the key looks like. What does this key look like? I know that it has gone into downloads, and if you notice here, I am into a folder called ITF under downloads. So what I will do is I will do cd ... cd space ... it will take me one step up. So now if I do ls ssh demo.pem, I have the file. So let's open the file and find out what it includes. Nano ssh demo.pem. These are Linux or Mac OS commands. These are not Windows commands. I'm going to show you how to do it on Windows. And here's how the file looks like. So begin RSA private key. So this confirms it's the private key. And then as you can see here, this is the key. So very hard. It's not like a password. SSH can work with passwords as well, but that is disabled by default on EC2 instances. You can enable it if you want. But this is way more secure. This is a key, so that's a long string and very hard to predict or to find out what it is. And the public key on the other side is going to be as complicated. And since they were generated using the same generator, there is a way to check if these two form a pair or not. So that's how it looks like. All right, I'm going to exit. So I'm going to do Control X. And now what I need to do, I need to change the permissions on the file. So I'm going to take this command, copy. I'm going to go back into terminal, and I'm going to do this. chmod, change mod 400 SSH demo pem. This will make the file a private file, not a public file. So let me, before doing this, let's try to connect and find out what happens. So I'm going to jump to the last step, copy this, and try to connect and see what happens. So here it's telling me the authenticity of this host cannot be established. I don't know if this is a secure host or not. However, are you sure you want to continue? And I will say yes. So it's giving me yes, no, fingerprint. So I'm trying to connect now. See what happened? Bad permissions on the file. Why? The permission is denied because it's a public key. You have to change the permissions beforehand. It has to be secure. And this is unprotected private key file. So SSH is smart, even it checks whether the key access is open or closed. So what I will do now is I'm going to copy, not this one again, to lock down the permissions. I'm going to use it. And then I'm going to repeat, let me clear. I'm going to repeat the same SSH command. Press on the arrow keys up and down. It has the history and it repeats the commands. So now I'm going to click and see what happened now. I am logged into an Amazon Linux 2023. And here it shows me that I am the EC2-user, which was what I requested here. But here it's not showing me that public IP address. It's showing me a private IP address. Remember, network address translation happens, right? What I need to check to verify whether this is the right one or not, I will just go here. I'll go back to the instance page and I will check what is the private IP. Here is the private IP, 172.31.2.144. So that's exactly where I am. We can do sudo su super user, and I will start doing ping 8.8.8.8. Can I get to the internet? As you can see, I can get to the internet from the device without any issues. And if I do Control C to stop it, and then I'm going to copy the public IP address, which is this right here. So now I am in the instance and I can ping to the outside, to Google site. If I do exit, so now I have closed the SSH connection and I'm back on my laptop. Now, can I ping the instance? Yes, I can. So now the instance is available on the internet and I was able to connect to it, to SSH into it. What if I need to SSH again into the instance? Just use the history commands and you can click enter again and you will be connected again into the instance. So that's how easy it works. But now I have a secure connection. I am in Dubai in UAE and the server is in Ohio in the US, and all this connectivity or the communication between me and the server is protected by the private and public key pair. All the information is scrambled, it's encrypted, and nobody can look at it or understand it. They can copy it maybe, but they will not be able to understand it unless they have my private key or the public key on the other side. All right, hopefully this is clear, and this is for Linux and Mac. We will look at how we can do this on Windows, and it's exactly similar process. All right, so since we are done with the test, if you are not going to continue working right now, please go ahead and stop your instance and you can bring it up later on. All right. Let's now use a Windows client. So my machine is going to be a Windows machine and we're going to SSH into a Linux EC2 instance in AWS. So we're going to repeat the same steps we did before to create an EC2 instance, a Linux one, but we are SSHing from a Windows machine. This is going to be a Windows client. That's the only difference. So let's go ahead and do it. All right, so here's my Windows machine, as you can see at the bottom, and I'm connected to my AWS account, and I'm going to go ahead and create the Linux machine. So let me put this one a little bigger. Okay, hopefully this is better visible for you. The response will be a little bit slow because I'm using a Windows machine on the cloud. So this Windows client is in AWS actually. But it works exactly the same if you were using Windows on your machine. So launch instance. Oh, but let's do it in Ohio. So to take advantage of the previous settings we have done. All right, so I am now in Ohio. So what I will do is I will call this when testing, and I'm going to still choose an Amazon Linux, and it's free tier as we mentioned before. And I will use T2 micro as well because it is free. Okay, and for the key pair, I'm going to also create and download a key pair. So I'm going to create a new one. And this I'm going to call it when file or when key. And I'm going to leave it to .pem, everything as is, and I'm going to do create key pair. It's funny when I increase the size, how slow this becomes. Okay, I want to show you this. So see on the right hand side, I apologize if the size is not appropriate. Let me try to do it from the browser. Maybe it works better. All right, hopefully you can see it now. So it has downloaded a file on my laptop, and that is the PIM file, the win key file. And we are going to continue our settings. So I'm going to choose T2 micro, and that will be free tier eligible as I mentioned. The key pair is win-key. We are going to locate the file where it is exactly. And for the VPC, as you know, we are going to click on edit. I'm going to choose the VPC custom. And for the subnet, I'm going to choose the subnet 1 public to make sure that it will receive an IP address. This is very important. Auto assign IP address must be enabled, not disabled. And select an existing group, security group, which is the testing group. So this one. All right, just to make sure, custom VPC, and we have subnet public, subnet 1, and everything looks good to me. So let's just make sure that we have everything. It's a Linux, and we have the key, and it's T2 micro, right VPC, and right everything. It's always good to check rather than finding out after troubleshooting a lot that you did something wrong and you'll have to redo it again. So this will be our Linux instance in the cloud that we need to connect to, right? So we need to get some information from the Linux in order to be able to work on it, which is the connection and what's the key and all that. So I'm going to click on connect. See here, we have a private IP address, and we also have a public IP address to the instance, 18.191.252.228. So let me click on connect, and I'm going to use SSH client, and that will give me the steps that I need. So chmod 400 does not work on CMD in the command prompt in Windows. So what we'll do is this would be the one that we are going to use, SSH -i when and EC2 user and so on. So let me go back now to the desktop. I'm going to minimize Edge, the browser. So let me minimize this. Okay, and I need to go back to my Windows desktop, which is this guy right here. Okay, so this is my Windows desktop. Let me just resize it so you can better see what I'm working on. And if I can relocate this, that will be perfect. I don't want to see it in front of my face all the time. Okay, so what we need to look for is where did the file go? So I can look in the file system. I click on and hopefully in downloads. And let me look. Yeah, it is in downloads. So it's very important to locate where did the file go. in order to find it. And win-key.pem is the name of the file. All right, now I need to get to the command prompt. So what I will do is I'm going to type cmd here, and you will see that it will show here. Double click on that. So this is the command prompt. Whenever you hear me talking about the command prompt, this is what I'm talking about. So let's relocate it to the middle of the page. And here, let's enlarge it a little bit. Okay, hopefully it's visible now. So what I will do is I'm going to do cd downloads. And if I do dir, just to check, we have here the file, the win-key.pem. So what do I need to do now? I need to get the command for the ssh-i to try an SSH from here. So where do I get that from? I get it from the browser window. So let me minimize again and get to Edge. And I'm going to copy that from here. Oh, actually, I had copied it. Anyways, that's okay. And I'm going to go to command prompt again. And let's try and see if it works. So now I am on the same directory where the win-key.pem file exists. That's the easiest way. Of course, you can add the path and do it from anywhere, but the easiest is locate where that is, use cd and the name of the directory as I did here in order to see. Let me just make this a little bit bigger. So cd downloads, as you can see here. So I went into the downloads directory. So you need to move to that directory where the PEM file exists. And then from here, I'm going to try and hit enter and see if it will connect. So I'm going to click yes. Let's see what happens. And as you can see, I am connected into the EC2 instance. Here it says Amazon Linux 2023. And here I have the EC2 and the IP address and so on. Now I can do sudo su and do ping 8.8.8.8. And that would be responding from the Google server. So we can do this and we can reach the internet without any problems. We did SSH, the SSH is working, and now we are typing commands from the instance to Google and everything is working fine. That means the forward path to Google is working and the response is coming back as well. So life is good. Do Control-C and it stops it. And as you can see here, we have 0% packet loss and we have sent this many and this many were received and life is good. All right, so hopefully this is clear how you can do it from Windows, and this is very easy as you can see. Don't forget to terminate the instance because we don't need it anymore here. So what I will do now is I'm going to exit from here, exit, and then another exit. And now I'm back into Windows. I do CLS. In Linux and Mac, we do clear here CLS, and it will clear the window as you can see. All right, so what I will do now is I don't need the instance anymore, so I'm going to go ahead and remove it. Why? Because if you leave it for extended period of time, and if you are not on the free tier, or if you have some credits and they finish, you will start to get charged, and I don't want you to spend money if you can avoid it. So what we'll do now is I'm going to go into instance state, and I am going to go ahead and terminate the instance. Thank you so much. Resize it back and click on terminate and delete. I need to check that it is shutting down, and that means it is on the way to be terminated. So now you're good to go. All right, hopefully this was clear and it is not problematic. We are still with common TCP/IP protocols, and now we are going to look at the HTTP and HTTPS. Whether you know it or not, but whenever you use your browser, be it Safari, Firefox, Chrome, Edge, whatever or whichever browser that you are using, the communication between your browser and the web server or the website or Amazon.com or wherever that you are trying to get the data from is based on HTTP, the Hypertext Transfer Protocol. HTTPS is a secure version of that, where between you and the server, between your browser and the server, everything is going to be scrambled, is going to be ciphered, encrypted, so nobody can read it or make sense of it, even if they can get a copy of that traffic. So let's go ahead and have a look. Let's start with HTTP, Hypertext Transfer Protocol. So it is a set of rules that web browsers and websites use to communicate with each other. So this standard was primarily created for the smooth and successful communication between browsers and the websites. And the websites can be anything. It can be Gmail, it can be hotmail.com, it can be British Telecom, it can be CNN.com, any website. So what does it do? It allows the browsers like Chrome or Firefox to request web pages for you to sign into your online banking, for example, to look at your accounts. These are different pages on the websites. And when the requests are sent, then the website will understand what exactly you want and it will send the information back. And that's how you get the websites in your browser and you can look at them. As in SSH, it functions at layer 7 at the application layer. And it uses TCP port 80 at the transport layer or layer 4. And if we said TCP means what? It means the two parties, the source or the client and the server, are going to communicate and establish a connection, and they will establish the rules of that connection. So the sequencing of packets, the retransmission when needed, errors when there are errors, what are the error codes that will be sent if a page is not available or the website is down or whatever. So they will agree on this set and then the connection will start. So the send, ACK, and acknowledgement is going to happen beforehand. So this is the port it uses at layer 4. And here's an example. This is to show when someone is not using SSL, so it shows you that you're not using SSL basically, or not using security or not using encryption. So you're working on HTTP, and the website is funny, it's called bad SSL. So let's go ahead and look at this website. It's just a dummy page, but if you look here at the top, you'll see that it's HTTP, and next to it, it's saying that it is not secure. So this is not HTTPS basically. When we're talking about HTTP and HTTPS, the success of HTTP and HTTPS between browsers and websites led to the adoption for that language to be used even between application components. As you progress in IT, you will find that a lot of the application components that you will come across, they are communicating using HTTP. And why is that? Because it has everything. It has the rules, it has the formats, it has the error messages, it has a lot of things to do. That's one thing to note. The second thing to note is when we are talking about it functions at layer 7, that means any information that will be added because of HTTP, like HTTP headers, for example, and there are many of them, they will only be understood by devices that can process up to layer 7. So for example, the web server, it processes up to layer 7 because it has the application and that's how it understands that. If you would like to put any security device in between and you want to filter or check the packets or understand everything at that packet to ensure that it is secure and it's not malicious activities and it's not including any viruses or anything, then the device that will be doing that check has to understand layer 7. It has to have software components that can look at the packet at layer 7 and understand the HTTP headers and look at them and find out if it is following the standard or if it is suspicious. So this is very important, and that's why we mentioned layer 3, layer 4, and layer 7 are going to be bumps on the road. You have to understand in order to assimilate what you need to do from a networking perspective, from a security perspective, from a lot of features that you are going to use, whether in the cloud, in the network, or in cybersecurity, or in a lot of other things. Now let's move on to HTTPS, the secure version of HTTP. So this is a normal HTTP over TLS. TLS is abbreviation of Transport Layer Security. HTTPS ensures that anything that your browser is going to be exchanging with the server, whether it is login information, credit card information, account information, whatever that is, it's going to be secure and scrambled, ciphered, such that if anyone in the middle, man in the middle attack we call it, can grab a copy of that data somehow, they will not be able to make sense of it or understand the information included. And it operates at layer 7 like HTTP, and at the TCP layer it uses port 443. HTTP uses port 80 at the transport layer. can I configure my server, my website, to listen or to function at a different port other than port 80, which is a default? And the answer is yes. You can configure it to run at port 8000, maybe 8080. And in that case, the client and the browser that are going to be communicating with the server, if the server is listening now based on the updated configuration at port 8000, then anything sent from here should be communicating with port 8000. Otherwise, if this communicates with port 80, but the server is not functioning at 80 anymore, it will not happen. The communication will be broken. HTTPS functions at TCP port 443 at layer 4, and examples would be a lot of things. Could be CNN.com. As soon as you get to the website, you'll find here it's not saying that it is not secure. And if you click on this, it will tell you that the connection is secure. And if you look here, you'll find that this is HTTPS. Okay, so these are the difference between the two. Very common. You will come across HTTP and HTTPS a lot when you are learning in IT. So that's why you need to know them. Whether you are a developer, a cybersecurity consultant, a network engineer, a cloud engineer, DevOps engineer, you will come across HTTPS a lot. So it's very important to know HTTP and HTTPS. If you are a developer, maybe you need to dive deeper into these protocols because you are going to build software that will start using HTTP and HTTPS. All right, so hopefully this was easy. Now, since we have learned a lot of information about TCP/IP, about ports, about many things, now let's put all that together and revisit the TCP/IP packet anatomy. Basically look at what is the composition, what are the different fields that we have addressed, and where do they exist, and how they will be sorted out, and which layers is going to be using them, and all that. This is very important, and we'll look at some examples because we need to understand when a client communicates with a server, what will be the source port and where it will come from, how it will be assigned. Also, what will be the destination port, the port on the server, which should be known, otherwise the communication will not happen properly. Imagine and remember when we said that if you send a letter and the address for the recipient does not have the unit number in the building, then it will be difficult or challenging to deliver it properly. Same thing here, you need to know the unit number, the port number for the application you are trying to talk to. Otherwise, the client software is going to create a packet that is going to be sent to the server, but then it might not be delivered properly, or it will go to the wrong unit and then an error will be created. So let's go ahead and look at the TCP/IP packet anatomy. So first thing, we need to understand TCP and UDP. Transmission Control Protocol, which is protocol number 6, and UDP, which is User Datagram Protocol, which is protocol number 17. But where do they sit in the headers of the packet? Believe it or not, but this is what a TCP packet is going to include. And it will be surprising to see that the payload is only this part. Of course, it can be long. But then we have so many other fields that will be added by the source and by the destination when they are communicating. So for the forward traffic and the responses. The HTTP packet has a length field as well. So all of these are going to be, anything that has to do with HTTP is going to be added at layer 7, for example. We have type of service and version. These are things that we're not going to discuss outside our scope. Time to live, how many times or how many devices can process this packet before it reaches the destination. And if the TTL, that's usually a number that decrements each time a node will pick up this packet and try to process it. So the TTL, if it reaches 0, the packet must be dropped, because that means it might be circulating endlessly in the network. One important field here is the protocol. So is it TCP or is it UDP? And that's how layer 4 in one end, when it sends the very first packet to the other side, it would say, if it said TCP, port number 6, that means let's go ahead and please create a connection and agree on the rules of the communication before we start. So retransmission, error flow, flow control, and all that are going to be included. If the protocol value was 17, that means the client with the first packet is telling the destination, let's communicate, but don't worry about errors and retransmissions and sequencing and all that. Well, I'm just, whatever you receive from me, do the de-encapsulation, make sense of the data, send it to the server, and that's it. Then we have the headers, source IP address, who is the sender of that packet, and the destination IP address, who is the intended recipient. Please remember, when I call you, if you are John and I'm Isa, when I call you John, can you please help me with that? When you come back to me, you'd say, Isa, I've done such and such and such. So always the source and the source IP address and destination in one direction, they are going to be reversed in the response of that communication. So then we'll get the protocol as we mentioned, and then we have the source IP address and the destination IP address. And then we have other fields out of our scope right now. But then this happens at layer 3, the source IP and destination IP. The protocol happens at transport layer, and also the source port and destination port will happen at layer 4. These are called IP headers because except for the protocol, because these are normal IP headers, and the network source IP and destination IP are the highlights. And the source port and destination ports are called TCP or UDP headers, which port for the source and which port for the destination. So now we are speaking about ports all the time. How do we allocate the ports? What are the available ranges? Is there any range that could be used deliberately without conflicting with anything else? Let's find out. So the ports are interpreted at layer 4. And the well-known ports are 0 to 1023. So these are the assigned ports. For example, HTTP by default port 80. HTTPS by default port 443. SSH by default port 22, and so on. So this is SSH, HTTP, HTTPS, and we have DNS. We are going to talk about it later on, domain name system. When you type CNN.com, how is that translated into an IP address? So this uses both TCP or UDP port number 53. So these are pre-assigned. Nobody can use them. They are assigned to services or protocols. This is a remote desktop protocol, a Microsoft protocol, when someone is trying to get from a client to a Microsoft server or a Microsoft machine remotely to administer and control that machine. Similar to SSH, but this is for Linux and this is for Windows. We have MySQL, one type of the databases, and it is very well known, very widely used on the internet, and that's the port, 3306. Then we have registered ports, and this is the range, and usually companies will avoid using that deliberately. And then you have the dynamic or private ports. So this is what clients can use deliberately without any permissions, and also ensuring that it will not conflict with anyone. And the range is 94,152 to 65,535. So what do we use the dynamic port for? When your browser is creating a packet to go and send it to CNN.com. So the source IP, destination IP will be added. The destination port is known. I mean, that's HTTPS going to be, so 443. But what will be the source port, the client, or this session port from the client? How it will be decided or assigned? The browser is going to check for this range locally which ports are used, and it's going to pick one port that is not used randomly. If my laptop is opening 20 sessions to my Gmail and to my Hotmail and to Zoom and to this and to that, these are going to be each assigned a random port from this range, and the port will not be reused if another session is using it. And that is how, when the client is going to send to the server, the client will send with it the source port and the source IP as well. And of course, the destination port and destination IP, they will all be in the packet. So when this is sent, then the server, when it responds, the source port will be the destination port. So when it comes back to the laptop that has 100 or maybe 200 sessions and tabs and applications running, it will know exactly what's the unit number, which session and which application to deliver it to. So this is very, very important. This is called dynamic range or ephemeral port range. Whether you hear this term or that term, it's the same. From the client to the server, the destination port is the port of the application, the unit number in the building at the destination, at the recipient side. And the source port is picked randomly from the range that we discussed. So here's an example. This client is going to use a browser to get to this website, let's say Dolphin Ed Academy. And the IP address of the source is this IP address, and it appears to be a public IP address, so it's connected to the internet. It could be a direct IP address, or it could be the one on the wireless router at home or in the office. The web server side, this is the IP address. Again, it's a public IP address, and it is listening on or functioning at port 80 HTTP. When you hear the term listening on, that means this is the port that it is expected to receive traffic on, or this is the unit number in the building that you need to deliver, or the server needs to deliver the packet to. All right? So when you hear that it works on port, it listens on port, it processes port, it's all the same thing, that the application for correct and accurate delivery needs to see that in the packet as the destination port. The browser will look at the random range that we discussed, and it will find out randomly that port 50,000 is unused. So it will create the packet. The source IP address is this IP address. The source port is the random unused one that no other session in this device is using. And then the destination port is 80, depending on our knowledge of the server, and destination IP address is 98.73.2164. And it is going to tell the server, please, we need to establish a TCP connection. This has to be a reliable connection. In the response, this is going to be reversed. The destination port is the source port that's in the response from the server when they are reversed. And the source port is the server port that used to be the destination in the forward traffic. So let's look at it again. Here we have the source port and the source IP are those of the client. Why? Because that is the sender. And the traffic was going from the sender to the receiver. So the destination port and destination IP used to be the server ones. When the server comprehends and understands the message, prepares the response, then it's going to take what used to be the source port and the source IP in the original message that reached the server. These are going to be the destination port and the destination IP. And since it was initially destined to the server, the destination IP and destination port, now in the reverse direction, they are going to be the source port and the source IP. Makes sense, right? And the protocol is still number 6. So this is basic. It's obvious. We use it for the analogy. If I call your phone number, you didn't pick up because you were busy. When you call me back, you will have to dial my number, not your number. A lot of people in IT, network security, cloud, DevOps, they do a lot of mistakes when they set security to filter out packets based on inbound or outbound. And when we get to the security module, we are going to talk about that in more details. So please, if you're going to eventually configure anything that has to do with packet filtering, traffic filtering, security, firewalls, and all that, make sure that you draw it. If you are not sure, draw where is the client, where is the server, and for this direction, what will be the source and destination? And for the reverse, what will be the source and destination? That's one thing. What if the server needs to go to an update server and download a new version of the server software? Let's say the server is running on Nginx or Apache, and it needs to download a newer version. In that case, the source or the client is going to be the server, and the actual server will be the update server on the internet. So in this direction, who is the source? Who is the one sending the traffic? What will be the destination? It's extremely, extremely important to map out the flows expected when you configure that. Here is one more example. And in this case, we are taking it one step higher. So in this case, we have a server that has 3 applications active. The first one is an SSH server. So administrators can connect using SSH to this server, and it is functioning or listening on port 22 TCP. Then we have a domain name server that will translate CNN.com into an IP address, DolphinEdAcademy.com into an IP address, and so on. And then we have a web server. So it could be an e-commerce website, something like eBay, Amazon.com, and all that. But we are talking about like a mini version here because we are talking about a single server. And this is expecting connections on port 80, or it could be 80 and HTTPS as well, and 443. All right, so what's the scenario? We have a user and an administrator that needs to connect SSH to fix few things in the code here or in the website. And while working on using SSH and administering that, the user also will need to connect to the web server to see the updates. What is the impact or effect of these changes and whether they have fixed the problem or not. So two connections in the same server from the same client. Remember that the ephemeral range or the dynamic port range is the 49.152 to 65.535. So let's talk about the first one. The client is trying to SSH, is trying to connect securely into the server for administrative purposes. So in that case, the source port is going to be a random port unused in any of the other sessions, and it will be picked up by software. You don't need to get involved. And it decided that it's going to take 61.234. Here we are ignoring the IP addresses, but of course, let's say this is IPS or IPC for the client, and this is IPS. So this could be 200.10.1.5, and this could be 150, for example, .2.1.1. So we'll focus on the ports. So the source port randomly selected from this range unused in the client, and the destination is going to be 22 TCP. And this is the traffic from the client to the server. So the server is going to receive it, check on the key, and check on all the information, and now it is good to go. So what the server would do, it will respond, and it would say, this is being sent from the source, which is the SSH server, port 22, going back to what used to be the source in the request. And of course, the IPs are going to be IPC, and in this case, going to IPS, which is the server IP address. And in this direction, they are going to be reversed. The source will be IPS, and the destination will be IPC. Connection established. The administrator does whatever he or she needed to do, and now it's time to test it. So they need to do an HTTP connection. Connection is open, but they open the browser, and now they need to go and do HTTP into the server. So again, the software here will look at this dynamic range and see what has been already taken. For example, 61234 will never be picked up. It will pick up another one that is unused. And here we have more than enough, 16,000 plus ports available to be used as a source port. And I don't think any of us will have 16,000 sessions open at the same time to 16,000 different applications and websites and all that. Maybe have 50, 100, 200, but never 16,000. So it will decide on this is free, the 50,000, and the destination in this case will be TCP 80. Why? Because we know that the server is listening on this port. Server will receive it, understand it because it's standard HTTP, and now it's time to respond. So when it responds, they will be reversed. The source is going to be 80 and the destination is going to be 50,000. So please, please, please stick this fact about the source port and a destination port in forward direction, and they will be reversed in the other direction. Now let's expand it a little bit. Let's say that this server would like to go on the internet to an update server, and the update server is going to be using port 443, for example, so HTTPS. All right, so the request is going to be initiated from the server out, so the destination is going to be port 443 in this case, while the source is going to be a random port selected depending on how the software will do it. All right, let's now discuss the security or the cybersecurity introduction and the network security introduction. A lot of people get confused about network security and cybersecurity, and they think they are the same thing. And here we are going to clarify the relation between network security and cybersecurity for beginners. In this module, we're going to introduce what cybersecurity is and what exactly it covers. And then we are going to look at network security. So the focus is going to be about network security, but we have to take the 50,000 feet view first. Look at what cybersecurity is and the role of network security within cybersecurity. We're going to extend the discussion to network security. We're going to talk about network devices again, but this time we're going to focus on the firewalls, the very famous or the most common device in protecting or in securing your network and the data within. We'll look at firewall examples, and we are going to use two examples from AWS, the security groups and the network ACLs, and both of them are layer 4 firewalls. What does that mean? That means they have the intelligence to understand up to the transport layer only, but they don't go beyond that. They don't understand what's happening in the application. They cannot comprehend any headers that are added by HTTP or by encryption. So they only understand IP addresses and ports, and that's what they can permit or deny based on. And we'll also look at encryption. Then we're going to look at virtual private networks, which relates very well to encryption that we have mentioned multiple times, but now it's time to explain what that is. So let's go ahead and start with cybersecurity overview. What is cybersecurity basically? Before we do that, we'll take a step back and we'll do an analogy so you understand the importance of security when it comes to networks and data. So think of your phone or computer like your house. What do you do to secure your house? There has to be a lot of different ways to secure it. There are the passwords that we need to protect and firewalls. So let's say, for example, this is locking your doors every night. And then we have the scrambling of the data so nobody can read your data. This is like when you spread or close your curtains so nobody can see you in the evening while you are inside the house. Then we have an alarm system. If anyone breaks into a window or breaks into a door, then we need that. So that is the role in cybersecurity for antiviruses and security monitoring. Then probably you will have a device with a camera and mic that will check who is at the door before opening the door, right? So think like authentication in networks. So we are going to cover all of these. So these are stuff that cybersecurity covers. So cybersecurity is about protecting computers. Computers include servers, include storage, include anything that does computations. Protecting networks, so nobody can break into the network and bring it down. Delete the configuration, for example. And also the data, whether it is stored or travels across the network from being stolen, attacked, like hacked, or damaged. So this is the core responsibility of cybersecurity in general. So please note that we talked about networks and we talked about computers, but this is part of what you need to protect. Why is cybersecurity important? Because it will protect your personal information, your credit cards, your photos, your money, your bank accounts, your passwords. That is all done by implementing cybersecurity measures. Also to stop hackers from breaking into systems, whether these are websites they will hack or even your laptop, and then they will ask you for a ransom. And also to keep companies and services running. Some hackers or types of the hacks is the denial of service. They will have loads and loads of traffic on a server such that the resources on the server, the memory and CPU will be busy and they will not be able to serve legitimate users. So this is also type of attacks that people can do in order to deny the service from legitimate users. So this can happen in banks, in hospitals, and in schools, universities, and so on. Also to prevent data loss or leaks. So cybersecurity is very wide in its responsibility to protect a lot of things and to make sure that your IT is healthy, is operational the right way, and is protected from any malicious activities. So cybersecurity is not network security. Network security is part of cybersecurity. So let's look at the areas or specializations that are under cybersecurity. What are they and what are these specializations? So we look at network security. This is one of many areas under cybersecurity. And as the name implies, this is about protecting network devices and protecting the data stored or the data that is moving over these networks or through the internet or local area networks. Then we have application security, which is the security of the software and applications from bugs, from backdoors, from Trojans, from there are so many things that you can do to protect applications and software. Then we have the endpoint security. I need to have security software on your laptop, for example. I need to have encryption, for example, done on your laptop. I need to have similar things to detect malicious activities on servers, to make sure that they are sending updates and notifications about their performance and all that, to monitoring and alerting. So this is for devices like server, storage, laptops, and phones. They have to have endpoint security, and there are companies that are specialized in endpoint security. And then we have cloud security. So it could be the network that you own, or it could be the cloud. And in that case, in the cloud, then the provider of the cloud will be responsible for the network, and you will be responsible maybe for the endpoint security and the application security and so on. So infrastructure and data in the cloud must be protected as well. There is identity and access management. Who can access your infrastructure, whether it is in the cloud or on-prem? And when they access it, what are they allowed to do? Are they allowed to get into databases and change things? Or is it only read-only to look at the configurations and find out if it's done right or wrong? Can they change configurations? Can they delete resources? Or they are just high-level, entry-level users? They can just view and not do all of that. So that is all in identity and access management. Who are the users that are allowed to do this, and at what level? So who's allowed to access what and what they can do? And then there is the physical security itself. AWS has data centers. Azure has data centers. Now, who is allowed to get into these data centers? And what is happening in the data centers? And who went in at what time, and where did they walk within the data center? So even if they are allowed, then we look at badges that will allow them in specific areas and not anywhere. They cannot just go ahead and open any cabinets or any cage and walk in if it belongs to third parties or different companies, or if it is an area where they should not be in. And then policies and rules. For security and security policies and all that, there are rules and policies. What are the standards implemented for that? And this is also part of cybersecurity, which is the compliance and auditing part. So as you can see, network security is just one of maybe 7 or 8 different areas in cybersecurity. So please be aware in your career that nobody is going to fool you intentionally or based on ignorance and tell you that cybersecurity is network security. It's the same thing. You need to take Network Plus and CCNA before you do cybersecurity. And my answer to that would be, what if I'm going to specialize in these areas? Why do I have to dive deep into network security? Maybe cloud security will have a little bit of that as well. So if I'm not specializing in this one or that one, why should I dive deep into networking? If I'm going to do endpoint security or physical security or compliance and auditing, why do I need to be the expert of networking? So please be aware of what cybersecurity is and what network security is and how they relate to one another. This is very important to keep in mind as you cruise through your IT career. All right, so now let's focus on network security. The normal extension or the normal continuation is to go through network security as a branch of cybersecurity. So please keep that in mind all the time. So network security, it is about protecting the network devices and data as the data travel across or live on a network, get stored on a network in a database or in a storage device. The mission of the network security is to keep the bad guys out and make sure that the data is safe, and only the good guys should be logged in to the network or access the network and only do what they are allowed to do. So that will take us to discuss network devices again, but now we are going to focus on the security part. What are network security devices? The very common one that we will face day in and day out, whether we are using AWS or Azure or Google Cloud, or even if you are working on premises, we always need to think about firewalls. Firewall is a security gate, is a security guard of your network and applications. So it can protect the network and it can protect the servers or the computing devices and the applications on top. Is it going to do everything in the application? The answer is depending on the intelligence of the device. Does it delete the need for endpoint security? And the answer is no. They are integral parts of the overall cybersecurity mechanism that you do. So here's an example of a firewall that we can place. It will protect the local area network switch, and it will protect the application servers and database servers if we are in a data center. Of course, some people would place that in front of the router. That's a possibility if the firewall is an advanced one that can also process routing. The firewall can be configured to allow, or sometimes it's called deny or block data coming in. If data is coming into the network or the server, this is called inbound. If data is being sent out of the network, this is called outbound. So some people would call it ingress for inbound and egress for outbound. So please understand what this means, because they are very important when you are configuring your firewalls. Once configured, the firewall will be like this security guard that is going to be looking around and trying to figure out if there is anything that's not supposed to run through the firewall. Then it will stop it, depending on the configuration that you have placed. When I was stressing before on the importance of understanding the flows and the ports, and what is the source port and what's the destination port, what's the source IP, what's the destination IP, because if you don't understand it well, you will configure the firewall in a wrong way, and that will deny legitimate traffic and may allow traffic that is not supposed to run through the firewall. Firewalls can protect at the network level or at the application level. So firewalls might be a layer 4 firewall, which means it understands IP and transport layer only. That's called a layer 4 firewall. An advanced firewall, sometimes it's called next generation firewall or web application firewall. That is a firewall that can understand up to layer 7. So it can process all the headers, and it can even look at the payload at layer 7. The complexity of the firewall depending on the budget and depends on also the use case. What do you need to use it for? So we might also deploy separate firewalls at the separate segments, and it depends on which business you are in. So there are some standards depending on the business that they have to comply with, and part of that compliance, there will be some clauses about firewalling in your infrastructure and how many firewalls have to be there. So we could also have hardware firewalls or software-based firewalls. The two examples that we are going to study in AWS are software-based. The infrastructure security part. How do companies classify segments or trusted, untrusted, or highly critical, low critical, public zones in their infrastructure? Here I'm not talking about a startup that maybe have 1 or 2 servers. I'm talking about a corporate, a hospital, a university, a government, or a ministry in a government that they have a sizable infrastructure and they want to protect it according to best practices and according to standards. What they do is they start to classify zones in their infrastructure from a security perspective. So the zoning architectures. Firewalls, as we have seen, can divide the network into trusted and untrusted segments. The security architecture of the network infrastructure consists of zones. So there are security architects, and this is a job. There are infrastructure security architects that will be defining according to compliance needs and standards and the business and so on. They will be defining a security architecture that will classify zones, and they will detail what should be in each one of these zones. So the zoning architecture is designed based on the criticality and the security risk of each component. So let's have this example that we have here. So I have a firewall. Now we are not showing the routers. We are showing the firewalls primarily. And this is an architecture, and that's why it's not a physical drawing. So you need to understand moving into IT, that there are physical diagrams where you have to put the devices and you have to put the ports and the types of the cables, speeds, and all that stuff. And there are architecture conceptual drawings that explain the concept, and that not necessarily is going to include all the devices by name, all right, or type. So here we have the internet, and this is a zero trust area. We don't trust the internet. That's why we have, let's say, firewall 1, or we can call it the DMZ firewall. That is a firewall that will filter traffic coming in or going out to the internet before it hits the demilitarized zone. We call the demilitarized zone, and that's a low trust. So it is trusted at a low level because it is only one firewall away from the internet, which is zero trust. This is a data center security architecture, by the way. So external DMZ, what would you place? Why do you build it? Which workloads are you going to host in an external DMZ? So examples are voice over IP servers. If you are using voice over IP, telephony over IP, basically telephony over the network. If you are going to have a file transfer protocol server where people can get in and download files from the outside, from the internet. If you have web, DNS, VPN, or extranet servers that are exposed to the outside, any workloads that should be accessed directly from the internet, and they are not a high risk or a highly critical workload, then they can be placed in the external DMZ. Okay, so let's say I have the servers and all that. If these servers, they need to communicate, for example, with a database inside, do they just communicate through the network, or do we have to have, again, checkpoints, firewalls that are going to process requests before they get in? And the answer is, if the ones inside are classified as trusted, that means I cannot connect a low trust to a high trust directly through the network, through a switch or a router directly. I have to put another layer of security or a checkpoint that will do more checks, because if someone from the internet somehow hacks one of the servers here, before they can get in or roam around the infrastructure, I have to do another checkpoint. Police officers, that they will stop them and look at the ID, try to find out what they're trying to go to and why and who are they before they are let in. I'm talking about the traffic they are sending, of course. Okay, so what would I have in a high trust zone? You will have applications and maybe end user systems. All right, then where are the databases? These are the applications. Databases, mission critical applications, and IT support critical services or resources. They are going to be in a highest trust. Look at the color coding, by the way. The colors usually in corporates and in their zoning architecture, they have meanings. Here you have the green, that is the highest trusted, and the red is the most dangerous one, and that's why it is no trust or zero trust, and the color red signifies that. If you look from afar, you will be able to tell which zone and what kind of security is that. And of course, they document in their documentation, they document the color legend and what that means as well. All right, so if I move from the purple, if it is high trust and I would like to communicate, application here would like to communicate with the database here. So it has to go through a layer of firewalls. Now, what about the corporate users who are coming through wide area network? They are not coming through the internet. Should I fully trust them? And the answer is no. If they're coming from wide area network, we'll have them as medium trust. So they are higher trust than the blue, but they are lower trust than the purple and green. And that's why we have firewalls behind the WAN routers, the wide area network routers, because they need to protect traffic or filter traffic before it gets into the operational zones. And from there, maybe they will try to get into the highest trust zone. So this is not something you need to worry about now, because that is advanced when we talk about these architectures, and you need to get into network security deeply, understand firewalls and how they get configured and their features and so on, before you will be at the architecture level deciding on zoning designs. Usually you will enter from the junior to mid to senior engineering before you move into the architecture part. All right, let's now go into AWS again and introduce one type of a virtual firewall, a layer 4 firewall, so it only understands the transport layer, the ports, and the IP addresses, cannot get into the application presentation or session or encryption details. And that is the security groups. This is available also in Microsoft Azure and in Google, and it is a type of a firewall that will protect at the virtual machine level. So let's go ahead and discuss that in more details. So the security group, what is it? It's a virtual firewall that applies at the instance's network interface. So each virtual machine in AWS, as we mentioned earlier, it's called an EC2 instance. Elastic Compute Cloud is what EC2 is, or abbreviation for. And then instance means it's one virtual machine, basically. Each virtual machine, as we know from the virtualization concept, it's going to have virtual resources allocated. One of them is a virtual network interface. So if we look at this symbol as the virtual interface, it's called the ENI in the AWS world, Elastic Network Interface. What does it signify? Why did they call it this way? I don't care. All we care about is to use the right terms that AWS has used or has decided to use for the VNet or the virtual network interface. So if you heard the term ENI or VNet, it's exactly the same thing, virtual network interface card. So it's a virtual firewall that applies at the instance network interface. And in the security group, we can only allow permit rules, allow rules. So how about the deny ones? By default, if it is not there, that means it's denied. If we have a security group with allow, and that's it, that means there is an implicit deny at the end. So if anything that is not allowed is denied. So if I have a blank rule set in a security group, that means everything is denied. If you make a change to a security group, the changes are going to take effect immediately. We're going to present all of that, so don't worry about that. In a firewall, there is something called inbound and there is something called outbound, or ingress and egress. But you need to understand the meaning from the vendor perspective, not up to you. From the vendor perspective, what is ingress or inbound and what is egress or outbound? For example, in some Cisco routers, if you are talking about inbound, it could be what is coming into the router, and outbound, what is going out of the router. But here, when we are talking about inbound, that means traffic that is coming eventually into the instance. So if the firewall, if the security group allows it, it will go inside the instance. It is sent to the instance. Whereas outbound, that means it's initiated from the instance, and if allowed, it will go out. So inbound or ingress means coming into the firewall, descend to the instance. Outbound means that it is leaving the instance through the firewall to the outside. And the outside could be another instance that is in the same subnet, or it could be another instance in a different subnet in a VPC, or even out to the internet. It could be going to anywhere. We don't care where it's going. What we care about is outbound means leaving the instance, or the instance has initiated that traffic. Outbound is always at the initiating instance side. So outbound is always coming from the instance, even if it was going to another instance in the same subnet. So this is outbound, and then it will be inbound if allowed to the other instance. So please make sure that you understand the flow that you are trying to allow or deny, where it will be initiated from, where it is going to, what are the involved ports for the source and destination, and then you will know where you decide. So for example, for this flow, assuming that it started from here, let's say this instance is doing a ping or SSH into this instance. So it is initiated from here, which means it has to be allowed, if you want to allow it, through the security group in order to pass through the security group and continue its trip. So as it reaches here, the same flow, the exact same flow, here it is inbound, not outbound. So in the inbound rules here, you need to allow it if you want to let it go into the instance. if you did not understand that, then definitely you're going to configure that wrong, or maybe you'll do one side and forget about the other side. And then the traffic will not flow and you will have problems. And we got a lot of questions like that based on lack of understanding, despite the fact we stress time and time again on the importance of understanding the ports, understanding the flow, what is the source IP, what's the source port, what's the destination IP, what's the destination port. And now we'll add to that, what are the involved security groups or firewalls in the path that need to allow this to get through. So here we have to allow it on the outbound in the blue security group, and we have to allow it on the inbound in the receiving security group. All right, so let's say this was a ping IP address, allowed in the outbound, allowed in the inbound, everything is cool. In security groups, they are called to be stateful. They have a memory and they remember the state. They remember what was allowed in one direction. So the instance will receive the ping, and now it's time to respond and say, I am alive. Yes, I'm okay. I got your message. As a special case, because it is stateful, if the traffic was allowed in one direction, the response for that traffic, when it arrives, it will be allowed. This is as if you are driving your car into a gated community or a gated compound. So when you are coming in, they will ask you, where are you going? Maybe they will take your phone number and name, which unit you are going to. Maybe they will call a landlord or the owner of that unit or the resident in that unit, and they will make sure that you are allowed to get in. So you get in. When you are leaving, the barrier or the gate will open automatically as you approach, and they will not ask you for anything else. Or maybe they have cameras that will record that you have left, and that's it. This is stateful. So that's exactly the same analogy for security groups. Is this true for any virtual firewalls or any cloud firewalls? Go and check the documentation of every vendor you are dealing with to find out if it is stateless or stateful. What if it was not stateful? That means you must configure the response rules to be allowed here on the outbound, and when it arrives here, then you have to allow the response inbound on this firewall. All right? So this is extremely, extremely important to know which firewall you are dealing with. Is it stateful or stateless? And should I allow rules in both directions for the forward traffic and the return or the response? Or is it enough to do it in one direction and then response is going to work without any problems? Let's look at inbound rules and how the format in the security group looks like. So what do we configure if we wanted to edit or create a security group and define the parameters and whether that will be allowed or not? So here's an example. We need to allow this inbound traffic. Let's assume that this is coming from the internet. A user is sitting here and needs to connect to an instance that is in a public subnet connected to the internet. All right, what do you need? Any instance, any virtual machine created in AWS must have a security group. That's not an option. There is no way you can start an instance without a security group. And even when you are creating the instance, and we have seen that before and we'll see it again, you are told, do you want to use an existing security group or do you want to create a new one? So for the inbound rules, the destination is the instance itself. So when you are creating the inbound rules, so this is an example of an inbound rule, you can decide on the IP version. It could be IPv4 or IPv6. That means the security group can filter based on IPv4 addresses or IPv6 addresses. Then what is the type of the traffic? Here we can say HTTP, SSH, all traffic, all TCP. There is a lot of choices. We're going to look at that. Then the protocol, is it TCP or UDP? Then the port range. Why do they call it a range? Because it could be a single port or it could be a range of ports. If you want, for example, to allow all the ephemeral, all the dynamic port range. And then we have the source, and that's it. So where is the destination? The statement we are trying to make here is when the traffic hits the virtual firewall of a specific instance in the inbound direction, it is obvious that this is headed to this instance. So why should I ask about the destination? I know the destination IP address. I know you are headed to the instance I'm trying to protect. So the destination is already known, but what we care about is where it is coming from. Who are you? Are you allowed to come in? Are you allowed to send traffic in the inbound? And we're not talking about only your IP address, but also which port on the instance. So the port range here is destination port range. We don't ask about the IP, but we ask about the port. Why? Because I may have here web, I may have here SSH, I may have here FTP, I may have multiple applications on the server or on the virtual machine. So I need to make sure that I know whether you, on this IP address, you are allowed to communicate with the web. Maybe you're only allowed to come into SSH as an administrator, but not to use FTP or the web. So it gives you that granularity that you can define based on the source, where it is coming from, the source. So this is the source. But the port is on the server. So it is very, very important to understand that. A lot of the simple and obvious mistakes happen because of this confusion, and people don't know what is the source, where is the source, where is the destination. You don't know, you can't figure it out. Bring a piece of paper, draw where is the client, what is the flow. Somebody is trying to come through TCP and get into the HTTP port on the server, trying to get to a web server. So the flow is clear. Is it from within AWS in my VPC? Is it from outside VPC, or is it coming from the internet? All right, so it's coming from the internet. What are the allowed sources on the internet that can communicate with this virtual machine on the HTTP port? And based on that, you will find out. So here, for example, there is only one source that is allowed. 98.12.37.32/32. So that's a specific IP address, not a range. /32 means a host IP address. So it has to match everything here as is. So this IP address is allowed as a source to communicate with the HTTP port on the instance. We have a second rule. The second rule is about SSH. And SSH runs on TCP and on port 22. So port 22 is here. So we are talking about port 22. Earlier we were talking about port 80. Again, that is a port on the instance. So this is a destination port. The source is 95.12.65.91/32 again. So /32 means only this IP address. So there is another IP address that is allowed to come in and to do SSH into the instance. All right. What if we get an SSH request but coming from a different IP? For example, what if this IP address tries to send an SSH into the instance? Would it be allowed? Security group, inbound, check the rules, cross, we don't have any other rules, deny. It will not be allowed. What if the second IP address tries to send in an HTTP? Again, do I have an HTTP rule? Yes. What's the source? 98.12. This is 95.12. No, not allowed. Cross. So that will be an implicit deny. So basically here there is a deny anything rule that we don't see. However, it's an implicit deny, deny all. And as you see at the end, there is no allow or deny. It's only allow rules in the security group. Based on that, the source in the inbound rules is the client, the one who initiated the traffic, and the port is on the instance. By the way, if the source was another instance within the VPC, so the source IP will be also this one. So if an instance within the VPC was trying to talk to another instance within the same subnet or in a different subnet, the source is the initiator of the traffic. The destination is where it is headed. Now let's look at the outbound rules, and there will be a difference here, a key difference. So let's look at the outbound rule and what information you need to fill in. So IP version, same. Type of traffic, same field, same choice. Pull down menu, ICMP, HTTP, SSH, HTTPS, all traffic, all TCP, and so on. Protocol, TCP or UDP. Port range and destination. So it is very clear. If the traffic is going out, we are talking about the destination IP address. But also we are talking about the destination port or ports. So in the outbound, we know the source is the instance because this is the firewall or the security group that will inspect the traffic. If it comes to me and it wants to get out, then obviously it's coming from the virtual machine. So I don't need to ask about the source. But in this case, what I need to ask is where it is going, both at the IP level and at the port level on that destination. So I don't care about the source port. I don't care about the IP port because I know them. I know it's coming from the instance. I know the IP of the instance, and I know the port because I have received the packet and I know the port on the instance. What I care about to allow it or not allow it is where it is going, not where it has been originated from. All right? So if there is no rule to allow that, then guess what? There will be an implicit deny at the end that will block the traffic. So in this example, we are allowing IPv4 HTTP on port 80 to go to this specific IP address. So the instance can send outbound HTTP to a specific IP address, which is the 133.45.89. And it's a specific IP, not a range. And I also allow HTTPS, the secure version of HTTP, on port 443, and that is to another IP 130.4.56/32. So I have two IP addresses. I'm allowed to send one of them HTTP, and the other one I'm allowed to send it HTTPS, and that's it. So what about any other traffic? If the instance tries to ping another instance, not allowed. Why? Because it doesn't match, blocked. What if it is trying to SSH into another server? Not allowed. Why? Because it's not HTTP and it's not HTTPS and it's not port 80 and it's not port 443. What if it is trying to HTTP into a third IP? So an IP that is not this one and is not this one, and it's initiated from here. Block. Why? Because this is very specific, very close. What if I need the instance to download updates from a specific server on the internet? I mean, in addition to these two, I need to download something from GitHub, or download something from a storage in S3 or a storage in Azure. Do you know the IP address of the server? If you know, then configure a new rule and allow HTTP or HTTPS. So you have to know the IP address of the server, and you have to know the port range or the port on the server, and then you need to add a rule to allow that. And please also pay attention, there is no allow or deny, because the rules in a security group in AWS is without deny rules. You allow, everything else is denied implicitly. It could be different in Azure, it could be different in GCP. So always study the specifics of the firewalls that are available in the cloud provider that you are working. Find out if you can configure allow or deny. Find out if it is stateless or stateful, and then decide on what you need to configure. Is it asking about the source IP, destination port, destination IP? If you understand this well and you understand your flows that you want to allow, then you will be able to configure them properly. Remember that the security groups are stateful. So if this instance initiate HTTP to this IP address on port 80, and it is allowed here, if the traffic goes out to the server, now the server is going to process it and respond. The response is going to be allowed automatically in the inbound direction, even if there is no specific rule to allow it. Why? Because in AWS, security groups are stateful. If you allow traffic in one direction by allowing the rule, whether it is outbound or inbound, if it was outbound, the response coming back will be inbound to the firewall. So that will be allowed automatically. If the traffic was allowed inbound to the instance and the response will be going out of the instance, that will be allowed automatically, even if you don't have a specific rule to allow it. All right? So please remember that the destination IP and the port are on the destination and not on the instance. So let's go ahead now and do a security group walkthrough in the AWS console. All right, so where would I find that? You can find it under EC2 and you can find it under VPC as well. So what we need to do now, let's go ahead and see the default security groups, how they look like, and what do they have in terms of rules in the inbound and in the outbound. So if you are in the VPC dashboard and you scroll down to security, this is where security groups are. You can also come from here and click on this. So I can click on security groups. So these both are default security groups. How would I know? They are named default, that's number one. And also, as you can see here, default VPC security group, default VPC security group. This is not what we created. I have two VPCs. We have the default VPC and custom VPC. And each VPC comes by default with one security group. What's my proof? Let's move to another region that I rarely use, Tokyo, for example. And let's check how many VPCs we have and how many security groups we will have. So let me make this a little bigger. So here we have one VPC, no name. And if we scroll to the right, it will tell me it's a default VPC, right? And if I go to security groups under security, you'll find there is one security group. It's called default, and it belongs to this VPC, and the description is default VPC security group. So it's all the same, but let me move back to Ohio so that we don't create anything and then we don't need it later on. It's not going to cost you anything to create VPC security groups and subnets and route tables and all that, but it's a habit that you only build resources where you actually need them, not just go randomly create resources anywhere. If you are used to do that, eventually you're going to create chargeable resources, forget about them, and then get a surprise bill. So let's go ahead and check one of the default security groups that is in United States in Ohio. So we have two VPCs, as we mentioned. The one that ends with D23 is the custom one. Let's refresh ourselves on that. So this is the custom VPC, D23, and this is the default, which ends with DE2. So what I can do in order to be able to know everything in my account, then what I will do is this one, I'm going to mark it as custom VPC default SG. So it's custom VPC default security group, and I'm going to save it. And the other one I'm going to mark it. So let's remove this, and I'm going to say default VPC default SG. So from now on, I know that this one I have created. These ones are the default ones. And if I scroll a little bit to the right, I'll find these two are in the same VPC. So there is no confusion there. Okay. What do we need to see? I need to see the default security group in the default VPC. How does it look like? This is the DE2. And if I scroll down, I'll find in the inbound rules and outbound rules. Inbound rules, there is no name for the rule. That's the default rule. And this is just the rule ID. So it's irrelevant to the actual impact of the security group. And it allows all traffic. All right. So what are the other options we're going to edit and see now? Allows all protocols, all ports. But here is the tricky part. If you didn't scroll to the right all the way. So this is how it appears when you open it. So it appears as it allows all traffic on all protocols, all port ranges. So they don't scroll all the way to the right to check the source. So this source is very tricky. So what does this source say? This is a security group ID. Each security group has an ID, as you can see here. And the source is the security group itself, A11 and EA11. So by default, the security group, the default security group, allows all traffic in the inbound direction from all ports, provided it is coming from the same security group as the source. What does that mean? It has to be coming from an instance that has the same security group applied to it, whether in the same subnet or a different subnet. So if it is coming from a different instance that has a different security group, this will not be allowed. It will not be allowed. No matter what the traffic is, if the source does not have this same security group applied to it, it will never be allowed. If you wanted to open up the inbound rules here, what you have to do is you have to do edit inbound rules. And you can delete this if you want. So I can delete, and then I can add rule, and then I can state what do I need, custom TCP or UDP. Is it ICMP or all TCP, all UDP, or you have all ICMP, IV4, all traffic, SSH, SMTP, and so on. So I can do all traffic from anywhere, and I can save it, but this is not recommended. And that's why they are stating here, rules with this source allow all IP addresses to access your instance. We recommend setting security group rules to allow access from known IP addresses only. Don't open up your security group widely like this because it could be dangerous. Now you are not limiting to anyone, and some of the IP addresses possibly that will come into your instance or will try to break into your instance could be ill-intended or malicious activity. So this is for the inbound. I'm not going to change anything because this is the default and I don't want to play with it. How about on the outbound? So please remember, the default on the inbound rule for the default VPC security group allows access to all ports, all traffic, only if it is coming from an instance within the same VPC that has the same security group applied. How about on the outbound? On the outbound, it allows IPv4, all traffic, all protocols, all ports to all destinations. Traffic from the instance going out is allowed to all destinations on all ports. Zero restrictions. That's for the outbound. The traffic that is initiated from the instance and going out. So everything is allowed. So that's the default. Let's look at the default security group for the custom VPC and see if there is any difference. For the outbound, it's all traffic, all to all destinations. So it's exactly the same like the default VPC default security group. On the inbound, you will see that all traffic, all port ranges, everything, if it is coming from the same security ID. If I want to edit, I would show you as well for the outbound, for example, then I can also do, for example, delete this rule and then add a rule. Let's say we want to allow only HTTP. So I'm going to allow HTTP. So this is the port on the destination. So this is outbound. Instance talking to a server. The server has HTTP port 80. And as soon as you choose HTTP, you will see here that it is port 80. What if I had a server operating on port 8000? So it is expecting to receive requests on port 8000. So in that case, you can say custom TCP, and then you can put 8000, and you can select what is the IP address of the other side if you know it. If you don't, you can allow all, or you can write down the range. So it could be 100.0.0.1/32, for example. So in that case, that means it's only allowed HTTP on port 8000 only to this server IP address. So you can restrict if you want, but in the outbound, you have to account for every single possible traffic that will leave your instance to the outside, originate from your instance to the outside. If this instance talks to a database, you have to allow that on the outbound. If this instance will talk, or you will look to this instance and you try to ping another virtual machine, then you have to allow that on the outbound. If the traffic is originating from the instance, starting from the instance, then the outbound rules has to be either wide open to account for anything, or it has to be detailed enough to account for all possible communications out. So this is very important to remember. All right. So that was our quick walkthrough. And of course, you can always go to security groups and you can create a new security group if you wanted. You can add rules if you want. Here by default on the outbound, it's going to allow all traffic outbound. On the inbound, you can add rules if you wanted, and it can be SSH or anything else that you need to allow. You can lock it down to what you want from which IP addresses, or you can write down the IP addresses if you know them put a description if you'd like, and then save, and that will start the security group. Of course, here, because I didn't add the information, it's asking me for it. So I'm going to skip that for the inbound rules. And I'm going to put a name for the security group. So my test SG. And I'm going to allow testing security groups. Anything that describes what we are trying to do. In your case, it's up to you. But here, you will always receive this warning if you leave things at 0.0.0.0. Now, if I check it out on the inbound rules, no inbound rules. So what traffic will be allowed to come into this instance through the security group? Based on what we have here, we have no rules explicit. That means we have 0 allows, which means if traffic is coming, originated from the outside, coming through the security group, it will be dropped. No matter what the traffic is, no matter where it's coming from. Because the implicit deny is the only rule that exists in this security group now on the inbound direction. How about if the instance would like to communicate from the instance to the outside? So let's check what is the outbound rule. It allows all traffic, all protocols, all port ranges to any destination. So any traffic going out from the instance through the security group, no matter what the port is at the destination, no matter what the IP address is at the destination, will be allowed. So in that case, it's wide open on the outbound. For traffic coming from the outside, it is widely locked. There is nothing that is going to pass. What if traffic from the instance, let's say ping, I'm on the instance at the prompt and I'm doing ping 8.8.8.8 and assuming that the internet is accessible to the instance. So the instance is on a public subnet. So the traffic will go out. It will reach Google 8.8.8.8. They will formulate the response and send it back. So it will come on the inbound of the security group. Do you think it will pass or it will be dropped? The response coming from 8.8.8.8 to me. The answer is, remember that the security groups are stateful. They have memory. So if anything was allowed in one direction, the response to that traffic will be allowed no matter what. So in this case, the ping response coming from Google back through the security group, despite the fact that there are no rules on the inbound, it will pass and the instance will see it. All right, so that is the statefulness of the security group. All right, let's go ahead and do some practice on security groups and stress the facts that we have mentioned. So we have practice number 1. And this is for inbound rules, and you are required to explain what this means. So we have a virtual machine with a security group, and the inbound rules look like this. The first rule is talking about type of traffic, HTTP, and the protocol is TCP, the port is 80, and the source is 0.0.0/0 means from anywhere. Anywhere could be from the same subnet, could be from the same VPC, could be from the internet, could be from another VPC. So I don't care where it's coming from, basically. Here it says, if it is headed to port 80, and that's HTTP, I don't care where it's coming from, allowed. And remember that we don't write allow here because there is an implicit deny at the end. The second rule we have, we allow SSH on port 22 from this specific IP. And why we are saying specific IP? Because it's /32. That means only this IP. So explain what does this mean. If you want to go ahead and pause, think about it, decide what it does, and then restart or resume the video again in order to see the answer. All right, so what does it mean? It means for HTTP port 80, anyone can access the instance over HTTP. Anyone can send inbound traffic to the instance over port HTTP, and no matter what the source IP address is, it will be allowed. For the second rule, it states that for port 22 TCP SSH, only this IP address 192.168.1.10 can SSH into the server. And this could be the IP address of the administrator who is allowed to get into the server, or the machine that is allowed to be used by the administrators to SSH into this instance for administrative purposes. Here's another one, and this is for outbound. So explain what this means. Outbound rules: type all traffic, all protocols, all port ranges, 0.0.0.0, and that's outbound, not inbound. Outbound means the rule will apply for traffic going out of the instance, initiated or originated at the instance and moving outside. So what do you think? Pause if it's not clear and try to go through it, and then resume to watch. So this means the server can send, or the virtual machine can send traffic, anywhere on any port. For example, download updates from the internet. Is this a recommended setting? The answer is no. But this is the default setting in AWS. They allow everything outbound and they lock everything inbound. Number 3, here's another example. Inbound rules that we need to explain what it does. Here we have SSH, TCP, port 22 from anywhere. And it's inbound. So we are talking about traffic coming this way. So anyone can try to SSH into the instance. I think that was obvious and easy. That's why I didn't ask you to stop and resume the video later on. Practice number 4. There's a custom TCP. So that's not a standard port. And the port is 5432. And we're talking about outbound rules. Destination is 10.0.2.0/24. Please remember that for the outbound, both the ports and the destinations are on the destination you are headed to, not on the virtual machine itself. So what does this mean? Here we just have a drawing for a subnet with this same range, assuming that this is within AWS. It could be outside AWS. Okay, so 10.0.10/24 is where the instance in question is. So this is applied to instance A. We're not talking about this one. So this is where the security group is applied. And now we are looking at outbound. And this is only allowed if it is going to 10.0.2.0/24 and on a specific port, which is 5432. Interpretation: this server, which is instance A, can connect to 10.0.2.0/24. So any instance within this subnet. This is not a /32. /24 means I have 254 usable hosts that I can send the traffic to. Of course, in AWS, you have the first and last, the broadcast IP and the subnet ID, and the first 3 more IP addresses, so the 1, 2, 3 as well. These are not allowed, these are reserved. So now if you have 251 IP addresses usable, then you send the traffic to any one of them on this port and things will be allowed. Of course, this is outbound here. If it's not allowed inbound in the security group here, it will not be functioning, although it went out of the security group here, but it was blocked here. So you have to allow the rules that are on security groups or security firewalls along the path, not only at the source. All right, practice number 5. Custom TCP, protocol is TCP, and port range and source. Source means this is inbound rule. All right, so always keep in mind. So now I'm talking about traffic that will be coming into my instances, and the source is 10.0.1.0/24, and that's custom TCP. It's a little bit confusing. Pause the video, think about it, and then resume to watch. So the subnet where the security group and the instance are is 10.0.1.0/24. And now we are looking at the inbound rule, let's say at the security group of this instance, for example. So I'm going to allow TCP port 3306 on the instance. So 3306 is a port on the instance, and that's a database port well known. only if the source IP address that sent in the request was within the 10.0.1.0/24, but that is my subnet. So this rule means we will only allow access to the port 3306 on the instance if the request was coming from within the subnet. So another virtual machine, another instance within the subnet, then we are going to allow it. And that's the interpretation. So only EC2 instances in this subnet can connect on port 3306, which is MySQL database, and that is the most used database on the internet. All right, so hopefully that was clear. Inbound and outbound, watch it. Remember that it is stateful, and always draw your flows until you get your head around it, and then you can do mind mapping to the flows and all that and decide what is right and what is wrong. All right, let's go ahead and do an in-depth security group practice, and we're going to involve virtual machines in order to know more and understand security groups much better than we did on the slide. So let's understand it hands-on. Let's get our hands dirty working with security groups. So we want to do a setup, a lab, hands-on lab in AWS that will be used for us to test and ping and SSH and all that stuff and see if it works or it doesn't work. All right, lab setup. Step number 1, we need to create 2 security groups, and we'll use the names security group A, security group B, and leave the default settings. And we're going to walk through the default inbound and outbound rules configurations on this default settings. So let's go ahead and do that first. All right, so I need to create 2 security groups. That's fine, easy. Security groups. We are going to name them SGA for the first one, testing security groups. And this is going to be in the custom VPC. We're going to do everything in the custom VPC. Inbound rules, I was told to leave it at the default. Outbound rules, leave it at the default. So I don't need anything else. Create. And now I need to create a new one. So I'm going to go back and create a security group. And I'm going to call it SGB as instructed, and testing security groups, and again in the custom VPC. If you create a security group in a VPC and you go to another one expecting that you created it in the second one, you will not see it. So security group as a resource is tied or confined to a VPC. It's not confined to an account where you can use it however you like. That's why they are asking me, where should this be created? And leave everything to the default as I was instructed and create the security groups. All right, let's check. Since both are identical, let's check one of them, SGB for example. So on the inbound, there is nothing allowed. On the outbound, all IPv4, all traffic, all protocols, all ranges to all destinations is allowed. All right, that sounds good. Let's go ahead and check step number 2. So in step number 2, we are going to create 2 virtual machines, 2 EC2 instances. One is called instance_A, so we have to use this name, and the other is called instance_B in the public subnet, or subnet 1 public. This subnet is in the custom VPC as well, the same VPC where we have created the security groups. All right, what else should we know about these instances? Create a key pair for each instance. Use the instance_A key and instance_B key for the key pair names. Ensure that a public IP address is assigned to each instance. Okay? And associate instance A with SGA and instance B with SGB. All right, we can reference that if we forget anything. So let's go ahead and create the 2 virtual machines. So I'm still in Ohio. What I will do now is I need to go to EC2 dashboard. If I click on this, it will open in the same tab. So I can right click on that and open link in a new tab. And if you look at the top here, a new tab will open now. So now I have access to the EC2 dashboard. And if I switch tabs, I still have access to the VPC dashboard. So let's go under here and launch instance. We are going to create the first one. So let me enlarge this a little bit. So this is going to be instance underscore A. And I was not told what's the operating system. So I'm going to go with Linux, Amazon Linux, free tier eligible AMI, Amazon Machine Image, or the OS of that instance. I'm going to stick with T2 Micro. I was not told anything, so I'm going to use the free ones. And of course, if your account is old or if you have run out of the AWS credits, these prices are going to apply to your usage depending on which operating system you are going to use. In my case, I'm not changing anything. Key pair for the first instance, this is instance A. I'm going to create a new one, and I was told to use instance underscore A underscore key for the name. And as you can see, it has been downloaded to my laptop. For network settings, I'm going to click edit. I want to make sure that it's going to be in the custom VPC to be able to use the security group. So custom VPC. And for the subnet, I want it to be in the public subnet, subnet 1 underscore public. And enable the assignment of an IP address, public IP address. And I'm going to select an existing security group, and that would be SGA. And there is nothing else that I'm told to do. Just a quick review, instance underscore A, Amazon Linux, T2 Micro, free tier eligible, the key pair as instructed, I've used the same name, network settings, custom VPC, and the subnet is subnet 1 public. Security group is SGA. So I've done everything as instructed. Are we done? No, we are not done. We still need to create a second instance, and we are given the details for that one as well. So I'm going to do instance underscore B. I'm going to copy this one. It will help me do things quicker. Amazon Linux and T2 Micro. And for the key pair, I'm going to create a new one, but this is going to be instance underscore B key. And create, and you will see that it has been downloaded as well. So I have instance underscore A key and instance underscore B key both downloaded to my laptop. I can click here or click the folder and it will bring it up. It will open the folder and I will see where that is. But in my case, I'm sure that it goes automatically into the downloads folder. In your case, most probably it's going to be also in the downloads, but you need to go and check that. Or when you see something like that on Windows, just click on the folder and it will open it up on the side to you, so you will know exactly where it went. Network settings, I'm going to do edit, custom VPC. And for the subnet, again, the same thing, the public subnet. So both they are going to be in the same subnet, which implies they are in the same availability zone. How did I know? Subnets do not extend beyond an availability zone. Select an existing security group, and I'm going to go in this case with security group B. And there is nothing else. Quick review, instance underscore B. It's Amazon Linux, T2 Micro, and the name of the key, custom VPC. It's in public subnet 1. And this one, see, always there is something that you may forget. After 9 or 10 years now with AWS, and I still rush things. So please be patient and don't rush things. Of course, as you grow in your career or as you grow in your cloud or network or anything, you will know that in the cloud, we actually do not usually work with manual stuff. We build scripts, infrastructure as code using Terraform or CloudFormation, and we submit these codes, and it has everything we need to do, and we don't need even to log in to the console. But that we will learn as we go. So security group B, everything looks fine, and the IP address is enabled. Everything is cool. So let's launch the instance. So now I have the 2 instances created as per the specifications I have been given. And this is what usually a cloud engineer would be doing, whether it is manual or through the Terraform script or CloudFormation script. You will be building infrastructure resources so the developers can use them, and the application architects and the application engineers and the software engineers can use it to test and deploy software. All right, so now we have the 2 instances hopefully up and running. Let me just minimize this a little bit. So I have instance A, instance B. What do we need to do now? Verify that the correct security group is associated with the correct instance. So I need to find out that SGA is with instance A and SGB is with instance B. And that's very easy to do. So all I need to do is click here, and under the security tab, this is for instance A. I'm going to scroll down and I will find that security group is SGA. And if I switch this tab, I'll find that security group on instance B is SGB. So all good. We have the security groups, we have everything. So now it's time for us to start testing. So what we have achieved now is I have instance A, instance B, and I have applied SGA on instance A and SGB on instance B. And they are both in the same subnet. Okay, so what do you need to do? From your laptop, from your machine, you need to try an SSH into instance A. And can you do that? Yes or no, and why? So from your laptop, this is SGA. From my laptop, through the big I, the beautiful internet, and of course, this is all inside AWS. We need to try an SSH into instance A. So I'm going to send SSH request through the security group A. Would that reach the instance and be successful or not? That's what we need to test. In your case, you will do it in the command prompt. If you are using Windows, forget about PowerShell for now. Command prompt, CMD, as we have seen in other labs. And in my case, or if you have a Linux machine, you're going to do it from the terminal, or you need to get into the Linux console and do it from there. But let's grab the command first. So I'm going to go into instance A. I'm going to click on connect and SSH client. And here are the commands. So this is the command that I need to see if it works or it doesn't work. So let's try. I'm going to go back to my terminal. I'm using Mac. Okay, so now just clear. So here we go. Let's paste the command and I'm going to hit enter. What do you think will happen? Why are we waiting? So nothing is happening. What do you guess is happening? So the question was, are you able to make it? Are you able to connect? And if yes or no, why? What do you think? What do you think the reason is we are unable to get a response and we are just waiting? And we'll keep waiting and waiting and waiting. And it will time out. The request is going to time out. If you ever get a timeout, that indicates for some reason the request has not reached the SSH server on the instance. And that's why you did not get a response. If the request reached the SSH server, you are going to get a response, and it could be a positive response or a negative response. But if it times out, as you can see here, that means it has timed out because the security group, for some reason, or the security in general, blocked it. In our case, it must be the security group. Let's go back to the VPC. And let's look at, this is instance A, so it must be SGA. So let's go back to security groups. I clicked on the VPC. I'm now in the VPC dashboard. And if we look at SGA, let me just shrink this down a little bit, or maybe just minimize this a bit. So SGA, here we go. SGA on the inbound, let's take this one up. It has no rules whatsoever, no rules. So definitely it's not going to allow SSH in, it's not going to allow ICMP, it's not going to allow anything. Let's verify. So let me try and ping the IP address of the instance, which is 3.140.186.254. So 3.140.186.254. Request timeout, request timeout, request timeout, request timeout. Of course. And if you try anything else, it will not work because it's not going through the security group. It does not reach the instance. The response to ping must come from the instance. The response to SSH must come from the instance. And if the request is not making it to the instance doesn't know anything about it. And why it is not reaching? Because the security group is dropping it. So if we go back here, no, I can't, and we know why we can't. So if we SSH from the instance to instance B, can we, and why? And the answer is, of course not. You want to try it? Let's go ahead. Remember that the two security groups are identical. So if we look at SGB, which is this here, on the inbound, same thing, nothing. Do you want to try it? Okay, fine. Let's verify. So I'm going to go back to instances. And this time I'm going to go to instance B. And I'm going to click on connect. Take the command. This is for instance B. And I'm going to try SSH. And the same scenario is going to repeat. So different IP address, different instance. Security group has exactly the same configuration. So you're trying the same thing with the same configuration. What do you expect will happen? It's going to be the same result for sure. So we'll leave it to timeout and let's go back and see what do we need to do now. Add the SSH from anywhere to the inbound rules in SGA and SGB. All right. So I'm going to go back to the VPC dashboard, and this is SGB. Let's do B first, edit inbound rules. I'm going to add a rule that is going to allow SSH, very specific, and I was told from anywhere, and we can write here, allow SSH inbound from anywhere. These descriptions will be helpful as the number of security groups and rules you have will grow to let you know what is this rule doing exactly. So save rule. And that was, we need to double check, that was in the inbound direction. And that is taking place now. So it's IPv4 SSH TCP port 22 from anywhere. So we need to do the same as instructed for SGA. So that's the inbound, nothing in here. Edit inbound rules, add rule, and also we're going to go do SSH from anywhere. And again, the same thing. Allow SSH inbound from anywhere. Okay. Save rule. Make sure that it has taken place. So SGA. And look at the inbound. And it looks like it is configured as expected. All right. So what do we need to do now? So that is done. SSH into instance A. Can you? Let's figure out. So I'm going to go back to the tab of the instances. I'm going to go to instance A. So let me grab instance A, click on connect, and SSH client. Let me go to the last and copy it. Now, see the request now. Oh, this is B, sorry. So B, before it timed out, we have put the rule in and now it has been accepted. So yes. And of course, we have a problem. It's unprotected private key file. So let me clear this one. As per the instruction, I need to try A now. So see, the response is very quick because it has reached the instance. Yes, and then we get the same error, unprotected private key file. So what do I need to do? We need to do the chmod and for the key name and all that. So instead of typing, I'm going to copy it. We need to do this in order to make the key private, not public. So I'm going to go back, paste, and hit enter, and then try the SSH again. The up and down arrow repeat the commands, the previous history, I mean. So this one looks like it's going to work now. And as you see here, let me do a clear. I am now in the instance as the user EC2-user on the IP address 172.168.157. How can we tell that this is the right IP address? Let's go back to the instance, click here, and look at the private IP address 172.168.157. 172.168.157. So now I am in instance A. So this was successful. Exit. And what we need now is we need to try to SSHB and see if it works. So this is it's A and this is still A. This is B. 3.148.115.161. So this is instance B. Enter. And again, the same problem. We need the chmod command. So I'm going to, let me just grab this one up. And let's do a clear. I'm going to repeat. And chmod, the only difference is this used to be key B. I'm trying to save time, but if you wanted to know the exact one, then you can go here. I can go to instance B, connect, and copy, and then go back. So I'm going to delete this completely. Just hit enter, I'll get an error. Oh, exit, quit, Control C. Yeah, so here I am. I'm going to do Control V, enter, and then repeat the SSH. And now it should work without errors. See, let's clear. All right, so hopefully that is clear. What else do I need to do? SSH into instance B, can you? Yes, I can. So we could do both of them. We are still with firewalls as network devices, and we are going to look at another example in AWS Cloud, which is the Network Access Control List, abbreviated NACLS or NACLS. So the NACL or the Network Access Control List is again a layer 4 firewall. It doesn't understand the upper layers, the application, and so on, and it applies at the subnet level. Before we proceed and we continue, please note the network ACL's part is an optional part for those who are not getting into cloud engineering, who are not getting into network engineering and network security. So that is optional. You have already knew what a firewall is and what it can do by learning the security groups. So if you are not planning to specialize in one of these 3 specialties, I think DevOps and MLOps to an extent are also included, then you can skip this part. But if you are going to learn the AWS Cloud and you're going to build infrastructures in the AWS Cloud, no matter what your role is, even if you are a developer, then network access control lists are very important because this is part of the security. And depending on what you are developing, it can be a mandate, not an optional thing to configure and lock down your network ACLs. All right. The network ACL is a virtual firewall that functions at the subnet level. Remember, we discussed the security groups, and we said that security groups apply at the instance level, at the virtual machine level. Now we are talking about the subnet level. So whatever is going to be allowed through the firewall, in or out, that will be at the subnet level. Whatever is going to be blocked from getting in or going out, it will apply to all the virtual machines in that subnet. So this is very important to note. The scope of the ACL is the subnet with everything inside that subnet. So the network ACL decides what goes into the subnet and what comes out of the subnet. The network access control list rules are numbered, unlike security groups where we just created rules. These ones have numbers, and the inspection, when there is some traffic and we need to decide, the network ACL needs to decide whether to allow it or deny it, it starts the investigation at the lowest numbered rule and then the next until a match is found. Once a match is found, it stops the search and then a decision is made. And we can configure allow and deny rules. Here's an example. I have rule 50, rule number 50, rule number 90, rule number 100, and then an asterisk. This one is an explicit deny. If no match is found, then there is a deny at the end. Parameters or variables that we configure, the type of traffic, SSH, HTTP, all ICMP, all TCP, all UDP, and so on. The protocol, what is the port or port range, and what is the source. So this one, for example, is for inbound rules. If it was outbound, it will be destination. And then we have allow or deny. So what is the action if there is a match? The security group functions at the virtual machine level. And we are saying that the network ACL functions at the subnet level. Where does it take effect? And the answer is it's at the implied router. Remember, we said each subnet is automatically connected to the implied router. So the best location to oversee the entire subnet is not to be inside the subnet. It is configured at the implied router and it functions at the implied router. The impact of the network ACL is applied or applicable to all instances in the respective subnet. So for example, if on this network ACL, we said there is no permission for any HTTP to go into the subnet. But here I have a web server. So this was, let's say, a database server, but this was a web server, a website. And the website is listening on port 80, which is by default HTTP. If you deny HTTP, it will apply to all the instances. For this one, it doesn't matter. It's a database and it functions at a different port, not HTTP 80. But for this one, what you have just done by denying HTTP to go into the subnet, you have denied any traffic from reaching this web server. That's why this will be broken. Having a network ACL configured, you need to make sure that at the network ACL, you apply the generic traffic that should be allowed or denied across the subnet. Then at the security group level, you can refine the allow statements to what this virtual machine should receive, and then the rest will be implicitly denied. Directions of traffic. If the traffic is going into the subnet, so coming from the router and it should pass through the firewall to go into the subnet, this is inbound, ingress to the subnet. If the traffic is coming out and it should pass through the firewall to go to the router and then somewhere else, that is outbound from the subnet. So inbound and outbound are from the perspective of the subnet. In security groups, we said they were stateful. Stateful means if traffic is allowed in one direction, its response will make it through in the opposite direction, even if there are no rules to allow it. In ACLs, it's completely different. It's stateless. So you want to SSH into a server, then you have to allow through the ACL SSH in the inbound to the subnet where the server is. You have to allow the response from the virtual machine or the instance going out to the user again. So you have to allow both directions. Otherwise, it will not function. So if we want to allow traffic on the inbound, let's say we want to allow all traffic in the inbound, then what we need to do is we're going to have a rule numbered, all traffic from all sources allow. If you don't do this, it's going to hit the explicit deny and it will be denied. And in the outbound direction, you have to have a rule that will allow traffic as well. Here, it's allowing all traffic to all destinations. If you don't allow it, it will hit the explicit rule. Do you have to do allow all? Allow all? Of course not. You have to lock it down to what is permissible. This is a wide open network ACL on the inbound and outbound direction, and this is not a good security practice, although it is the default in AWS. Why do we need the network ACLs if we already have security groups? We add an extra layer of protection at the subnet level. So you have the security group at the virtual machine level, and you have a second layer of defense at the subnet level. Also, if you would like to deny specific traffic, let's say we figured out after investigation that there is a specific range of IP addresses coming from a specific country, and that is malicious, that always tries to hack into our website or our network or our VPC presence. We would like to deny that traffic completely and allow the rest of the internet. So in that case, then since we can do deny and allow, I can have a rule in the inbound to deny the range for any port, for anything. And then afterwards, let's say the first one is rule number 100. The second will be rule 110 or 200, and it will allow traffic from anywhere else. Also, if you want to block IP ranges at the subnet level, and you are working on a compliance-heavy environment where they need multiple layers of protection or firewalls. Let's go ahead to the AWS console and have a look at the network ACLs, how they are configured, what parameters are there, and what are the default settings in the default network ACLs in AWS. So here I am in the AWS console. I want to go to the VPC dashboard, and I want to go under security, and here is network ACLs. So we have an ACL. Here is the ID of the ACL, no names. And here's another one. This one is applied to 4 subnets. This one has applied to 3 subnets. I'm still in Ohio. It's a default network ACL, so which means created by AWS. I did not create it. And this one is in the default VPC. And this one is in the custom VPC. So let me go ahead here and write down some labels that will help me. Custom VPC. And this one is default VPC. Always the tags or the labels, they will help you as you work through your exercises and projects, because you want to quickly identify the resources that you would like to check, troubleshoot, manipulate, edit, and so on. Okay, so let's look at the default VPC network ACL. And here is the ACL. Let's look at the inbound rules. Here you'd see at the inbound, all traffic, all protocols, all ports from all sources is allowed. So all the traffic coming inbound through this ACL is going to be allowed inbound, no matter where the source it's coming from is. And on the outbound, rule number 100, all traffic, all protocols, all ports to all destinations. Outbound means it's leaving the subnet to a destination. So all destinations, so that means the virtual machines on this subnet can send traffic to anywhere on any port. Basically, the inbound and outbound by default does not filter anything at the network ACL level. Is this a good security practice? The answer is no. You need to lock it down. You need to identify what is allowed outbound, what is allowed inbound, and lock it down to that, and don't be generous when it comes to security. And this VPC network ACL is applied to 3 subnets, and these are the subnet IDs. And these are the default subnets in the default VPC, which we did not create them. How about the other one? So this is a default network ACL in a custom VPC. Let's see how different that would be. So actually on the inbound, there is no difference. It's exactly the same. And on the outbound, there is no difference. It's exactly the same. Please note that it is the destination in the outbound, the destination IPs, and the destination ports, like in security groups. For the inbound, it is the destination ports in the subnet, in the virtual machines in the subnet, but the source is where it came from outside the subnet. So the source in the inbound is where it came from the outside to the subnet. And this one applies to 4 subnets, and these are the subnets that we created. Subnet 2, 3, 4, and subnet 1 public. Remember, in custom VPCs, there are no default subnets. You have to create the subnet. So these are the ones that we created. Now, if I want to associate a VPC network ACL with a subnet, then you can go into subnet associations, you can edit, and then you can identify which subnets are going to use this ACL and which will not. Since I have only one ACL, all the subnets will have that ACL applied to them. So it's like route tables. If you don't create custom route tables, there will be one main default route table for the VPC, and that will apply to all subnets in the VPC. Same thing for the ACLs. It's one default ACL per VPC that allows all the traffic in and out, and it will apply to every subnet that you create, unless you start creating your own custom ACLs and you start associating them with the relevant subnets that you want. All right? So these are default settings. Network ACLs don't filter anything. So this is how it is. Let me just go back. What if I need to add a rule or change a rule? You can edit. So this is on the inbound direction. Where do you want the rule to be? Please remember that the inspection always happens when there is some traffic coming into the subnet. This is inbound, coming into the subnet. Then it will always start the inspection from the lowest numbered rule. So if you want to add a rule that is going to be inspected first, you have to add a rule number that is lower, not higher. So 50, for example, and then allow, or let's say that this one is going to deny SSH from a specific IP. So let's say deny And we're going to add 100.1.1.10/32. So that's a specific IP that should not process or should not access SSH into the subnet. So when we look at the rules now, you will find that it has been sorted according to the rule numbers. Let me just minimize this a little bit so I can drag it up and you can see it. All right, so I'll keep it large. Inbound rules, it has a new rule, 50, and that's for SSH, TCP, port 22, and the source is this specific IP will be denied. Now, what about the rest? What if a different source IP tries to SSH? Then this rule will not match. Then it will skip to the next rule, which allows all traffic. So anybody else will be able to SSH, and anybody else will be able to do all the other ports. And even this IP address can do HTTP, can do ICMP, can do a lot of things, but not SSH. So doing so, and the fact that we can have deny rules more specific, we can put the denies at the top, and then the rules that will come after will define what is allowed. So this is how flexible network ACLs can be. So hopefully this is clear. And you have seen how we can edit rules, and we can do the same thing for the outbound as well. So you can do edit rules for the outbound, and then you can add what's to be denied and what's to be allowed. Please remember that network ACLs are not stateful. They are stateless. So hopefully this is clear, and that was a quick walkthrough into network ACLs. All right, let's now do some hands-on practice where we are going to demonstrate the fact that the network ACL is stateless, and we'll show that we have to configure both sides of a communication in order for that to work. We'll also show the rule numbers and their priority, and some other stuff. So let's find out what exactly we are going to do here. If you don't have this done earlier, please create two security groups, security group A and security group B, and ensure they allow all traffic inbound and outbound on all ports. Basically, what we are trying to do here is we are trying to show the impact of network ACLs. We're not going to examine what the security groups can or cannot do. That's why we need to have them wide open, and they are not going to block any traffic in or out. So if a blockage happens, this is because of the network ACL. If any traffic succeeds, is also because of the network ACL. So we can focus on the network ACLs and show their features and what the inbound and outbound rules impact is in network ACLs. So in my case, I'm going to go into the custom VPC. All the work will be done in a custom VPC. And I'm going to go ahead and look at the security groups, and I have SGA and SGB. So all I need to do is to make sure they allow all traffic inbound and all traffic outbound. So here I had them do some traffic, not everything. So I will edit inbound rules. I'm going to delete all the rules, and I'm going to follow the instruction. Allow all traffic from any source. That's inbound. All right, and I'm going to go back on the same one. Verify that it allows all traffic from any source on the inbound. And then I'm going to go on the outbound rules and do the same thing. Check. It's actually allowing all traffic from only one IP address, but I want it from everywhere. So if I do a final check, always a good idea. On the outbound, it allows all traffic from any source, and on the inbound, it allows all traffic from any source as well. All right, so we are good for SGA, for security group A. For security group B, inbound, also we have some selective allows. So we're going to delete, add rule, all traffic from any source, save, that's the inbound. We need to do the same for the outbound. So I'm going to go again into SGB. Just verify that inbound is correct before we do the outbound. Outbound rule. And there are no rules whatsoever. And we need to add a rule, and that will be all traffic from any source and save. I didn't put any descriptions, but it's a good idea to put descriptions because it will help you find out as the number of rules grow, why did you add that specific rule. Okay, so we did SGA and SGB. Step number 2, create two EC2 instances, instance underscore A and instance underscore B in the public subnet, subnet underscore 1 public. Create a key pair for each instance and use the names instance underscore A underscore key and instance underscore B underscore key for the key pair names. Ensure that a public IP address is assigned to each instance and associate instance A with SGA and instance B with SGB. So in my case, I have these two instances created. I'm going to show you how they look like, and I'm going to verify that they are associated with SGA for instance A and SGB for instance B. Also, I will show you that we have a public IP for each, and I've already done the keys as well. So if you haven't done it, please go ahead and do it. And for me, I'm going to show you what I have. I'm going to go into the instances or the EC2 instances, and you can simply do that, EC2, and then right click, open in a new tab. I have it open already. So here I have two instances, instance A and instance B. They are both in the stopped state. So what I will do now is I'm going to start them both because we need to use them. If we need to verify what configuration they have, this is instance A. So it has a public IP, it has a private IP. And if we go in under security, you will see here that SGA is allocated to instance A. And you see that on the inbound, it allows everything from any source. And on the outbound, allows everything from any source as well. If you want to connect to this instance, you'll find that the instance A underscore key PIM is the key. And we need to do the key to make it private if you are using Linux or Mac. And this is the command to use in order to connect. All right, so this is instance A, and instance B is exactly the same configuration, but with instance B, and the key name is instance underscore B underscore key. And if we verify quickly, security group SGB, and it does have details, public IP, private IP, and we can look at the key pair name from here. So instance B key.pim. And here is the command if you want to SSH into the instance. All right. And let me check the state of each instance, and they should be up and running right now. So all done. Now let's do the first test. ICMP test using ping to the public IP addresses. What is the instruction? So now I have the two instances, instance A and instance B up and running. This is with SGA, this is with SGB. Both are in the same subnet. And we're going to do some ICMP tests now. So from your laptop, ping the public IP address of instance A and instance B. Can we, and why? Let's go ahead and get the public IP address of instance A. So here is the public IP address of instance A. Copy it. This is copied. I'm going to go into my terminal. In your case, you'll go into command prompt if you are using Windows. So let me do a ping. And you can see that it works. If I try to B, I'm going to stop it. Let me go into B. And copy. Go back. Ping. And it works. So now let's go back to the instruction. Can you? Yes, I can. Why? First of all, the security groups, SGA and SGB, they're not filtering any traffic. How about the network ACL? We haven't checked that. We don't know. So I need to make sure the subnet 1 public is associated with which ACL. I need to go and look at the inbound and outbound rules of that ACL in order to be able to respond and say why. So let's go under network ACLs in the VPC. security network ACLs. We have only 2 network ACLs. This one is the custom VPC one. So let me click on that. Let's verify that it is associated with public subnet 1 public, and it's associated with this ACL. So let's look at the inbound rules. Inbound rules in the ACL, they deny SSH in, but they allow all other traffic. That's what's happening right now. So let's bring it to the default. The default usually is that it allows everything in from any source and everything out to any source. Okay, so this is the default on the outbound, and this is the default on the inbound. So why did the ICMP ping work even when we had the SSH denial rule? Because I was sending ICMP, and that's why it is still working. As you can see, it is still running to instance B. If I stop it and I start it again, it will still work, because the ICMP is allowed through the network ACL, through the allow every traffic in and out, and also in the security groups, allow all traffic in and out. In the network ACL, block ICMP inbound from any source. So block all ICMP v4 inbound from any source. Okay, let's go ahead and do it. This is the network ACL. I'm going to do edit, and I'm going to do add new rule. To add the rule above 100, so it will be investigated first, or below 100, so it will be investigated after the allow all traffic. Let's try both. Let me try and add it as 150. And I'm going to say this is for ICMP IPv4 from anywhere denied. So when the inspection happens, 100 will be inspected first, and it says allowed. 150 will stop ICMP specifically from anywhere. So let's go ahead and look at the ACL again, at the inbound rules, and this is how it looks like. So this one will be investigated first, second, and third. If this one has a match, it will not go to the second. It will make a decision, allow, and it will continue. If it did not allow here, then the deny will take effect. So let's find out if the first one is going to be used or the second one. As you can see, the ping is still ongoing, 120, 122, 124, 126, and so on. So the ping did not even take effect because the allow at the top was the one that was considered, and this proves that rule numbers are extremely important. And if one match is obtained from the lowest numbered rule and to the next one, once a match happens, the investigation aborts with the decision of that rule. So let's do one thing here. Let me go again on edit, and what I will do is I will make this 50 only. So the deny rule will be above the allow all traffic. So this is how it looks right now, and denied. So let's go ahead and check. You'll see that the rule or the ping has stopped. Why? Because now it has investigated the first rule, which is ICMP denied, and that's why it stopped. If I remove that rule, everything will work again. And let's try one thing more before we change it. So here I was pinging, this is the IP address of instance B, the public IP address. Let me try the other one, this one. This is for A. It will not work as well. Why? Because the network ACL is blocking ICMP from anywhere to go anywhere into this subnet. So instance A and instance B are in the same subnet. So whatever the network ACL decides applies to everyone in the subnet. If it was allow, then everyone is allowed. If it was deny, everyone is denied. So what happened to the ping? It stopped when we blocked it with the rule number 50. With the 150, it did not stop it. From your laptop, try to ping again to instance A and instance B's public IP addresses. It's not working. We tried. Okay, let's do one more thing. Instance A and instance B, we tried from the outside and we saw the impact of a network ACL rule. What if I block ICMP inbound and I block ICMP outbound? and I try to SSH into instance A and ping instance B, private IP, so they are both in the same subnet, is that going to involve the network ACL or not? If the two instances are within the same subnet, will the traffic go up to the implied router where the network ACL is and then come back? Or would it flow internally with complete ignorance of what the network ACL does? We need to block ICMP ping from any source inbound and outbound, and we are going to use rule number 50. And we are going to allow all other traffic inbound and outbound with rule 100. So I think for the inbound, we already have this done. So let's do it on the outbound. So for the inbound, I have rule number 50, denying ICMP from anywhere. And I have rule 100, allowing traffic from anywhere. On the outbound, I need to do the same. So I'm going to edit, and I'm going to add rule number 50. And this will be for ICMP v4 from anywhere. And that would be deny, not allow. ICMP version 4 from anywhere, deny. So when we look at it, it will look like this. So ICMP in and out of the ACL is going to be blocked. However, any other traffic from any source will be allowed. That's how it is now, inbound and outbound. All right, what do we need to do? So this is done. SSH into instance A. Sure. So I'm going to go into instance A, get the SSH rule from connect, SSH client, and I'm going to copy this. So let me stop this failing ping. I'm going to clear the screen and then SSH into instance A. Yes. And here we go. I'm going to clear the screen. So now we are into instance A. I'm going to elevate the permissions to the root level, super user. Okay, what do I need to do now? From instance A, use ICMP ping to the private IP of instance B. So I want the private IP of instance B. Instance B, the private IP is this guy right here. And I'm going to ping it. And it is working. So the network ACL in the subnet where both instances A and B exist is blocking ICMP inbound and blocking ICMP outbound from anywhere. However, when I am inside instance A, I am at the prompt of instance A, and I try to ping instance B, the traffic is successful, which implies that the network ACL has not been checked at all. It has not intervened in this communication. And the reason is that you need to keep in mind, when will the traffic from the subnet go through the router? It will only go through the router. Let me draw it here. It will only go through the router when the traffic needs to leave the subnet, or if the traffic from outside is coming into the subnet. In our case, this is all local to the subnet. So the traffic goes out and goes in here. The response goes out and comes in here. So the network ACL is not involved at all. The implied router is not involved at all. That's why it was successful. So this is a very important thing to keep in mind as well. So we looked at the rule numbers, but let's find out what is this about. SSH from your laptop into instance A. Can you? Why? Yes, I can, and I know why. SSH from your laptop into instance B. Can you? Why? Because the network ACL is allowing it. What else? Now on the default knuckle in custom VPC, add a rule to block SSH from anywhere with rule number 50. All right. I'm going to go into the network ACL, and I'm going to add a rule that will, let me make sure that whether we need this one or not, but let me add that rule first. Add a new rule. Let's say it's going to be 75 or 80, 70. Should block SSH from anywhere, and that should be a deny. See if changes. So now there is an allow all traffic, which is number 100, deny SSH, which is number 70, and deny ICMP, which is number 50. All right. to block SSH from anywhere with root number 50. I cannot do it because 50 is taken. Okay, so let's proceed and see. Try to SSH again into instance A and instance B. Can you and why? Let's find out. So now I'm going to stop this. See, I'm not connected at all. And 143, 142, this is not running anymore. I lost the connection. The SSH connection is lost. So what do I need to do? I'm going to open a new terminal. So shell, new window. And from here, I want to try and SSH into instance A again. So let me close this one, terminate. And I want to SSH into instance A. Go back, instance A, connect, copy, and Control V. I need to go into the right folder first, where the key is. CD downloads. That's where my key is. And then I'm going to do Control V and SSH. And do you think it would work? I don't think so, because rule number 70 is where the SSH blocked, and rule number 50 is ICMP blocked. So it will hit number 70 before it goes to 100 that allows everything. And that's why I won't be able to. Control C. So I couldn't, because the network ACL is blocking it, and that's why I couldn't. From your laptop, use ICMP to ping the public IP address of instance A. Can you and why? In my case, I'm not going to be able to, because I have rule number 50, and rule number 50 is denying ICMP from anywhere. That's why I will not be able to. However, if we remove rule number 50, then we will be able to ICMP ping, but we are not going to be able to SSH into the instance. So that's the case here. All right, network ACLs are stateless. So this test is going to show us that fact. In the custom VPC network ACL, allow all inbound traffic from any source. Okay, so let me go and clean up that one. So we're back to the ACL. I'm going, and this is inbound. I'm going to edit. And I'm going to allow all traffic from all sources. So I'm going to remove the deny, remove the other deny, and this one will take care of allowing all traffic from any source. What do I need to do? Delete the rule in the outbound that allows all outbound traffic. But before I do this, let me check if I will be able to SSH before we do the delete rule. And then we will find out after removing that if we can or we cannot. So let me from here try the SSH first to make sure that it works. And after I make sure that it works, then I can try, yes, it works. So now I know that it works. I'm going to exit. So I'm back to my prompt, clear, back on my laptop. Now I will do what was requested, which is remove the rule that allows all outbound traffic. So I'm going to do edit, and I'm going to remove this and this. So the only rule that exists is the explicit deny all. As you can see now on the outbound, I have only the deny rule, and on the inbound, I have allow all. Why are we testing this? Because I will show you that if the traffic is allowed in one direction, but the other direction is blocked, then the entire result or the whole result, the end result would be the traffic is blocked. Let's verify this. Go back, and I'm going to try and SSH again. And this will not work. Why? Because it reaches the instance, but the instance's response is blocked at the network ACL. Why did it go through the network ACL? Because my laptop is connected to the internet. So that is outside the subnet where the instance is, so it has to go through the ACL. The general rule is if the traffic leaving the instance is going outside the subnet where the virtual machine or the instance is, it has to pass through the router. That means it has to pass through the network ACL of that subnet. Okay, so it will time out and it will not work. For obvious reasons, it is not allowed because it was blocked. All right, what I will do now is I'm going to go and clean up the network ACLs and make it again like the default, allow all traffic in, all traffic out. All right, so inbound looks good. Outbound, I'm going to bring back the rule that we have removed because otherwise nothing will be flowing in or out of this subnet. So I'm going to use rule number 100 for all traffic, all sources allow. And just to verify, Can I SSH? I should be able to. Yes, I can, and that is enough to make sure that it went back to normal. Clear, and we are good to go with this hands-on lab. In Module 9, we are going to learn important IT services and observability as well. It's good to have the infrastructure up and running that you have built, or the network and so on, but it's more important to know that it's functioning properly. So you need to have monitoring in place to monitor the infrastructure or the network or whatever you have built in real time. Make sure it is performing as expected, and if not, then send you notification or alerts. Also, for compliance reasons and for troubleshooting purposes, you need to have logs. You need to have the history of events that happened in your infrastructure or application or network, and these are called logs. Also, we are going to introduce the domain name system or the domain name service, the DNS. When you type www.cnn.com or google.com in your browser, that is not how the internet works, right? This is a name. All the internet only relies on IP addresses. So what would translate the www.google.com that you type, which is easier to remember, into an IP address? That is the DNS. So we're going to introduce that as well. And we're going to have an introduction to databases. So we have mentioned data in a database. Why do we need a database? What are the types of databases? All of this we are going to learn here, and we are going to end up with a very important training, which is how to draw professional architecture drawings. So all of this in this module, lots of stuff to learn. So let's start with DNS, domain name system or domain name service. As we know, websites, all the internet use IP addresses. However, it is much easier to remember names than remembering IP addresses. Imagine if you had to memorize the 15, 20, 30 common websites that you go to all the time, and you had to maintain and memorize their IP addresses, which will be a nightmare. For example, here we have a web server, www.dolphinedacademy.com or dolphined.com, and this is the corresponding public IP address. When you want to go to Dolphin Ed Academy, you're not going to type the IP address because you don't know it, and you're not going to search for it, but you know that it's called www.dolphined.com, or maybe you have it saved in your preferred domains. So you click on that, and then magic happens in the background to find out the IP address, and then a packet will be formed, and that will be the destination IP address in the packet. And since it is easier to remember names than IP addresses, the domain name service are the translator, the interpretation of domain names into IP addresses. That is what DNS is all about. So here's an example of a DNS server. Let's say the server of the DNS, the IP address is 1.1.1.1, just hypothetical example. And it will maintain a database, and here is a snippet of the database. Dolphined.com, this is the IP address. Example.com, this is the IP address. Marketing.abc.net, this is the IP address. And of course, it has a huge database that involves all of the known domains and subdomains in the internet. So if you want to visit dolphined.com, what you need to do is you are going to use the internet and you are going to use DNS. But how would your laptop know which DNS IP address to send the request to? It's called DNS query. Any client that will be configured, your phone when it connects to Wi-Fi, your laptop when it connects to Wi-Fi, or any other network, it will have a DNS server configured, and this is automatic from the Wi-Fi device. So you will get an IP address, and you will get also the DNS configuration, or maybe it is static configuration on your laptop or your device. So now when you want to go to dolphined.com, you go in your browser and type dolphined.com. Now in the background, the browser is going to formulate a request, a DNS query, and it will send it to the IP address of the DNS server configured. Can I please have the IP address of this subdomain, www.dolphined.com? Now the DNS will check its database to find out that it has it, and here's the IP address. So it's going to respond and say, here we go, the DNS response, the IP address requested is such and such. Now the browser and the IP stack on your machine, they know the IP address, the destination IP address, and they will form the packet and send it to dolphin8.com. Of course, the internet is going to forward that, because as we knew and as we learned, that the internet knows how to get to any public IP address anywhere in the globe. Now, how can I find out on my laptop, whether it is Windows or Linux or Mac OS, how can I find out the DNS configuration? What's the DNS server that I'm using? And also, how can I find out the IP address of a specific DNS? Let's say that I want to find out what is www.dolphin8.com. What's the IP address corresponding to it, or cnn.com or google.com. Then you can use the command nslookup and the name or the domain or subdomain you would like to look up. If you would like to find out about the IP and the DNS information in your machine, if it is Windows, you can use ipconfig/all. If you are on a Linux system, depending on what type of Linux system, which distro you are using, then you can do cat for the etcresolve.conf file. Cat means show me the content of that file without opening or editing the file. Linux also systemd resolve -- status or -- status. This is for systemd based systems. If it is network manager like Red Hat, for example, real, nmcli, all of these are going to give you the same thing. What is the DNS information that you are using? What's the DNS server that you are relying on? All right. So these are good stuff, DNS server, and here's the DNS server as well for Linux, and this one would show the domain. Whether it is Windows or Linux, the nslookup will show the IP address of this domain or subdomain that you have typed. Let's go ahead and do a demo and show you DNS in action on an AWS Linux EC2 instance. So we need to have a Linux instance in AWS. It needs to be in a public subnet, and we need to ensure that it has a public IP. We are going to associate with that instance while creating it a security group that allows all traffic, inbound and outbound. And we have one that does that. We are going to SSH into the instance from the console, and then we're going to start the testing. So let's go ahead and create the EC2 instance with this specific criteria and SSH into the instance. So we're going to go into instances and then create instance or launch instance. I'm going to call it testing DNS. I'm going to choose AWS Linux. T2 micro is fine. Key pair, I'm going to choose one of the key pairs that I have. In case if you don't have one, please create one. You know how to deal with them now. I'm going to choose this one, which I've used before. For the network, I want to make sure that it is in the custom VPC, the VPC that I have created and I know everything about, and in a public subnet as requested. And I want to make sure that the auto-assign public IP address is enabled. For the security group, I'm going to select one that I have, which allows all traffic in and out, SGA. And that's it. Let me just go back quickly and confirm that I have done everything right. AWS Linux and T2 micro, key, custom VPC, public subnet, and enable, and I created or selected existing security group. So I'm going to launch it. And once I launch it, I'm requested to connect to it through SSH or using SSH. So what I'm going to do is so once this is highlighted in blue or colored in blue, I can click on connect and I can use SSH to connect. So let me try from the outside. Here's the instance, connect. And I'm going to use EC2 instance connect. Instead of SSHing from my laptop, I'm going to do it through the console. Connect. And you will notice that it will open a new tab for the connection. And it shows me here what is the public IP and what is the private IP. And here you go, I'm connected. elevate the permissions to root. So as you can see here, it changed from EC2 user, which is the user we used to connect using SSH, and now I am root, so I have all the privileges that I have. Let's find out what we need to do. So all of this is done. Check the DNS server on the instance. How? We can use the cat etc resolve.conf, or we can use the systemd resolve -- status. So let's find out. So cat etc resolve.conf, and if you look here, this is the line we're looking for. Name server is 172.31.0.2. So the DNS server is an IP address, the second usable IP address in the subnet, and this is the name server. So all the queries are going to go into this IP address, DNS queries as the server, and that server from AWS, or that DNS server from AWS, if it knows the answer, it will respond. If not, it will query the internet, find the answer, and send it to you. Or we could have done also the systemd resolve status. And it gives me the same information that we have received here. So if you look at this and you look at this, it's exactly the same answer. We are now sure that there is a DNS configured on the machine, and that's how we can get to the different domains on the internet. So for example, if I do dig www.google.com, in the answer section, you'll find that this domain maps to this IP address, 142.250.190.68. And also I can do NS lookup for the same domain, and it should give me a similar answer. Look at this IP address and look at this IP address, but the NS lookup will give you that in a different format. So here is the DNS, and here is the IP address of google.com. Also, it gave me the IPv6 address of google.com. So it resolved both IPv4 and IPv6. So we did this step already, DNS lookup. Oh, actually it's NS lookup, not DNS. So forget about this D, NS lookup. So now we need to influence a change in how the local DNS sees www.google.com. The dig command, let me clear this. The dig command goes straight into the DNS and finds the IP address and goes out. But if we use ping, for example, www.google.com, it is working and it is responding. But the ping, what it does is it checks local files, local DNS files first, and if not, then it will query the DNS server. Ping does that. So here, when I ran ping, it translated www.google.com into this IP address. Let's now do one thing. Let's do nano, and here is a file where I can define hosts, etc hosts. So I'm going to go below and I'm going to do 10 or 172.31.0.55 maps to www.google.com. So what I am doing now is in a local DNS file, and I'm going to define www.google.com as a local IP address, a private IP address, 172.31.0.55. Control X to save, yes to confirm that we need to save the change, and hit enter. Now if I do ping, what happens? Let's find out. You'll find that instead of going to this IP address, 142.250.190.36, which was working, now it's going to a completely different IP address. Let me stop this, Control C. It's going to the 172.31.0.55, which is the one in the hosts file, in the etc/hosts file. Whereas if I do dig www.google.com, it will not check any local files. It will go straight into the DNS and it gets me the correct IP address. There are ways that for some of the tools like curl and ping that you can influence locally what some domains would look like. whereas dig will always go to the DNS server and get the correct information. So we did the change and that worked, and we did ping and it used the IP address in the etc host file, whereas if you do dig, it is going to use the one from the DNS, which is the correct one, and that is how dig works. All right, hopefully that clarifies at a basic level how the DNS works. In the AWS cloud, there is a service called route 53. Let me show it to you. So if I go here and I type route 53, if I right click on this, this is a DNS service that can be used even for big corporates if they would like to host their domains and details in AWS. You can register domains and you can create hosted zones, basically records in these domains to tell what www.dolphin8.com means, what marketing.dolphin8.com means, what example.com means, and so on. So you can rely on AWS completely to provide you the DNS server in the cloud. But we are not going to dive deep into this because this is beyond the fundamentals. All right? Hopefully that was clear, and thank you for watching. Let's now talk about monitoring, alerting, and logging, and why these are important and what can we use them for. Monitoring is watching the system metrics in real time for health, performance, and security. So monitoring in real time means as the events happen, as the status changes, as the performance degrades or enhances, that means monitoring in real time. So you are recording in real time what's happening in the system. And if you have a monitoring tool that's like an eye on the system, then that can tell you, for example, if that was a virtual machine, what's the CPU utilization, what's the disk space taken, what's the network in and out traffic, and so on. So it can give you a lot of things, and these can help in the health, in the performance, and in the security of the systems. So monitoring can be monitoring security, performance, or health, or all of that together. So here's an example from my Mac OS. There is a tool called Activity Monitor. I'm going to show it to you right now. So as you can see here, we have the CPU utilization, CPU time, and we have also memory information about the memory for the different applications that I'm running. We have energy, we have disk, we have network. So we have a lot of things that we can see about this Mac OS, this laptop in real time, and the applications running and their statistics, what CPU they are taking, and all that stuff. So this is monitoring for my system, for my laptop. That is what is being monitored right now. In Windows, you have something called Task Manager, which I'm going to show you in the demo as well. Something similar to this that will be about your laptop or your server. It will tell you about the resources, the utilization of the resources, the percentages. So for example, here on the left-hand side, if anything is close to 70, 80, 90%, that means it's taking a lot of resources. And also I have it here as a graph at the bottom that shows if it's working fine or if any is taking more than it should. CPU utilization, the percentage of the CPU, and how many threads, and so on. These are metrics for the monitoring. And using these metrics like CPU utilization, I can find out if everything is okay or not. Memory utilization, disk space, network in, network out. All of these are metrics that will tell me by looking at them how is the system doing from that perspective. Then alerting, notification basically. So getting notified when some pre-identified events happen or thresholds are crossed is a good thing. That's what alerting is. So it could be performance related, could be health related, or security related. For example, if someone is trying to SSH into an instance and it doesn't pass, it doesn't succeed, and it fails repeatedly, I need to know someone is trying to hack my systems. For example, if the CPU utilization of one of the critical server reaches 80% or 90%, I need to be notified even if it is at 3 o'clock in the morning, because that is a critical thing. That will affect the response time, that will affect the performance of the server and application, and that will cause a lot of issues when users will start to complain. One of the examples where you can be notified in AWS is when you have a budget alarm. So basically you tell AWS, you know what? If I am getting the consumption is expected to cross or be higher than $3.60 a month, please send me an email or send me a notification. And here's an example of a notification that I have received when the cost, the budgeted amount for the month, I don't want to spend more than $6, but please let me know when I reach 60% of that. So I was told that it's going to get to $4.84 if you keep the same utilization for the month. So this is an example of notification where I was informed based on a configuration I have done about this event. If it didn't cross the threshold, I wouldn't have received any emails or anything. Similarly for security, similarly for performance. Then we have logging. Logging is an archive, storage of events or errors related to a system. So if you are logging, for example, who had access to your account, who had created EC2 instances in your account, who had deleted EC2 instances in your account, if you can find these logs, if a problem happens, then we can go back to the logs and find out who did what and at what time to what service and who deleted or who created and so on. So this is good both for auditing, if you are in a business that requires compliance, and also for troubleshooting, if we need to find out the reason for the problem that happened or the outage that happened. And in AWS, we have a service called CloudTrail. Any logins, any sign-ins, any creation of virtual machines, any deletion of virtual machines, any creation of subnets, VPC, root tables, security groups, network ACLs, all are going to be logged here. Any action on AWS services in your account is going to be logged here with the time it has happened, who did it, which user, and what was the event source, and so on. A lot of details. And if you click one of these links, you will find that out. Let's look at this service. So I'm going to go here and type CloudTrail, and I'm going to open a new tab. We have so many tabs open now, but let's go into this service. And this is enabled by default in your account, in any AWS account, and you don't pay for it. So if I look here, if I click here and I look at the event history, and this is of course about my account, and this is the account ID, you'll find here that send SSH public key, and here it has the date, who did it, and EC2 instance and the ID of the instance that was affected with that. And if we click on that, you'll find more details. So you'll find the timestamp, who did it, the user, what was the event name, event source, event ID. You have here the instance ID and the details of the event. I don't want to drag you into what this means right now, but this is a lot of information that is very useful when we need to troubleshoot or find out what has happened and who did it and so on. And those events are kept by default for 90 days free of charge. After 90 days, they are purged. And if you want to keep them, you can export them and save them in a storage that you will pay for. Also, we have a service called CloudWatch. And this is for monitoring in your account and for logging in your account and for alerting as well. So it has, as you can see, it has insights, metrics, alarms, dashboards, and services. So let's have a look at this service, CloudWatch. For example, if I go into metrics, all metrics, scroll down a little bit, you'll find here EC2, for example, virtual machines. And if I click on that, I have metric data available. If I start scrolling, as you can see here, for example, this is the CPU utilization average on EC2. So you can see that the CPU utilization is low right now, but it has gone up to 6%. If we keep going, network average, network in average, the traffic going into the instance, the average. And we have also the network packet out average, network packet in average, network out average. So you have lots of details about what's happening for this instance. So that is for the metrics. What else can I see from CloudWatch? If I go back to the dashboard, you can create alarms. So I can create alarms, and the alarm will watch for a single metric. For example, the CPU of the virtual machine. So I can monitor the CPU, the average CPU of the virtual machine, and I can instruct it if it goes above 75%, send me a notification, for example. That is possible also to do in CloudWatch. Then we have CloudWatch logs. So I can send the logs from all my applications and the errors from all the applications and the events that happen, and I can save it in a log group into CloudWatch. So CloudWatch is the core or the heart of the monitoring as far as AWS is concerned. So why is it important? Let's go back and find out. The importance of monitoring, alerting, and logging. For security perspective, you need to know if someone is attacking or probing your system. If someone is trying to break into your system or scanning your system for attacks. You need this monitoring, alerting, and logging for troubleshooting. If you want to fix things faster in a proactive manner when something goes wrong before the users start to complain. For performance, you need to monitor your performance and spot slowness before the users do, because you want to make sure that they are going to have the right response and the right performance. For compliance, the logs are very important because we need to keep records of what's happening in the infrastructure for audits and policies. So these are many, many reasons why we need to make sure that monitoring is in place, alerting is in place, and logging is also in place. Example use cases: CPU usage goes over 80%. I need to be notified. Someone tries to SSH into a virtual machine repeatedly and they don't succeed. A part of the code or the application code fails to run. I need to have that error sent into logging or maybe a notification based on that. Website response time is going down. I need to know about that as well as it happens. A web server runs out of disk space. I need to find out before that starts to impact the performance or the user experience. Example tools: Windows Task Manager, macOS Activity Monitor, AWS CloudWatch for monitoring, alerting, and logging, and AWS CloudTrail for logging. We talked a lot about databases, but we didn't dig deeper into what a database is and why do we need it. To understand the importance of databases in applications or in IT, think about a pizza shop. So imagine you are running that shop and you need to keep track of the customer orders. Who ordered what, and maybe the customer phone number or name. Ingredients used, deliveries, and payments. And if you want all of that written down in a logbook, that is going to be your database. And that may run for a small pizza shop. But for a popular pizza shop that has so many branches, a franchise, people can order online and deliveries and all that, there is no way one person or even a couple of persons or 3 people will be writing down all of that manually. It has to be in the application. It has to be in a persistent storage that will keep this data. So if we shift now into IT, the database is an organized collection of data that can be easily stored, searched, updated, and retrieved by software. So the application can write in the database, can search the data in the database, can update the data in the database, and can retrieve data from the database. And even if the application fails or whatever, the data in the database is going to persist. And we usually take copies. We call it backups. So in case if the database fails, we can retrieve or restore from the backup into a new database. One might ask, okay, but I can do this in Microsoft Excel. I can have all the data about the customers and the orders and what pizza they ordered and how many and how much they paid and all that stuff in an Excel sheet. And the answer, it's okay, fine. You can do it in an Excel sheet or in a Word file. But again, scaling, how easy it is to search. Would an application be able to read the Excel file or ask the Excel file for a specific information and get the proper response? Or does it have to search the Excel file every time it needs to get a part of the information? So we need a system that can receive a short question, look through a database engine into the data, and then respond with the answer. So the system itself, the database itself, is going to take care of that. We may think of database as like super powered spreadsheets, and they have the search capability within, so no need for us or for the application to search by itself. Why do applications need databases? I think we have mentioned that already, but let's summarize it. So applications, they need to store the user data. like usernames, messages, customer orders, and so on. So the user interfaces with the application, and the application writes into the database and gets a confirmation to that. E-commerce sites storing customer orders, customer preferences, customer refunds, and so on. Hospitals will need to store the patient records. Banks will store banking transaction or financial transactions. With databases, it's always called an input and output or write and read operations. When we write to the database, the application will write to store data. So the user, for example, goes on dolphinet.com, buys one of the bundles, and now this is going to store the order information in the database. Receive a confirmation, and then confirm to the client that everything is okay. So your order is processed, and here is your access, or this is what you will get. So this is for the write operations. But also we can do query operations or read operations. For example, I go on Amazon.com and I need to find out my orders for the past 3 months because there is one item I need to reorder it again. So now the application logic will understand what you want. As you click on orders, 3 months, show me the history. It will query the database and ask for the history of your orders in the last 3 months. Gets the answer, prepares how the answer would look like in a nice way on the page, and then you will get that in your browser. There are types of database. They are not all one type. So there are relational databases where the data is sorted out in tables, and examples databases that are relational: Postgres, MySQL, and SQL Server. NoSQL database examples: Mongo database and AWS DynamoDB. In-memory database, very fast. Redis is the best example. And time series, we have Influx, Amazon Time Stream. So we have many types of database. The most common one is the relational one, but also the NoSQL is gaining popularity. An example of a relational database, it's exactly a neat table. So for example, here we have the order ID, customer name, the pizza, which type, the quantity, and the price paid. So this is an example that would be stored in a database, and I can search it and I can find it at the end of the day. How can we read and write from a database? This is following something called SQL, Structured Query Language. So using SQL, you can write and read from database, especially the relational database. So allows applications to talk to the database, read or write using simple queries. And here are examples. So if I have a table with the name order, so a database with the name orders, and this is the information in the table, then I can do a query to find information from the database, select, and this is SQL command, select asterisk from the table orders where customer equals Bob. So what is it that I'm finding here? Can you find me in the table with the name orders? Search all the items and find me the entries or the records where the customer equals the name is Bob. So this is the customer field, and this is Bob. So basically, the output for this one is going to be this row. So this query will request the database show all orders in the table named orders where the customer is Bob. Again, for the same table, I can do other queries. Will be around how many pizzas has Bob ordered. So if I'm looking for this from Bob, or what's the total revenue today? So I want the collection of the prices paid, or show all orders with pepperoni pizza. So these are examples of if you build the code to do these functions, then you can easily go open the application, click, show me all the revenue for today. Or show me how many pepperoni pizza were ordered, or how many packs of mushroom were used today in the ingredients, or cheese, or whatever. So databases, the good thing about them is they can be integrated with applications, and they are persistent. Persistent means they are going to maintain the data. Even if issues happen in the infrastructure, the data will still be there. Even if the application fails, the data will still be there. As long as I have the right way or the right process of backing up, of taking copies or snapshots from the database on a regular basis, so such that even if the database fails, the infrastructure fails, I can take that data, populate it in a new database, and restore the functionality of the applications. So databases are extremely important, and this is an integral part of any infrastructure that you are going to work on. Be it for AI, be it for machine learning, be it for cybersecurity or anything. Always, always, always you will need a database. Let's do a hands-on demo on a database called SQLite, and this is available online for free, and that is why we're going to do it. Of course, as you learn through the cloud, there will be a lot of AWS services or Azure services or Google services that are databases, and you will get the chance to work with them in applications and in projects. Now, we're going to only show you the database part, but there's no application to communicate with the database. We're going to do the application role manually, basically, in this case. So here's the page for the SQLite online.com, and this is free. You can go ahead and use it. So what we need to do is we need to build a table like this one, a table that has ID, name, and city as the columns or the parameters. IDs are going to be 1, 2, 3. For ID 1, the name will be Alice and the city is New York. For ID 2, the name is Muhammad and the city is Cairo. For number 3, the name is George and the city is London. So how can we do this using SQL? So what we'll do is we're going to have this SQL statements or script, and let me tell you what that is all about. So delete the table if it exists and the table name is customers, and then create table customers. This is because we are testing, and there will be 3 parameters. ID is integer, so it will be a number. Name is text, and city is text. So this is only identifying what information to expect in each one of these column or data for the columns. So until now, all we did is we just created an empty table. Now we need to populate it. Insert into customers. So after creating the table, I want to insert into it the values 1, Alice, New York. So basically, I'm entering a row into this, and I'm going to repeat it to enter 2, Muhammad and Cairo, and then I'm going to do 3, George and London. So we are entering rows or records in the database. Once I have entered that and we confirm, let's query it. Let's send a query, ask the database to find me a specific piece of information using SQL and find out if it understands it and if it gets me the right information. So what we'll do is select from customers. Show me the full table because we are not specific on what exactly. I'll also do select from customers where ID equals 1. So I expect to see this row. I can also do select from customers where name equals George. So I expect to see this row. So let's go ahead to SQLite and play with this information. All right, so here is the SQLite website. Let me just make this a little bit bigger. And let's remove this completely. Here it shows you if you had any tables. Here I have only a demo table, as you can see. And we are going now to start creating our table. So let's go ahead, and I'm going to copy from the text that we have gone through. And I think it doesn't like this one, so let's do a normal code. This is the table that is going to create, and as you can see here, it doesn't exist. If I click run, we will have a customers table here, as you can see, and then the columns are ID integer, name text, and city is text. This is what we have right now. Okay, so now if I want to view items from the table, what do I do? So I can do the first query that we have looked, which will show me the entire table. And if I click run, it will show me here, as you can see. Hopefully it is a bit visible. Let's do, if I can do white background. Yeah, I think this one is clearer than the previous one. So this is going to be select from customers. And here is the table fully because I didn't specify what exactly I'm looking for. Whereas if we do this query, so select from customers where, and we put the information here, and I run it, then as you can see, I want where the ID equals 1. And the ID equals 1 is in the first row which is Alice and New York City. If I do where name equals George, and we hit run, oh, I put this wrong, George, and I hit run, you'll find that the third row for George and London is the one that appears. So this command that we are typing here, usually it's going to be encoded or programmed into your application code. Let's say if this was for a school and the user would like to know the grades or the GPA. So in the user interface, it will be like check your GPA or check your grade. Whereas when that is clicked in the code itself, there will be a select from the table for that subject. So select from the grades table where the subject is chemistry and the user is, let's say, George or maybe Sarah. So it will find that out and you will see it. So the UI or how you see it is completely different than what happens between the application and database. So hopefully this was a simple example. And if we want to delete this table right now, all I need to do is the drop table if it exists. And if I click here, and if I run it right now, look at this side, run, and the table is gone. So there is no table anymore. And this is an actual database engine available online, and we can play with it. What happens in reality is there will be application code interfacing with the database. Hopefully this clarifies how the databases work. Let's now train on how to draw architecture drawings or diagrams in a professional way. In order to do that, we are going to practice on how we can draw such good-looking architectural drawing that represents a VPC in AWS with some requirements. So what do we have here? We have AWS region US East 1, North Virginia, a VPC with CIDR block 10.0.0/16, and then in availability zone 1A, we have a public subnet and a private subnet. And these are the IP address ranges for the subnets, security groups, web server 1, and a database. And then we have public subnet 2 and private subnet 2. In availability zone 2, which is 1B, and here are the ranges for them. And we are giving also the root table information for both of them, or for all of them, with the IGW, implied router, internet, and users. And of course, the VPC stretches across the different availability zones available. So how can we draw this, and where do we get the icons from, and how does it end up being good looking or representative of your skills and understanding? This is what we are going to learn now. All right, so let's open this website, app.diagrams.net, or you can do draw.io. Both of them are going to take you to the same website. This is an online drawing tool, used to be called draw.io, draw.io, and now it is app.diagrams.net. Once you get to this website, it will ask you, where do you want to save your diagrams to? Do you want to save it to your device, to OneDrive, to Google Drive, and so on? I'm going to save it to my device, and it will ask you which folder, where exactly do you want to save it. And I'm going to create a new diagram. And you can change the storage if you wanted later on. Because I have already decided where it will be saved, it did not ask me for the folder or the directory. But in your case, it will ask you where on your laptop do you want to save it. So in that case, you save it to downloads, you create a new folder and call it drawings, architectures, solutions, use cases, whatever. So now I'm going to create a new diagram. And I will start with a blank diagram. Of course, here you can do a flow chart. You can do organizational chart. You can do a lot of types of diagrams. But in our case, I think blank would make more sense. And click on create. Now it's asking me where exactly it will be saved. I'm going to save it under downloads. And I will call it testing, for example. All right, so this is basically where we can draw. And as I mentioned, what we need to draw is this. So let's start with the AWS region, US East 1. And then we are going to create the VPC, the availability zones, and then we can come and look again for the details. So on the left pane, on this side, let me make this a little bigger so you can see it. I can type what I want. So for example, I want AWS icons. So here you have the 2025 open library and you have a 3D one. So I'm going to go with this one. And as you can see here, we have groups, we have analytics, depending on which services you want. So you can have all of that. If you are not sure where the icon you want exactly, so I'm going to mention or type region. And here you can see that there is an AWS region. Here's another one. So I'm going to select this one. When you see this cross, that means you can drag it around as you wish. So you can drag it around your canvas. And if you expand, the canvas is going to get bigger. So is it one page or more pages? Usually try to confine it to one page. Don't try to make it multiple pages. It will be easier for you to save it, to print it, and so on. And I'm going to, as you can see, when at the corner, when this shifts into an arrow, then you can shift it this way, you can shift it that way if you want, as you wish as well. So this is the region, and it was US East 1. Double click on the text, and now I can write US East 1. All right, so this is the region. What do I need now? I need the two availability zones. So I can write availability zone. And you have here availability zone, and this one is also availability zone. So what I will do is I'm going to grab this one and I'm going to put it here, and I'm going to drag it to the end. And for the availability zone, click or double click on the text, and I can write US East 1A. And the second one, I'm going to click on this and Command D to duplicate it. And I'm going to drag the other one below, and this will be, by double clicking on the text, 1B. So this is the availability zones, 1A and 1B. Now what do I need? I need the VPC. VPC. And here is the drawing for the VPC, and you have the purple one and you have this one as well. I'm going to drag this one, and I can change the color. Let me leave this one. I dragged the wrong one. So the VPC stretches across the availability zones, as you know. And I'm going to make it bigger so we can accommodate the different. Okay, so I'll make it this way, drag this one this side, and this is availability zone 1 and availability zone 2. You know what? I think it's better to do the availability zones in a different way. The reason why, I'll tell you, because I don't want the writing for the availability zone to get in the way of stretching the VPC. So what I will do is for this one, see what happened? I cannot click the other availability zone. Why? Because a layer is in front of it. The VPC is in front of it. So what I will do is I will click on the VPC. I will click on the VPC and then send it to back. That will allow me to get, so these are like layers. When you are unable to click one of them, that means the other one is in front of it in terms of layers. So what you need to do is click on the one that is holding it or not allowing you to get to it, and right click and then to back. That means send it or make it a backward layer, send it backwards. So that will allow you to view or to touch or to move the other one. So what I will do here is I'm going to move this way like the other one. And this is going to be availability zone 1B, and I can make the region a little bit bigger. No, only the region, not everything else. So I'm going to move all of this down now. And that makes the availability zones, I can see them. And I can see the VPC as well. And it also signifies that the VPC can extend across availability zones. So this is what we see right now. And it is what I wanted to see here. What we can do is I can now click on the mouse, hold the mouse button down, and I'm going to move these inside to the back a little bit and to the bottom a little bit so it doesn't conflict with this text. What you can do also is if you do Control B, this is going to be dark or bold. Also here, I want it to be bold. And here, I want this to be bold. Oh. Okay, so we have all of them. Of course, you can change the colors if you want. So this one, for example, I can make it green if I want it. I can fill it. This is the fill, and this is the line. If you don't want to fill it, then I can reverse what I did, and I can put a color for the line, a different color if you want. So I can make it green, apply, and I can also make the line a bigger size. So see, the line size is getting bigger now. For this one, I'm going to do the same thing. And I'm going to make it bigger as well. And drag this a little bit up. Of course, the color and your taste might not be like mine. I mean, I'm not thinking actually about what will look good and what will not look good in terms of colors now. But I'm thinking that you can distinguish it by looking that they have different colors, which means they are not the same, and they represent different things. So for this one, also make it a little bigger, and now it's a different color. And also for the region, I can make it anything, red, for example. And it's up to you. You can also change the text color to be different. So now we have the VPC, and we have the availability zones. Let me shrink this one a little bit to this side and expand this a little bit to this side. So what do we need now? We have the VPC, the region. I need the internet, right? So let me just type the internet. And here you have multiple selections of the internet. Select the one that you like. So this becomes the internet. And of course, I can move all of this. I can highlight all of it. Move it to the right. To the borders. And then I can write users. So whatever you want to draw, you can type it in the search, and it will give you the different icons or shapes that can represent that. So this could be the users that are going to be using the infrastructure from the internet. All right, so what do we need now? I need to have public subnets in availability zone 1A and private subnets in availability zone B. So let's go back and check. 2 public subnets and 2 private subnets. 1 public, 1 private in each availability zone. So let me do public subnet, and here it is. So again, this is blocking, so I'm going to push it back, the VPC, to be able to get the subnet. So push this one to back, push the region to back, so I can get to back. So now the VPC also. All right, so here's what I'll do. Okay, I'll move this one out, leave this one out. Now take the region, put it back, and take the VPC and put it back as well. So this one, I'm going to bring it in. This is the public subnet 1. And then I need a copy of this. Control D. So this is going to be public subnet 2. Then we need private subnet. And here is the color. So I need private subnet 1, and I'm going to copy it, Control D, into public subnet 2. Private subnet 2, I'm sorry. Okay. And then we drag this one down, and we drag this one down as well. All right, what else do we need? I think it would make more sense maybe to put the internet and the user on this side. The reason being that we are going to put the internet gateway here towards the internet, and I want the two public subnets to show as if they are closer and directly connected to the internet, whereas the private are behind and they are hidden from the internet. We need now to put the VPC CIDR as 10.0.0/16, which is fine. And then we start putting the CIDRs for the subnets as well. So I'm going to place 10.0.10.0/24, 10.0.20.0/24, and the CIDR block here. So let's do that. When you click anywhere, you can open a text and then you can write what you want. So this is 10.0.0.0/16, and this is the VPC CIDR. So let's add the word CIDR. Okay, and 10, and this one, remove it and put a bold, and I can place it in here. Then I need a copy of this, which would be the subnets. So 10.0.10.0/24 for public subnet number 1. And I'm going to move it a little bit behind the name of the subnet. And then another one that will be .20.0. So this is going to be .20.0/24. So I'm going to place this one here and a little bit up. Okay, now let's see what the private ones are going to be. So the private is 100 and 200. So I'm going to do 200, and I'm going to do 100. Okay, so 100 is private subnet 1, 200 is private subnet 2. Okay, what else do we need? I need to put an instance in the public subnet with a security group around it. This is called web server 1, this is called web server 2. That's easy. So here I'm going to go and click on instance, or write instance. Let me write EC2. So EC2 instance. Okay, this is, I wanted the instance only without instance. All right, I'm going to scroll down and look for it. It's under compute. And I want the empty one, the one that doesn't have any text inside, this one. Okay. So this is an instance and a similar one on the other side. So Control D or Command D copies or makes a copy of what you are working on or what you are highlighting basically. And a security group. So you have multiple ones. I can probably take this one, let's say. I'm going to take it out. I'm going to resize it so it fits within the subnet and around the instance. I need to make it a little bigger, so I'm going to drag this a little bit down. And let's see. Probably we need to move the instance a little bit down as well. Drag this a little bit down, a little bit more. Yeah. And then I need to write that this is web server 1. And then using the arrows, I can adjust it, and I can do Control B to make it bold. And Control D, I need the same thing on the other side, and I need the security group on the other side as well. Of course, you can change the colors to your liking and to your taste. And this shouldn't be a problem. And I can move the instance a little bit down. Of course, the security group is coming on the way. So I'm going to bring this a little bit down and then bring this back. Use the arrows to adjust it. So now I have a security group and the web server 1, and this is web server 2. Okay, so the text is going also to be over it. So I'm going to drag this one out and make it 2, and then take this one back, use the arrows to adjust it, and we are good to go so far. Okay, what do you need now? I need to have the implied router and the internet gateway. So internet gateway, and here we go. This will be at the border of the VPC. Resize it to look good, and this will be at the border of the VPC, and that is how it connects to the internet. And then I need implied router, or I will just say router, and this is the icon of the router. Again, I'll take it out, resize it so it fits in between. I need to connect the router to the internet gateway. So when you hover over the icon, you will see that there is an arrow, and if you click on the arrow, then see it connected it to the router. Same thing, if I need to connect the subnet into the router, then I can click on the arrow. No, not this one, don't drag it. I need the subnet only. And I'm going to click on the arrow and then adjust it. Okay, so now this subnet is connected to the router, and if I click on this subnet as well, I'm going to connect it to the router. So just click on here, and you can adjust it a little bit. So, and make it a little longer, drag it. So we can move this a little up with arrows. And same thing for this subnet. And use the arrows again to connect it here. And we can make this move up a little bit so it's in line with the other one, or close to being in line with the other one. All right. Okay, I think it's close. Maybe if I move it to the side a little bit, bring it here, and then use the arrows to align it with the other one. Yeah, I think it looks good now. And the last subnet also needs to connect here. So I'm going to connect it in here. Doesn't look as good because of the distance. So we can drag this a little bit to this side and it becomes better, and we can drag this one as well. So the lines are now looking much better. Okay, so I've connected all the subnets into the implied router, and the implied router is connected to the internet gateway. All right, so this looks okay to me now. What we are missing now is the route tables. That's what we are missing now. I need the destination and target and the names of the route tables. And once we are done with that, that means we have done the entire thing, and you have built an architecture drawing that looks good for a fundamentals level. This is excellent, not only good. So we need to insert a table. So I'm going to type table, and you'll see different ones here. So I'm going to click on this one. Let me drag it out. And we need only 2 columns, not 3. So what I can do is I can click on it's in the arrange, and probably this one. Yeah, okay. And also I need to delete an arrow. So I'm going to go into arrange again, and I'm going to delete a row, but I didn't want to delete this one. Let me delete the last one so it will maintain this one. Okay, and we need to type the text destination and target. Of course, all of them are going to have the 10.0.0.0/16, and this is going to point to local. And the internet ones are going to have 0.0.0.0/0, which will point to the internet gateway, IGW. Let me go back. Yeah, I got it right. So let me go back here. We don't need this row. So I'm going now to put this as, this is for public subnet. So we have public RT and public RT the same. So I'm going to double click here and then write public RT and make it bold. So this one applies to both, and what I can do now is I can highlight the entire thing and then drag it to the left, so we'll have space on the right hand side as well, and I can drag it a little bit more, so we'll have public root table as well. Okay, so I need a copy of this table. Okay, it is replicating not the entire table, it's replicating the row, and this is not what I want. So I'm going to replicate this first, public root table, and this one I need to replicate, I need the entire thing to be replicated. So let's see how we do this. Copy and paste. Okay, so here is the other one. This is and public root table. Of course, now I have started a new page and I didn't want to do that, so what I will do is I'm going to shift everything into the same page. Just drag it and then take it to the left a little bit. So now we are back to one page only, and this one, bring it closer. Now what we need is we need to do the private subnet tables. So I'm going to do a Control V again, but this is going to be without the last row because it doesn't have access to the internet. And I can change the color, of course. I can choose not the font, I want the table color. Style, so I can do the fill to be let's see, fill, let's make it blue, but with a little practice we can figure out why it's not taking the color, why it's not changing the color. But anyways, what I need now for the private, I need private root 1 and private root table 2. So I'm going to have different names for them. So private RT1 and make it bold and drag it to here, and then Control D, drag it out, and number 2, and take it to the other side. And guess what? We have now the full drawing that we wanted to do. Although it changed the direction of the internet, but that is okay, that's perfectly fine. And actually it makes no difference because here I have the two public subnets facing the router and the IGW closer to the internet. So as if we shifted that 90 degrees to the right, and that is how we have it. But the availability zones here were horizontal. If we shift it 90 degrees, they are going to be vertical and it will make the same drawing. Now I need to find out why it's not taking the fill color, and once we're done with that, then all is good. All right, so let me click on this, click on the table, and I don't want the fill to be auto. I want it to be solid, and I want it to be a different color. So let's try blue. Okay, so blue is good. And now, okay, so now, oh, okay, it does one cell at a time. I think it does one cell at a time, not all the table. So this one, I'm going to do it blue as well. Yeah, all right. So we figured out why it was not taking it. So we have to highlight one cell. That is not the case when I'm working on the app that I have on my laptop. But anyways, we figured it out. It's very easy if you play around to figure out what are the different things are. So now you have a full drawing, looks very professional, and it shows that you understand what is an availability zone, because here you are extending the VPC across availability zones. So you understand that the VPC is confined to a region. You understand that the region has multiple availability zones, and availability zone is also confined to a region, but the VPC can stretch and have workloads across availability zones. So this is clear. When I look at it, I understand that you understand what you are drawing, and it looks professional. You are using different color to signify that you have different items. Root tables, different root tables, different colors. Same root table, same color. So this shows that you know what you are doing. It shows the IP addresses. It shows the name of the web servers if you have one assigned. We have a wrong line here that we can delete. I'm only missing one thing, which is the database and the security group in the private subnets. Once I have this, I think we would have completed everything, and this will be your first architecture drawing. Of course, you can start with simpler ones if you want, but now I showed you how to build a complex one. If you get to that skill level, excellent, perfect. If you don't, you need to look up to getting to that level, but you can start with one availability zone, one subnet, implied router, IGW, one VPC, small VPC, and all that. You can start with that, and then you grow your skills as you go. But let's put the database and the security group, and we are good to go. So here I'm going to type RDS. That's the name of the database in AWS. And I'm going to take this icon. Let's take it out. I can change the color. I can make it blue. Yeah. And I can make it smaller so it can fit under the security group. So we need one here, and we need one here. And then I'm going to go back and security group. And let's grab this one so it's different than the other one. And let's change its color to blue, for example, also. I like blue. Resize it to fit in. I think this should be enough. See, yeah. And you can always use the arrows for sensitive distances. Control D, so I can have another copy, move it to the other side, and use the arrows again to adjust it within the subnet. And we are good to go. Believe it or not, congratulations on building your first architecture drawing. And nothing stops you from expanding into other pages if it is going to be big, but it will be very hard to accommodate it and make sure that it's visible within documents. Now you are done and you want to export it or you want to save it. So I can export it as PNG, JPEG, SVG if you want, PDF. You can do all of this. If you do PNG, you can click here to make it transparent background. So you can take the drawing, put it on a PowerPoint presentation if you are going to present and you include it in your PowerPoint, or take it without a background and put it as well in your documents. So it will not have a grid or anything that will show in the document. It will only show the diagram on the background, which is the document itself. That's it. And if you do export, it will ask you, okay, what's the name? Where do you want to have it? And that's it. So that's all what you need to do in order to build a professional drawing. This is not only limited to AWS, by the way. Let me cancel. Now, if you want Azure icons, you can have Azure icons. If you want GCP icons, you can have GCP icons. So GCP icons, you can have Google Cloud icons. If you want Cisco icons, if you want to build something for networking, you will find everything. Cisco, and you'll have Cisco icons. Juniper. They don't have Juniper. So there are icon libraries that you can download and use it as well. And of course, they have the general ones as well. They have the drawings, the rectangles, the circles, the triangles, and so on. These are general purpose ones that you can use if you want, arrows and so on. And the more you draw, the more you get familiar with it. So Kubernetes, I think it will have also. Kubernetes, it does have Kubernetes icons. Docker has some of them. Terraform, let's see. Not many. Or maybe HashiCorp. HashiCorp. No, it doesn't. But you can look for libraries and you download them and use them if you want. In Module 10, we are going to look at many IT tools or technologies that we use, and they are extremely important when it comes to modern IT. The IT of the cloud, the IT of DevOps, the IT of AI and machine learning, and so on. This is not going to turn you into a master of these technologies and tools, but it will tell you why you need to learn them and what you can do with them at a very high level, very basic, very simple, without any complications. When you decide on your next career steps, you will know upfront what technologies and tools you would like to master in order to be well prepared and well-rounded for the role that you are going to choose. All right, so let's go ahead and start our section. So let's start with a Linux overview. First of all, Linux is, I would say, 95% running all the servers on the internet today. I'm talking about the server side. I'm not talking about the users that are using Windows. I'm talking about servers that are running AI, that are running the cloud, that are running DevOps, that are running a lot of things in the cloud in modern IT, and these are based on Linux. That is why I am personally an advocate of learning Linux as opposed to Microsoft Windows Server. You will be well equipped with Linux with the right skills to start learning Docker, to start learning Kubernetes, Terraform, Git and GitHub, and a lot more technologies that are all based on Linux primarily. I know some of what I mentioned may run on Windows, but that is not what is used in production. That is not the core in production. And as I mentioned, we are talking about 95% of the internet runs on Linux. Again, this is only a high-level overview to show you how you would deal with it and how it works. Is it command line interface or is it graphical user interface? And what would you do for simple tasks in Linux? So why learn Linux? Linux runs most of the cloud and internet systems, servers, and cybersecurity tools today. DevOps and cloud careers heavily demand Linux skills. So you need to know Linux well. And also, in order to build the skills in other technologies like Docker and containers and Kubernetes and all that stuff and Ansible and so on, you need to know Linux to a decent level where you can learn these technologies and work with them, because at the end, they all work on CLI and they are all dependent on Linux commands and Linux operating system. Learning Linux paves the way to learn the other stuff. We talked about that. It is free, so you can start learning Linux without having to invest in a license or buy subscription or anything like we do with the Windows. You don't have to do that with Linux. Linux administrator is a good quick entry point in IT, as I mentioned. So if anyone would like to get quickly a job in IT, it won't be the highest pay that you should be aiming for, but at least you can enter and have a funding source to fund the rest of your education. And at the same time, learn IT and grow within. The minimum Linux knowledge that you need will be creating, deleting, and navigating folders and working with files and permissions. Basically, to be capable of dealing with the file system, the files, the folders, the permissions, the users, the groups, assigning and creating users, assigning permissions, and all that stuff. So this is all important. Using the terminal shell and the common commands and install and tune packages. This will be the minimum that you need to know. And this is enough to get started. You can add more skills as you go, or whenever you need to learn something new for a new technology, then you can go add that to your tool set in Linux and then continue. If you are planning or if you want to get into IT as a junior Linux administrator, then the #1 enterprise preferred Linux certificate is the Red Hat Certified Systems Administrator. So this is a certificate you may spend after this course, maybe another 1.5 to 3 months, depending on the time that you are going to allocate. And you can prepare for the exam. The exam a little bit on the hefty side. It costs about $350, $400, $450, depending on where you are. But that would give you the seal that you are certified in Linux and you can start your job as a junior Linux administrator or junior technical support engineer. Don't make that your goal, but that could be a tactical or a milestone towards your goal. So if you want, you can do this. And of course, there is one equivalent one also, the LPIC certificate. But I think the Red Hat is more widely known at the enterprise level. The other one is picking up towards the cloud. Either one will give you enough knowledge about Linux that you can learn any distribution. You can learn Ubuntu, you can learn Red Hat in this certificate, you can learn Kali Linux or anything else depending on what you will specialize in after this course. When you work with Linux, you are working with a command line interface. So it's not a graphical user interface where you click on things and right click and open and delete and all that stuff as we do in Windows and Mac OS. It is more on the command line. So some common commands that you will definitely use. Who am I? If you would like to check which user you are logged in to the Linux system. PWD. If you would like to know where exactly in the file system you are. Are you at the root? Are you in the Linux practice subdirectory? Are you in the application one folder? Where are you exactly in the system? LS to list files and folders, and CD to change directory. CD can help you change directory so you move deeper into the file system or you move up into the file system. You can create directories with make directory, and you can do cat in order to print file content. Basically read for me the file and print it on the screen. And use the touch command in order to create files. You can nano to edit files, and you can echo if you would like to redirect a specific sentence into a file. So you want to create a file, and then you can start adding information into that file or appending information to what is in the file using the echo command and redirection. We are going to go ahead and do a demo, and that would be the most helpful way to get an idea on how Linux works and what to expect when you are dealing with the CLI. Let's go ahead and demo Linux and use some commands in a very simple scenario that will give you a feel of how Linux is and how you work with it, and some basic commands, as I mentioned, that are very common and you will use them frequently when you are learning cloud or you're learning any of the modern IT skills. So what's the objective? We want to learn how to navigate, create, and manage files and folders in a Linux system. And the scenario, imagine that you have been hired or you are in an internship as a junior support technician or systems administrator. And the team lead that you are assigned to will ask you to explore the Linux server and do some basic file and folder operations to get used to the environment. In order to achieve that, the simplest thing, I'm not going to ask you to create a VM on your laptop or anything. We are going to create an EC2 instance in a public subnet in AWS with a public IP address. It will be associated with a security group that will allow SSH inbound from anywhere. Very easy. Let's go ahead and create this before we start the commands. So here we go. I am right now in my account. I'm going to go ahead, launch an instance, and let's call it Linux Training. And it's going to be an AWS Linux, Amazon Linux 2023 or AL 2023, T2 Micro. We don't need a powerful instance for this. I'm going to use an existing key pair. If you don't have an existing one, please create one and download it and know where it was downloaded. And network settings, we're going to do with a custom VPC. I want to make sure that it's going to get a public IP address, and I want to make sure that it is in a public subnet. And I'm going to use an existing security group, and I have one, SGA. This allows all traffic in, all traffic out. Okay, so a quick review, just to make sure that everything is right. Public subnet, it will get a public IP address in the custom VPC. It has a key, and it's T2 Micro and Amazon Linux. And I'm going to go ahead and create it. After we will create it, we'll connect to it because we need to start working with Linux. So I'm going to click on the ID to get into the instance, click on connect, and in this case, I'm going to use the EC2 instance connect. Click on connect. And as you can see, we have a public IP address and a private IP address. Connected to the instance. And I'm going to elevate my permissions with a super user. So as you can see on the left-hand side, that this is EC2 user. But if I want to know for sure, I can ask, who am I? And that will tell me that you are EC2 user. When I do the sudo su, this is going to change. So let's find out, who am I? Now it will tell me that you are the root. Root means the most powerful, the super user in the system, and you have, or you can do all permissions and all that stuff. Of course, in Linux, usually when someone tries to change into a super user, there must be some authorization done, because not everyone should be allowed to do that. But the default in AWS is there is no password, there is no permissions to claim the root privileges or permissions. All right, so find out your username. We did the who am I. Where in the file system are you right now? So in order to do that, we need the pwd or print working directory. So I'm going to do pwd, let me know where I am. And this tells you that you are under home and under the directory home folder of EC2 user, or the home folder directory of the EC2 user. List the files and folders in the current directory, and that is using the command ls. So I'm going to do ls, and I don't have anything right now. Create a new folder for your work, and this is going to be the Linux-practice folder. And the command to do that is make directory. So let's do that, make directory, and then Linux practice, that's the folder. When we do ls again, you'll find that we have now a folder called Linux practice. Move into the new folder. So from home / EC2-user path, or the place in the directory, you need to move into, you move deeper into the file system. So basically, we have home, and under home, we had a folder called user. Now, under user, we created a folder called Linux practice. And when I started right here. Now I need to move one step in the system and get into this directory. How can I do this? Using the change directory command, Linux practice. And after we do this, we need to find out where in the file system we are. So we're going to use pwd to confirm that we have moved in the system. So I'm going to do cd and then Linux practice, ls. I don't have anything. And if I do pwd, it will tell me that, see, before I was here, and now I have moved one step into the system, deeper into the system, into a folder called Linux practice. Create a file. How can I do that? Touch hello.txt. So when you do ls, we don't have anything. Let me clear this. And now I need to create a file called hello.txt. If I do ls again, we have a file now, the hello.txt. And if we do cat hello.txt, this will show me if the file has any content. It will print it here. But as you can see, the file is empty. I don't have anything here. List the folder content. We saw that. All right, what's next? Write something into the file, and we can use echo hello world. So this is going to print as an output hello world, but this means amend it or append the hello.txt file. So add it to whatever is in the hello.txt file. So echo and double quotes hello world, and then hello.txt file. Now, if we cat the content of the file again, you'll find that after it used to be empty before, when we did here, we didn't get anything, and now we're getting the text in the file. We did the cat, edit the file. So we can use the nano editor in order to edit the file. Let's try that one. So nano hello.txt. And here I am inside the file. And as you can see, the sentence that we have added, and I can say here, how are you doing today? And then do Control X, yes, to save the changes, and enter to exit. Now, if we repeat the cat, you'll find that we have the 2 sentences in the file. Okay, create a subfolder inside the folder. Subfolder called notes inside the folder. So we're going to make dir notes. If I do ls, now I have 2 things. I have a folder, different color, and I have the file hello.txt. Where in the file system are you? We're going to move the file hello.txt into the notes folder. All right, so do pwd. I'm still where I am in the Linux practice. We're going now to move the file hello.txt. I would like to move it from the location where I am right now into the notes folder. So I'm going to move it into notes. ls, I don't have the file anymore. If I go into notes and do ls, I'll find that the file is here now. Now, once we are done, we can delete the hello text file. We don't need it anymore. That was just the practice that we wanted to do. So I'm going to remove the file hello.txt. Remove regular file. Yes. ls, remove hello.txt. Now the file is removed. Now let's get out of the notes directory because I need to delete it. So you can move 1 level up in the file system by doing cd space ... And as you can see, we moved from notes into Linux practice. So I moved 1 level up in the system. And if I do ls here, I will find that we have notes. So we can do remove directory, delete the directory, notes. And if I do ls, I don't have it anymore. So I'm going to move 1 level up again. And now I'm back into the home directory of the EC2 user. And we can do remove directory Linux practice ls, and we don't have it anymore. All right, so delete the hello, delete the directory, and delete the Linux practice. And as a good practice, always, if you don't need the instance anymore, terminate it or at least stop it so you don't face any surprising charges. So I'm going to go back. I don't need this anymore. And I'm going to get here and instance state terminate. And we are good to go. Now let's do bash scripting or bash overview. What is bash? Why do we need it? Why it is always a requirement or a skill required when you apply to cloud engineering, to DevOps, to programming, to Linux administration, to ML ops, to SRE, to platform engineering, anything you will need to work with bash scripting at least as a scripting language. So what is bash? Bash stands for Born Again Shell. That's the abbreviation for bash. It's a command line interface and a scripting language for Linux. So it's only for Linux. It lets you talk to the computer, automate tasks, and chain commands together to get powerful things done. So instead of you going into the command line, typing one command at a time, you can have them in a script and you can apply that script. For example, when the virtual machine is booting up, you can install things and you can configure things. When you want to automate the backups, for example, you want to take a copy of your database every night at 1 a.m., for example. So instead of you waking up and doing that manually, why don't you put in a script and schedule it so it runs every day at 1 a.m. and you will be sleeping, and you can also ask for an alert or a notification that was done successfully. All of that is done using bash script. So it's one of the core skills when you are working with Linux systems for automating tasks on these Linux systems. Why learn bash? It's the default shell in Linux and automate boring tasks used in DevOps, cloud, and cybersecurity heavily, and it's fast and lightweight. Now let's look at common use cases for bash so you can get your head around why do you need to learn it. So we'll look at the tasks and what would bash do for me in that case. So you want to automate routine stuff. Starting virtual machines at 7 a.m. in the morning, switching them off at 6 p.m. in the evening, doing backups for the virtual machines or for the database, a lot of things that can be done. So routine tasks like backups, deleting temporary files every day, so that can be done without you having to worry about it. Schedule it and forget about it. Cloud setup. So launch and configure EC2 instances. Not only launch, and configure. So you can download things, install packages, and so on. Security and monitoring. It can help you scan logs for failed logins, and that will be helpful for the security specialist or the consultant to find out if you are or were under attack. Installing packages and software, multiple packages in one script, as opposed to you going and typing a command and then waiting until it finishes and then typing the next one, and until it finishes, you can just pass them as a series of commands and it will do them one by one as the virtual machine boots. Report generation. You can use it to pull, for example, disk usage and send an email or email these reports. Which modern IT roles will require you to have Bash because you will use it in that role? So if we start from IT support, network engineers, technical support, sysadmins, all of them will need Bash because they need to fix files, manage files, generate reports, troubleshoot via CLI, create and manage users. For DevOps engineers, it will be very helpful to automate the CI/CD tasks and also server management and creating cloud scripts to bootstrap the virtual machines with the right packages or the right software that you need. For cloud engineers, for user data scripts, basically passing that, as we will see in the demo, passing a script to the virtual machine when it runs, so it will download and install packages and maybe services that you need, and it will start them as well as the instance boots, so you don't have to wait until it boots and then you go in SSH and then you start typing one by one of the commands. So user data scripts, provisioning EC2 and startup tasks. For cybersecurity analysts, it will help with the log analysis. It will help with automating tools that are used and also for network scans. And for sysadmins, automate system health checks, backups, and updates. So these are just examples. Of course, when we talk about DevOps engineers, that means SRE engineers and platform engineers also, they need it. Cloud engineering also definitely will need it. Network engineer, developers, they will need to have an adequate level of Bash because many of these tasks, you will find that other roles as well need them. A lot of the jobs that I see in the US, and that is the reference for me that I use to find out where things are going, they will ask to know Bash or PowerShell or Python. Rarely I would see that this and this and this, but they want one of the three. So let's compare them and find out what's the positioning of Bash, why is it more popular, what's the positioning of PowerShell, and if I learn Bash, why do I have to learn Python? So this is very important, and I get this question day in, day out from people who don't want to learn Python, and they keep pushing back and say, I know Bash, I can live with Bash, I don't need Python for anything. Actually, you do. From an operating system focus perspective, Bash is for Linux, PowerShell is for Windows, and now it is cross-platform. Python, of course, that's a coding language. It can work on Windows machines or in Linux machines, as long as it has the right runtime. For the syntax, this is very simple, Linux commands basically. For PowerShell, it's verbose a lot. I mean, the commands are much more difficult, I would say, than Bash, but they are powerful. If you learn them, you learn them. For Python, it's a programming language, so the code is clean and very easily readable. Bash is best for native Linux tasks and automation on Linux systems. And of course, PowerShell is for Windows and Active Directory. Whereas Python, it's full-featured applications, anything you want. So you want to automate integration for an application. For example, when someone uploads an image on a website, then Python will sense that and then will do some tasks based on that that cannot be done with Bash. So you have to have coding in that case. Learning curve, easy for beginners. Usually you learn Bash after you learn Linux. And PowerShell is slightly steeper than learning Bash. And for Python, it's a programming language. How is it used in AWS? Bash is excellent for EC2 user data scripts. PowerShell is less common in AWS. and Python, of course, when it comes to writing programs that will interact with AWS services and automate things based on events that happen in these services. Learn Bash first for system level tasks, and then learn Python later for more complex automation or data manipulation. So Linux, so you do the fundamentals, you learn Linux to an adequate level and be confident with Linux, then learn Bash, then learn Python. That would be your automation / operating system path in order to get a job in, let's say, 4 months. And if you finish the RHCSA as well, you will find entry-level jobs with these skills, and then you can take it from there up. Python automation is very hot everywhere. Don't stop at Bash and say, I'm good, I don't want programming languages. Take your time, learn it, and if others have done it, you definitely can do it. All right? Hopefully this is clear. Let's look at a demo where we are going to bootstrap. Bootstrap means you will initialize the instance, you will create the instance, but then you will stuff it with some script to initialize it in a proper way. This is called bootstrapping the instance. So we are going to use a Bash user data script to bootstrap an Amazon EC2 Linux instance. Let's find out what we are going to do. We need to set up an EC2 instance in a public subnet and make sure its security group allows port 80 inbound, at least. And we're going to pass the following script to install Apache as it boots up. I'm going to add from my side as well. Let's do SSH as well. So allow SSH and 80 inbound, just in case. If it's not working, we need to get into the instance and find out what happened exactly. So we're going to pass the following script to install Apache as it boots up. What is the script? This is at the top to define that we are going to use, or we are going to use the Bash shell or the Bash script. Then we are going to update the indices and all that on the operating system. We're going to use DNF install -y HTTPD. We're going to install Apache, which is a web server engine. We're going to do systemctl start HTTPD. So after installing Apache, we need to start it. And then enable HTTPD such that every time you are going to reboot this machine or stop it and restart it, Apache is going to be restarted as well with the instance. So all of that is going to install Apache, and that's it. But then let's also have a simple web page that would say, welcome to my EC2 instance. So this is HTML. This is the echo command. We have seen it before. And here are the double quotes to delimit the text in question. And we are going to output that into a file index.html at this path, var www HTML. This path within Apache is where the root document or the index.html or the root of the website exists. So if you want to have a web page and you have designed the HTML for that page, you need to place it in this folder in order for users, when they come in to your website on port 80, they will be able to see that page. So if you want it to be seen, this is where you place it. And this is what we are going to do in our case. Let's go ahead and create the instance, and then we'll deal with the script. So here I am in EC2. I'm going to do this in a slightly different manner. First of all, I'm going to do every command manually. And I will show you the result, and then we will do it with user data so you will see the difference yourself. So launch instance, and we are going to do it without bootstrapping first. So web testing, for example. Amazon Linux, and it needs to be with a key. So I'm going to use again a key that I have for SSH. Network settings. I'm going to use the custom VPC, and I'm going to use the public subnet, and I'm going to make sure that it has an IP address. For the security group, I have one that is widely open. It allows all traffic in, all traffic out. In your case, at a minimum, you want to have on the inbound SSH from anywhere and HTTP inbound from anywhere. I'm not going to do anything extra than this, and I'm going to start. If I wanted to have the user data or the script passed to the instance, you click on advanced details and you scroll all the way down, and this is where you paste it. It's called user data, and that's the script or you can have it in a file and upload it here. So I'm going to create this instance without any user data or anything. And I will show you that we can achieve what I'm being told. So why do I have to use a script? So let's find the difference, and that will tell you the importance of bash scripting. So what we'll do now, let's go back to the instances. And I'm going to select this one. Okay, it's running now, connect. And I'm going to use EC2 Instance Connect and click on Connect. If at this stage you are unable to open this black screen and find out the prompt, that means you have a problem with your security group inbound rules. Go fix it. And you will get an error that maybe SSH is not available or something. So this is based on SSH inbound in the security group. If this is not working, you have a problem in your security group. All right, let's go ahead and do sudo su. And what do we need to do? I need to do DNF update -y. So this will update the system. It may take a little bit of time because the instance is still booting up. All right, so it's working now. And then DNF install -y httpd. This is the Apache service. So as you can see, a lot of things are happening now, installing many things. Then we do systemctl start httpd. So start the service. Now, if I can do systemctl status httpd, show me the status. You'll find that we have this service right here, and it shows me that it is running. And the last command, systemctl enable httpd. So each time when the instance is booted, the httpd will be started, Apache will be started. Okay, fine. What did we achieve? I typed the 5 or 6 or 8 commands, and now I should have Apache up and running. How do I find out? Apache listens or works on port 80 by default. So I'm going to take the public IP address. I'm going to open here a browser, and you can write 80 or just leave it to the default. By default, it's port 80. And you can find out here that it's telling me it works. I didn't put any script or file, so this is by default from Apache. If I want to add a script that I need, then I can do echo and then hello from Apache. And then I have to redirect it into var www html index.html. You can cat to check. So I can cat and then have all of this copied, paste, and it shows me hello from Apache. So now if I go back, if I reboot, it will tell me hello from Apache. Maybe you can see it, it's small, but hello from Apache. So now it works was coming from a default page in Apache in the same folder, and now I have replaced that with hello from Apache. All right, so this shows you that we could do it without any bash scripting. Why on earth do I need to learn bash scripting? Let's find out. So let me go back into instances, and I'm going to launch another instance, but this time I'm going to do it with the bash script. So let's do web testing 2. It's going to be Linux and same size. Key pair, I'm going to use the same key pair. If you are using EC2 Instance Connect, you don't even need a key pair, but that's fine. Same VPC. So I'm going to do same everything, but I will pass the script to it. Enable security group. Security group, I'm going to use the same. And advanced settings, click on the triangle, scroll all the way down. And then we're going to copy the script that we have in the file. And I'm going to paste it here. One very common problem here is sometimes when you copy from PDF files or Word files and you paste here, the line delimiters, they get scrambled, they get mixed, they get confused. So what I usually do is either I will copy it and put it in a notepad, for example, like basic text editor, and adjust it, or I will do what I'm doing right now. So I'm going to go into every line at the beginning, then backspace, and then hit enter. So that confirms that I have a line break after every command, and each one of them is going to be considered a separate line, and they are not mixed up. Also, the comments that we have here, they are of no use. If you want to remove them, that's perfectly fine. It's just for you in the documents to find out what this was for and to find out that it is a separate line, each one of them. Okay, so this is the most common problem that I see with my students when they are working on bash scripts with user data, especially if they're copying from PDF files. So launch instance, let me just double check. We have everything set right. It's always good to double check as opposed to waiting and testing and troubleshooting and then you figure out you forgot something. Custom VPC, public subnet, public IP, and security group allows everything, and we have the bash script as well. So now I can go grab a cup of coffee. I don't need to wait for the instance or connect to the instance or type any commands. If these commands with the line delimiters, they are done right into the script, the virtual machine will boot up and will start execute these commands line by line. And the start of it states that it is a bash script. So that should all be working without us intervening. Okay, let me close this completely, and I don't need the previous one anymore. So now we have a new instance, which is web testing 2. This is the one initializing. So this one, I don't need it anymore. I can go ahead and terminate it to not forget it later on and be confused about which one I'm using. So this one, I don't need it. And this is the one that is initializing right now. Let's refresh. If the bash script will download a lot of packages and it has a lot of steps, then you need to be a little patient, because if it takes time when you type the commands, it will take time when they are automated and running on their own. So let's try. Here is the public IP address. I'm going to copy it and I'm going to check and see if this works. So paste it and hit enter. And as you can see, welcome to my EC2 instance. So it didn't say it works or it worked. It has taken the statement in the echo, and that was done with HTML delimiters to enlarge the size a little bit. So that's why you can see welcome to my instance, which is exactly the statement that we had here in the file. So you can see with scripts, that is one task. I mean, that is one example, not everything that you will do. If you are not working with virtual machines, maybe you need to take the backup of the disk of the virtual machine and do a copy or a backup every night. So scheduling and scripting will help you do that. Maybe there are some states, read the logs, and if this happens, do this. So there is complex logic that can be built with bash scripts, but this tells you the value of automation, although it is a basic example, not a complicated example. So it shows the power of scripting in cloud automation, and 0 clicks whatsoever. I did not even SSH into the instance. I just checked from the website and everything was working. And that is the power of scripting and automation, which is why everything is going towards automation. AI is also doing faster automation and so on. All right, hopefully this was clear. Don't forget to terminate your instance if you don't need it anymore. DevOps engineering, site reliability engineering, platform engineering, and DevSecOps. 4 very crucial areas in IT as it relates to IT in general and software development in particular. It doesn't mean that you're going to be a developer to work in one of those areas. This module will help you understand what these areas are, their importance, and how they relate to one another. So let's go ahead and get started. So let's start by exploring what SDLC is, Software Development Lifecycle. When a team or a company would like to build an application or build a tool, what is the process? What's the workflow that from the time the need or the requirements and the planning were done all the way until the code is done, tested, and deployed? This is called SDLC, Software Development Lifecycle. So let's go ahead and explore that because it relates to everything we're going to talk about. Any application or software goes through several steps from the idea all the way to deployment. We have, let's say, the startup, the company, or a business unit, they have requirements. So these requirements are going to feed into a team, and that team will start doing the planning. And in the planning, they will say, okay, this is what we need to build. This is how much it will cost. This is how much it will take. These are the required resources and so on. So development team and project managers and all that are assigned. They start working on code and they start collaborating in a repo, in a repository. Then we have the build and QA and testing teams that are going to be testing the code as it is developed or after it is developed. And depending on the manifests of tests that needs to be done, they will find out if there are any issues. If there are issues, they will send feedback to the developers and then iterate through this until the software and the code is ready. So this is true for any software development. So let's go ahead and find out what are these steps. So the software development workflow will go through the following steps. Planning. Then we're going to go through identifying the teams, the development teams, assigning the jobs to them, and then they will start coding. After coding, or maybe during, depending on which methodology they are going to use, there will be building of the code from the different developers, then performing testing in order to find out errors or bugs or malfunctions in the code, and they will provide feedback to the developers depending on what happens, the results of these tests. And after that, if these all errors or all problems are solved, then we get into the releasing and deployment. Releasing means the software is ready or the application is ready or the new version is ready, and then deployment means it gets implemented in production. Then comes the operation and monitoring phase, and then this cycle repeats as we enhance and add more features and so on. So this is called the SDLC, the Software Development Lifecycle. Of course, it is critical if we need good quality software with less problems, less errors. The more we can automate in the steps, the better it's going to be. The less errors we are going to have, the faster it's going to be released. So SDLC is a structured process used by software development teams to do what? To design, develop, code, test, deploy, and maintain software. And this will provide us a step-by-step workflow or guide in order to be able to manage the entire life cycle from the planning all the way to monitoring and iterating through this process again. Benefits of following a workflow or a process step by step, or SDLC, it will ensure that there is a systematic approach to the software creation across teams, and it will provide a way to measure and improve the development process. We can look at every stage or every step in the workflow and find out if this is working as expected or not. And it allows for an accurate analysis of the different steps, which one is working fine, which one needs enhancement or improvement. And depending on the methodology we use, we can test more frequently and build and test more frequently to find errors or bugs early in the process. And of course, the SDLC also will facilitate, if we do the automation, it will facilitate faster software delivery and higher software quality, of course, which is going to yield better user experience. Of course, that is the goal. But let's find out how was software development done the old way. So the old way, we had the developers who are going to code and build. Then they're going to ship the code over the fence, do a handover or handoff to the QA and testing teams. They will do their testing and then they will send it to the release team or the release manager team and say, okay, we have done all the tests, we did feedback, everything works fine. Now it's time for you to decide with the operations team when to release. And we work with the operations team. Once it's done, then it is handed off to the operations team. So as you can see, this is more like silos. They are working separate from one another. When each one finishes their work, they will pass it on to the next one, and so on. So there is no collaboration. There is no integration among the teams. So they were discrete teams, complex integrations, of course, because if we are going to finish all the code 6 months, 12 months, and then start testing, we are going to have a long list of issues. Lots of bugs, of course, and definitely a slow release process because we wait until all the development finishes before we start testing. We wait for all the testing to finish before it is ready for release, and we wait for the scheduling in order for that to be deployed. So that's very slow release, and features are not going to be updated frequently. In the new way, and in order to reach our goal, the goal of automation, less human intervention, less errors, higher quality, faster releases, we need collaboration among the teams, and we can't have the discrete teams that we have looked at. So here we need to have an iterative process. Maybe every couple of days we release, or maybe multiple times a day, which means we have to build and test more frequently, and we have to get software ready more frequently. We have to deploy more frequently, and that's how we need to enhance the user experience by adding features in a stable software, highly performing all the time. So we expect teams to collaborate together and not to work in silos. There is going to be continuous and less complex integrations, and errors consequently are going to be detected earlier, and this will yield a fast release process, which is what we are looking for. So collaboration between the teams or marrying the teams together is an ultimate goal, as opposed to allowing them to work in discrete teams in silos. Now, let's look at the different models, and we're going to bring it from the history all the way to where we are right now. There are different models or workflows that we can adopt, or processes, if you will, in order to do the SDLC workflow. One of them, which is legacy, is waterfall. That's traditional. So in waterfall, we expect that the development team is going to sit and work for 6 months or 12 months on the software, and then when ready, it will be shifted to testing, and when ready, it will be shifted to operations, or release and then operations. So this is the old way, sequential methodology. So we look at the requirements, we look at the design or design phase, coding or development, building and testing, deployment and operation and maintenance and monitoring, and only when this is done, then we can take new requirements and we can work on a different project. But of course, this is only or can fit with projects that have well-defined requirements. Today, every day we need a new feature. We get customer feedback and then we need to build a new feature. The fact that we can have all the requirements upfront with no changes for 6 or 12 months is very rare to happen nowadays. Releases here are very slow, every 6 or 12 months to have a release. And the testing is done manually. So this is completely, as you can see, waterfall is completely off the goal that we had. Manual testing, and it only happens after development is complete. And operation teams will deploy the code, and of course, this is silos. We are talking here about operations team at their ease. Whenever they have time, they're going to look at the code and look into deploying that. Then evolved Agile. And Agile is more of a set of principles or a methodology. It's not only about project management that is used in software development. Agile is an iterative and flexible software development methodology. Usually in Agile, we agree on a milestone. It could be a feature, it could be a release, and it is divided into sprints. Let's say the sprint will be 2 to 4 weeks. We are going to work on code, and every 2 to 4 weeks, we are going to test and release. So the goal is to deliver working software more frequently. The waterfall had 2 issues. The first one is it does not accommodate new requirements during the workflow. Second thing, it takes very long for that to complete before testing happens. And of course, a long list of errors and bugs and all that will be discovered, and integration issues that needs to be fixed, and it takes a long time to be fixed. So Agile said, okay, fine, we're going to fix that. We're going to iterate through the process. So we are not going to have one long process for development, workflow. Development is too long, and then testing is too long, and release and deployment is too long. We are going to do that frequently, and we can gather new requirements, and we can add it into the new sprints, the new milestones, and we can work on it, test and everything, and release every 2 to 4 weeks. So as you can see here, we have planning, we have a plan phase, we have design, coding, building and testing, deploy and review, and then it repeats. So we can launch or deploy, And then we have again planning, gathering new requirements, designing, and so on. So it is a process that repeats at high frequency or close intervals, so we can release at close intervals as well. And testing is continuous, but it's semi-manual. So it is very close to what we wanted, but the testing is semi-manual, and also 2 to 4 weeks is a bit long. So we are still aiming for a better solution. And the release manager coordinates development team and operations team to work on the deployment. But of course, it all depends on how available are the operations team, because Agile focuses more on the development phase and not on the operations phase. So the limitations in Agile, before DevOps, of course, it was widely adopted to make software development faster and more responsive, as we explained. However, Agile ended at the code handoff to operations. So once the code is ready, tested, and then release manager coordinates the deployment, that's it. So is the operations team Agile? And the answer was no. It did not transform operations. It did not include operations in the Agile process. And that is a problem, because now we have a team that is collaborating, the testing and QA and all that, and developers, but then the operation is a different silo. An operations team, because they're not Agile, they still used slow manual processes. And this caused friction, of course, between the development teams and the operations teams. And that is what necessitated finding out a new solution to this, which is DevOps. So let's talk about DevOps. DevOps increased the automation and also married development, QA testing, and operations. Brought all of these and blended them in one bowl. And this is the team responsible for the software delivery. So the problem before DevOps, that Agile created a fast dev, slow ops bottleneck. So we needed to fix that. The code was ready every 2 weeks, but ops teams deployed monthly or quarterly. And developers and ops worked in silos. These were the issues that we discussed. So what is DevOps? DevOps is a set of practices, tools, and a culture mindset that combines software development, and IT operation. It brings both of them as a collaborative, bigger team. It's a full software lifecycle investment, and it's a team undertaking. It's not one person that will decide, I'm going to do DevOps. It has to be adopted and managed by the team. And DevOps enables better software development and delivery practices, because it's going to fix or solve the bottleneck caused by the operations in Agile. And it accelerates the last mile of continuous delivery. So that means DevOps did not cancel Agile. However, it extended Agile beyond dev into the deployment, infrastructure, operation, monitoring, and maintenance. And it brought automation, collaboration, and shared responsibility across the entire software lifecycle, or SDLC, not only until the coding and testing is done, as Agile did. Goals and benefits of DevOps: faster software delivery, and improved collaboration between teams, more reliable releases, so more automation, and automated testing, deployment, and monitoring. That's the way we can have better quality, better scalability and performance, and it will promote the collaboration among the different teams involved in the software delivery process. So let's look at the areas or practices that are now considered under DevOps. First one is continuous integration. Every time the developers are going to make changes to the code, they will commit that code in a repository, GitHub, for example, and that is going to automatically trigger the build and test. So every time there are changes, build and test is going to be run automatically. And then we get into the continuous delivery, which is once build and test are done and feedback is done, iterations have been taken care of and no errors now, then software will be ready for release into production. Also, infrastructure as code, which is scripting the configurations or the infrastructures that you build, the resources that you need in Terraform, for example, scripts, or Python scripts, or maybe CloudFormation scripts, and so on. Then we have automated testing to have less errors and faster testing processes. And then configuration management, which is all about centralizing and standardizing how the software and the applications are being configured and set up after they are deployed. Now let's look at the first two practices that we have looked at, the continuous integration and the continuous delivery, and we'll add to that also the continuous deployment. Taking a step back, CI/CD is all about continuous integration, continuous delivery, and continuous deployment. And these are software development practices in DevOps that are aimed at automating software development end-to-end, including the marriage between the development and operations. This will yield better software, higher quality, faster releases, and better user experience as well. Let's look at CI. So CI, or continuous integration, refers to the DevOps practice that is going to trigger automatically a workflow each time developers are going to commit code changes. So developers, every time they commit code changes, so they make changes and they upload them or push them into GitHub, that is going to trigger the CI tools to build and test. And that is going to be the continuous integration. So automatically triggering the build and test process and the iterations and feedback until the software is ready for release in a staging environment. This is what CI is. Now let's look at the other part of CI/CD, which is continuous delivery and continuous deployment. Both are CD. So this is CI. Continuous delivery means then once the software is ready for release, ready to go in production, there will be a manual process, manual approval, manual scheduling, and then it will go into production deployment. So code changes to a staging, testing, or production environment after the code build step, but with a manual approval, with a manual process. So this is dependent on the team's plans and decisions for release time. Changes need to be released. In continuous deployment, changes that pass all the CI, the build and test steps, are deployed automatically without human intervention. And of course, because there is no human intervention, this is going to be risky, and that's why it's not commonly used, not in the critical applications at least. What is more common is CI, continuous integration, and continuous delivery, releasing and making sure that it's available, and once it is reviewed or approved, then it will be deployed. A question that I get frequently is, do I have to be a developer, a full stack, a back-end, a front-end developer in order to be able to get in DevOps? And because this is very important and it causes a lot of confusion, I decided that let's go ahead and discuss it in a video. So do you have to be a developer or a programmer to work as DevOps engineer? The short answer is no, you don't have to. But let's explain the two schools of thought and the reason why there's a lot of DevOps engineer jobs that will expect you to be a developer. So based on the company, and it differs from company to company and project to project, the two schools of thought are, one expects you as a DevOps engineer to be a professional developer, so you have been a developer and then you got into DevOps. And the other one would say, we only need you to have the fundamentals of programming. So you have the logic, you know the data types and data structures, and also you can do scripting and you can do file operations, like simple stuff using code. And of course, Python would be the easiest to learn in that case. So the short answer is you don't have to be a full stack developer or a back-end developer, but you must know the fundamentals of programming. You must know how to write Terraform scripts, Bash scripting, and you need to know at least Python at the basic level. Why do you need to have these fundamental development or coding skills? Because you need it. You are going to sit in meetings with developers. So you need to understand their lingo, what they talk about. Also, you are going to write automation scripts, whether it is Bash scripts, infrastructure as code, configuration management, or automation through Python. All of these are going to be scripting skills that you will need. And also you may write scripts using SDKs. Python is one of them. So you can deal with AWS and you can deal with different infrastructures through programs that you write in Python. Very simple. This is not like when you need to learn everything about Python and become an expert. I'm talking about a 6 to 10 hours course that will give you all the required skills. So don't freak out and don't leave potential and shiny careers just because you don't want or you are scared to learn. Also, for monitoring and alerting scripts, you will need that as well. And the recommended coding skills that you need to have for DevOps, Python or Go. Python has, I think, won the deal, so now it's Python and Python. Bash or PowerShell. I would go with Bash because most of the servers you are going to deal with in the modern IT are going to be Linux. And Terraform for infrastructure as code, and Ansible for configuration management. These will be the ones that you need to learn. As DevOps evolved, we found out there is some area that has been overlooked by DevOps. And that is, once the software is released and deployed, who looks after the reliability, the performance, the availability, the uptime, the capacity planning of the infrastructure for the deployed releases and the ones that are coming up? Who's going to deal with incident management? This is not DevOps. Who's going to be awake at 3 o'clock in the morning when there is a problem trying to fix issues? That is not DevOps. So DevOps overlooked these areas, and that's why the evolution by Google for the site reliability engineering emerged or surfaced, and it has been out for quite some time now, and it's gaining more popularity. Because it looks at the entire thing as a system that needs to be reliable, and it focuses on uptime, and it focuses on a lot of other things. So let's contrast SRE to DevOps and see what are the differences between them. So DevOps focuses more on the speed than on the stability and reliability of releases. So we need to make sure that they don't have bugs, there are no errors, and they will be released more frequently. But once deployed, maybe they will be performing, maybe they will not be performing as expected. So who looks after that? Not DevOps. DevOps does not define a role that focuses on the overall reliability of the deployed systems or applications. SRE will fill this gap. So SRE will mainly look at the reliability and the performance and the uptime of releases and applications after DevOps. So what would a site reliability engineer focus on? Incident response and reliability metrics. So they will have a lot of tools, logging tools, monitoring tools that will look at service level indicators, SLIs, service level objective, as well as error budgets. So that's their focus. Root cause analysis. When a problem happens, finding out what happened and why it happened is also what the SRE should do. So this is the one that will be notified at 3 o'clock in the morning to wake up and see what the problem is and fix problems and all that. And this is usually a team, not an individual. If we contrast DevOps and SRE, the focus of SRE is reliability and uptime and performance, whereas the DevOps is the faster delivery of software and the frequent releases. SRE will be more into the operation side, incident response, monitoring and alerting, and capacity planning for the infrastructure. Whereas DevOps will focus on CI/CD, release automation, automating the process, environment builds to deploy the software on, and code configuration management, as well as infrastructure as code. So SRE and DevOps are different. Skills are different. However, the core skills are the same. You can't expect the SRE to go ahead and fix a problem in a Kubernetes cluster that is faulty without knowing Kubernetes. And you don't expect them as well that they're going to work or troubleshoot something in the cloud if they don't know the cloud. They would go into systems and find out why it happened and look at logs. So they have to know about logging solutions. They have to know about Linux. They have to know about Bash. So they have to know about a lot of things, or the common skills are the same. However, when it comes to monitoring uptime, capacity planning, and so on, these are specialized tools that are used by SREs more than DevOps. DevOps is going to focus on tooling or tools and pipelines that help developers in the software development lifecycle to build, test, and deploy code quickly and automatically with less errors and high quality. Whereas SREs will focus on keeping the systems reliable, the applications deployed, the software deployed, and make sure that it is scalable and available in terms of uptime. So they are going to use software engineering and tools in order to monitor these criteria or metrics and make sure they are up to expectations. DevOps will include CI/CD, infrastructure as code, configuration management, automated testing, and monitoring. To an extent, not the full-fledged monitoring like SRE. Whereas SRE will include things like the error budgets, service level indicators, service level objectives. That will be the focus of SREs. So SRE is a way to implement DevOps, especially in large-scale complex systems. So can there be a DevOps team and an SRE team? Absolutely. There can coexist because the focus is different. DevOps is going to take care of everything until deployment. SRE is going to take over from that point and make sure that it is reliable and up and running without any issues and up to the performance expectations. Here is a real-world example that shows how can DevOps and SRE work together. So if we have a company like Google or Netflix, for example, the DevOps platform team or the DevOps team is going to maintain Kubernetes clusters, build CI/CD workflows, support thousands of developers with the right tools to automate the process. The SRE team for a specific service or the entire infrastructure, the applications, will ensure that the uptime meets the expected percentage, 99.99 for example. It will handle global traffic. If there is any issues or bottlenecks, they will figure it out and fix it. And it will make sure that they also deployed infrastructure or applications, they will scale on demand. And even if there is high traffic, it will still keep the performance expectations. So this is DevOps and SRE. So they are complementary and they are not mutually exclusive. It's not that you have SRE so you don't need DevOps, or you have DevOps so you don't need SRE. You need both. Or in some companies, smaller companies specifically, the DevOps person or the DevOps engineer is now requested to also deal with the uptime and the logging and the monitoring and all that as an SRE/DevOps. This is all good, but as we scale, we have problems. So that's caused the emergence of what we call platform engineering that we are going to introduce next. A new concept that is evolving and being adopted right now is platform engineering. For the past couple of years, it has been a hot topic. And the reason why it evolved is because we have faced issues scaling DevOps. And also ensuring governance and standardization as we scale DevOps was an issue as well. So let's understand the issue. I know maybe this will sound or will feel like above your head at this stage at the fundamentals, but you can always come back and reference this lecture when you hear the term platform engineer to understand what it is. It might not be relevant right now. Maybe it's 6 months, 9 months down the road in your career, but come back and watch the video again if you feel it's an overwhelm at the moment. So what are the issues with DevOps? Two things. Number one, DevOps teams are getting overwhelmed. They have so many tasks they have to worry about, including building and running the infrastructure, running Kubernetes clusters, CI/CD pipelines, infrastructure as code scripts and deployment, security, as well as monitoring to an extent. And this is not limited to one tool in each one of these categories, but it could be multiple skills, multiple clouds, multiple tools that they need to work on based on the requirements from the dev team. And of course, that is overwhelming. That's the first issue with DevOps. Since they are getting overwhelmed, they are becoming a bottleneck. So they are slowing down processes, they are slowing down development teams because they can't cater or scale to the requests and the requirements and the skills they need to learn at the same time. So now the developers or development teams are being held back because of DevOps. And this is kind of contradict the main purpose of DevOps, which was to speed up and ensure faster delivery and so on. That's issue number one. Issue number two is as we scale DevOps, one of the solutions would be, since DevOps engineers are overwhelmed, let's not centralize that in one team. Let's have DevOps engineers in different projects with the different development teams. So I have application one, for example, has a group of developers, and let's say they need to use a set of tools. Then let's get a DevOps engineer or two that they work with them and they are proficient in these tools. App 2, another tech stack. Let's get them one or two DevOps engineers that can cater to these skills. App 3 team, also get them one or two DevOps engineers for their tech stack. But this becomes an issue because there is no consistency in the technology and tools used across the different teams. And there is no standardization in terms of security or even governance. We cannot have a policy that will be across because we have different teams working with different tools with different requirements, and we can't keep up on how the DevOps engineers are setting these tools. They could be secured, they could be not secured, they could be following best practices and maybe not. Of course, this will be an extra cost to the organization. The scripts and the stuff they will be using, since they use different tech stacks, the reuse is going to be minimal. And it will be harder to troubleshoot. I cannot even move DevOps engineers now between the different projects because they are proficient in what they do, but they don't know what's happening across in the other team or in the third team. So because of these two issues in scaling DevOps, platform engineering emerged as a solution to this. And basically what platform engineering is all about is, why do we have to have developers wait for DevOps engineers to do stuff for them? Why don't we build the platform that can do all the automation they need? They can build repositories in GitHub. It can build pipelines. It can do infrastructure in the cloud. It will have everything they need, and they can do it in a self-service fashion. So basically, they log into that platform, they click, and then a repo is created. They click again, and then a Kubernetes cluster is deployed. They click third time, and there is a CI/CD pipeline. So platform engineering is a discipline of designing and building tool chains and workflows that enable self-service. That is the bottom line. So this is for software engineering organizations in the cloud-native era. That's what we need. So the whole purpose is to build something called the internal development platform. That internal development platform, it will integrate, or it will have all the tool sets that are required. So for example, Kubernetes, OpenShift, Docker, Terraform, Jenkins, GitLab, Pulumi, Git and GitHub, GitHub Actions, Python. All the tools and the integration with the cloud environments is going to be ready-made. And then there is a portal where the users or the developers can log in, and then they can select, okay, here's what I need. They will take a box for CI/CD pipeline. They will take a box for AWS Azure Kubernetes cluster. They will take a box for a GitHub repository. They will take a box that I need monitoring using this tool, and it will be all done in the background for them without them having to wait for anyone to do it. That's what it is about. And now the development teams, they can self-service their requirements and they don't have to wait for anyone. That's the core of platform engineering. So the internal development platform is a self-service system that allows developers to do the following: deploy code without worrying about infrastructure. The infrastructure will be taken care of, which used to be done by the DevOps engineers. Monitor their apps with minimal setup, and run tests, stage environments or rollbacks easily. So they are doing the build and tests and stuff like that. Launch new services using templates. And the ones who are going to build this platform, the platform engineering team is going to be proficient about these tools, the security requirements, the company policy, and all that stuff. So they will set this properly such that the users of the platform, which are the development team, can work on that. So the platform engineer role is to build and maintain a reusable IDP, including tools and system that will make it easier for developers and operation teams to build, test, deploy, and run applications efficiently without having to wait for a human DevOps engineer to build stuff for them, which might be a bottleneck. Platform engineering involves setting up cloud infrastructure. So everything that used to be done by the DevOps engineer. DevOps tools, operating systems, database, servers, containers, Kubernetes, orchestration tools according to best practices. Let's look at a real world example, how the platform engineer play with DevOps and SRE? How in a big corporate? Of course, when we talk about platform engineering, we're talking about big corporates. We're not talking about a startup that has few people. However, in the job market, you might find platform engineering required for a smaller company. Basically, what they expect is they expect everything. They would expect to know the DevOps, to know the SRE part, and to know also the platform engineering part. So a company wants to deploy 100 microservices in Kubernetes. So the platform engineer, what they will do is they will build a self-service portal where developers click a button to get the following: a repository, a working CI/CD pipeline, a deployment target, which could be the Kubernetes cluster, for example, with built-in monitoring, logging, and alerting hooks. And this will make the deployment feel easy to the developers. The DevOps team will set up Argo CD, which is required for GitOps, Helm charts, and CI/CD pipelines. A common question I get about this one is, would platform engineering kill DevOps? And the answer is no. They need to do work even if they are part of the platform engineer. The platform engineer needs to know all these services, including CI/CD and how to set up the tools and all that stuff. So the platform engineering team will have DevOps engineers within because they need to be proficient in the different DevOps tools. So it could be shifting the jobs from a DevOps engineer into platform engineering team. Or it could be that I'm going to have DevOps engineers within the platform engineering team to set up the DevOps tools properly according to best practices. And maybe the development team are going to have a DevOps engineer that will be proficient in how to use the IDP, the internal development platform, and the DevOps engineer will be working on that. So the short answer is platform engineer is not going to kill DevOps. It requires the skills of DevOps engineers. So this is what the platform engineer does, and this is what the DevOps engineering will do. And SRE will be handling the monitoring, the uptime, the SLIs, the SLOs, and being on call and handle capacity planning and so on. Since you might end up being into security, and we discussed DevOps, then it makes a lot of sense to look at how we can secure your pipelines. How we can secure it from the inception of the code by the developers all the way until it is deployed, and ensuring who has the access and authorization to deal with these applications. DevSecOps is what looks after all of this. So let's find out what that is. And there is a lot of people that are interested in building cloud as cloud security engineers. And part of that is going to be DevSecOps. So DevSecOps stands for development plus security plus operations. So we have dev and ops, and then we have sec on top of that. So it means integrating security practices and tools into every stage of the DevOps pipeline, from planning and coding all the way to deployment and production monitoring. So in short, DevSecOps is security of the DevOps pipeline and the automation scripts and everything you use in DevOps. If we look at the different phases and how DevOps is going to act in each one of these, when you are doing the planning for DevOps, you have to include security requirements and threat modeling in design discussions. When coding, we need to use static code analysis tools, the SAST, to catch vulnerabilities very early. And when you are building before testing, building the application, integrating the software together, then we need to scan dependencies for known common vulnerabilities and exploits or vulnerabilities using tools like Snyk, Trivy, and Dependabot. And for CI/CD, of course, we need to automate security tests in pipelines for secret scanning, policy checks, and so on in the code. The short or the summary of this is you have to think security in every step, from the planning before the coding, through the coding, and during building, and when you are doing CI/CD testing as well. That should all include security tools to scan to ensure that you don't have backdoors in your code and you don't have any vulnerabilities in your code and so on. Moreover, when you are thinking about containers, you have to scan container images for vulnerabilities. You need to make sure that they are clean as well. When you are working on scripts infrastructure as code, you can use tools like Chekhov and Terraform Sentinel to ensure secure infrastructure definitions, and you don't have credentials, for example, in your code. For the secrets management, passwords and so on, licenses, keys, and stuff like that, you need to use HashiCorp Vault, Secrets Manager in AWS, or Sealed Secrets tools where you can store these credentials without having to embed them in your code. And for production monitoring, of course, we need to look for security events and misconfiguration or drifts. And there are tools to help you do that, like Falco, OSEC, and AWS Guard Duty, etc. So again, the message is think security in every action and every step and every technology, every code, every image you are using in your DevOps. Congratulations on finishing up the course. Hopefully it was interesting and you have done all the hands-on demo labs and all the practice examples and all that yourself in order to cement the knowledge. Again, if you would like to get more knowledge and more depth into this course, you want to get more design assignments, more practice, more hands-on labs, and also the IT tools primer that will give you a 50,000 feet view of what is Linux, what is Git, what is GitHub, what's Docker, what's Kubernetes, what's Bash scripting, and Terraform, what's Docker and Kubernetes. This is going to be available on our website, and you will also support us in creating more free content like this one at this quality for you to enjoy and for you to grow as well. This course the supplementary material can be found at www.dolphinet.com/courses/ITF-course. Thank you very much for watching and looking forward to meeting you again in future videos.